All right, welcome everybody. We should be live. Which camera am I in? Here I am. Welcome to day 3 of Imagine, our Edge Impulse Developer Day. I'm super excited. I've got with me Jan over here, Matthias down here, and I think Avi is down there. He's coming on later. Daniel should be popping in to take his spot in just a few minutes. I'm going to go ahead and kick us off with just a quick introduction and some housekeeping. Then I'll let these guys take over and show you some of the neat stuff that they've been working on, honestly, over the course of the past year, some of the things that are going to be forthcoming in the next couple of months' time, and some of the things that they talked about on day 1 of Imagine. If you already saw that, awesome. But today we're going to dive a little bit deeper. So let me just quickly get some basics out of the way. Chat should be open. You should be able to pop any comments into the Zoom chat. And I see we've got 46 attendees already in. So welcome, everybody. I do also have the hello world. Good job, Jan. You got it. I do also have the Q&A section open. I'm going to monitor both. I'll say it's probably better if you have a very specific question, drop it in through Q&A, and I will get the question moderated and over to Jan and Matthias and Daniel as they're going. The chat, yeah, let's just try to keep chit-chat in there, questions over to Q&A, but we'll see what happens. I'll keep an eye on both. We've got, I think, 5.5 hours of content. So I've got 2 coffees with me. I don't know if it's going to hold out or not. I might have to take a small break for some coffee at some point, but we'll see what happens. The sessions are 55 minutes or 25 minutes. So there is a 5-minute intermission between speakers for everybody to go get some water, hit the restroom if you need to. So if you happen to pop out and come back, Jan's already got his, well, he's in Amsterdam, so I'll let him, he'll introduce himself in a minute. But so there is a 5-minute window built in between speakers where I'll do a transition and give everyone a chance to go, get some water, hit the restroom if they need to. So if you pop out and you come back in and it's in that 5-minute time frame and nobody's there, just wait. We will be back, I promise. And there's Daniel joining now as well. Welcome, Dan.
Hey, everybody.
You missed all of my rules, but that's okay.
That's
you don't
okay.
need to follow.
You
don't need to follow any rules. Exactly. So I'm excited, and it's going to be a great day of content. We've got robotics, we've got devices, we've got Edge Impulse platform features, and I've got some prizes to give away throughout the day as well. So folks, pay attention. I'm going to sneak in some questions. As each speaker does their session, I'll have some trick questions ready to go, and we'll do some giveaways as well. With that, I'm going to go ahead and turn it over. I'll have the 3 of you introduce yourselves. Jan, you're on my top row. Do you want to go ahead and go first?
Absolutely. Hey, thanks, David. Yeah, you might have seen on the program that you would just get me and a little bit of Arun in this session, but I figure I bring my top team. So yeah, I'm Jan, co-founder CTO of Edge Impulse. I guess most people know that, but I brought with me actually employee number 1 and 2 of Edge Impulse. So and there's still a little bit of debate who is 1 and who is 2. But let's start with Matthias. Matthias, can you say something?
Hi, nice to see everyone. I'm Matthias. I'm either the first or the second employee at Edge Impulse. I joined originally to set up our cloud infrastructure, but since that moment, I've become deeply involved with our new product features. And one of them is the Eon Tuner. And right now, I'm thinking about new innovations that we're going to release to you at the next Imagine event next year. And with that said, I'd like to hand over to Dan.
Hey everybody, thanks Matthias and Jan. So yeah, I'm Daniel Sitanaika, and I'm the head of ML at Edge Impulse. And really, like, my goal is to try and build tools that make it easy for people to build products with machine learning without having to be machine learning experts. So within Edge Impulse, we have an ML team who's, you know, on the one side trying to figure out how to do amazing new things on embedded devices with machine learning that no one's ever done before. But secondly, and even more importantly, is making sure we build tools that help people work with the same degree of confidence that they would if they had a whole supporting team of ML engineers on their side. So that's our goal with Edge Impulse. And you know, that's kind of the philosophy behind all of the features that we build on the ML team. So really, really excited to be chatting with you today. I'm coming from a hotel in Atlanta, Georgia, where I'm currently waiting out a hurricane that's hitting my house right now, where my girlfriend is sheltering with a cat. So fingers crossed they'll survive this next couple of hours.
Amazing. Yeah. So we want to do this a lot less formal than, you know, our sessions on day one. So as David said, the Q&A is open, the chat is open. So if at any point during the next 52 minutes, you have a question, just ask it straight away and we'll help to clarify anything. So I have 4 topics, main topics that I want to talk to. So data sources in the Data Explorer. So what more can you do with data and how do you build that up? Our new feature that was launched during Imagine called performance calibration. Then about bring your own model. So how can you push your custom models into Edge Impulse? And then that ties all together in the Eon Tuner, because that is the way that you can very quickly iterate over all the possibilities that you have when building all of that up. And naturally, anything else that will pop up. And I'm gonna share my screen.
Yeah, you should.
Someone needs to make me presenter, I think.
Let's see here.
Oh, I got it here,
made you
so never mind.
Yeah, I made you a
Never mind,
co-host.
Sorry, I'm the CTO of a tech company, but AV is still very hard.
It sure is.
So last year, we've done a lot of really interesting stuff around machine learning algorithms like FOMO, faster objects, more objects. Really cool. But the thing that I think is most useful for people is something that you might have missed, and that's data sources and our Data Explorer. And why do you think that's important? Well, it's because it enables active learning. So if you set up a project once, right, you basically do one iteration of your project, you collect some data, you train a model, and then you deploy it on device. I think you're missing out, because once you realize that you can continuously learn while your device is in the field, so continuously add more data, iterate over these models, make sure that your model gets better over time, that adds a ton of value. And that's what data sources enables and the Data Explorer enable. So I want to do a quick roundup and show how absolutely trivial it is to use data sources to populate your project and then automatically retrieve new data, update the Data Explorer so you can see kind of what this data looks like, and retrain your project in one go. So if you have a camera trap that writes data to S3, or you have a system that collects audio and sends it to Google Cloud, get that data straight into Edge Impulse, see data flowing from the get-go, adds a ton of value. So what I have here is a small S3 bucket with some photos of me and some photos of not me. So this data is sitting in S3 right now. Here I've chosen to have a folder per class, and let's add the data. So I go to data sources, add a new data source. So stuff that we support natively is Amazon S3, Google Cloud Storage, anything else that has an S3 compatible API, which is a ton of stuff. And then this is an enterprise project. So here we can actually choose an upload portal, which in essence is just an S3 bucket, but with a fancy UI, as you can see here. So here I say, well, I want to infer from my folder name, right? So I have data that's in the Jan folder that will automatically be Jan. And then I can set posting actions. So stuff like recreate the Data Explorer, retrain my model, create a new version, create a new deployment. So I can say, hey, let's actually go build a binary for the Arduino Potenza H7 with my updated model in there. And finally, I can say, even like if all of that is done, send me a notification. And what you can do with that is actually get this new binary, including the complete optimized model, and send it, for example, of your device management solution back to device. So really powerful. I don't have a model here yet, so I'll just do the data explorer. So create a pipeline. And we can run this either from the UI. So I have a button here, run pipeline now, but I can also run it from code. So if you have whatever, like the camera trap example, if you have a camera trap in the field, you probably know when you add new data. So if you want an example in Python, okay, cool, get your new API key, just throw this into that application, and this pipeline will start from that point. And maybe Dan, you want to say something on why active learning is so crucial while I run this pipeline?
Yeah, absolutely. So really, when I think about machine learning, I think about feedback loops, this idea that when you're working with a project, it's not like you do everything in one big kind of waterfall development process. You don't go out, collect a perfect data set, train a perfect model, deploy it to your device, write an application, and then be done with it, right? Software engineering doesn't work like that generally, and machine learning especially so, because we're so dependent on kind of learning about our problem through a data set. Like the data set kind of encodes our representation of the problem and the situation that we're trying to model. And then the model that we create is dependent on the data set. It's a little bit different from a sort of traditional programming model where we've got like some theory that we know about a situation, maybe like something based on the laws of physics or something like that, and we can write a little algorithm by hand and prove that it works. Instead, it's this kind of interactive flow between data set and modeling and evaluation. And so what active learning is this idea that basically we're going to kind of bootstrap ourselves, like we're going to make use of whatever little data set we've collected to begin with, and whatever model that is partially functional that we've trained. And we're going to use those together to provide a way for us to more easily access better data, which in this case, it comes through improving the experience of labeling, making it easier to label data and make it easier to notice data that's been mislabeled. Data collection is always the most expensive and complicated part of a project, right? Like with tools like Eon Tuner, training a model is as easy as just trying a lot of combinations using some automation. But the tricky part is going out there, collecting data and making sure that the data is labeled correctly. And so if we can build tools that allow the cost of that to go down and the time it takes to go down, that's going to make it massively easier to build a successful project.
Yeah. So as an example, and then I'll run to the chat question. So as an example, so we ran this project now, and we have our initial 100 labeled items sitting in here. So you have really nice clusters already. So this is the data explorer. This gives you this one view overview of your data set. It's a bit more complex than just TSNE or PCA, because it actually uses neural network embeddings to understand the structure of the data better, rather than just raw pixel values. But let me show you what you can do like after this initial labeling. So, you know, here, all this data that's labeled Jan, that's all pictures of me in my old living room, sitting nicely in the cluster. A couple of things like falling in the middle, but in general separates already very nicely. So what we can now do is say, let's add some data for which we don't have to label yet, right? So I throw in a bunch of photos. I throw them in here because I don't have a label, and re-trigger the data source. So what this will now do, and I think this is sort of the magic of iterative development in machine learning, is that we can use the context of these 100 items that we already labeled, for which we know the label, to get an idea of actually what this new data is. And here we add 7 photos, but you can do the same with like 1,000 photos, and then use the inherent structure of that to very quickly label that. So once this is running, And so we can do this on really large data sets. So for example, saying, hey, I label 100 images now and then throw 10,000 in. Then just looking at, hey, what kind of clusters do we have? And from that, so we're working on a couple of things around unlabeled data, but can you identify the most important items to label in your data set, right? It's probably not all of these 1,000 images that you throw in are equally interesting.
The
So,
thing
for
that's really
example,
cool
here-
about this pipeline, I think, is that once you've set that up, that's just
Yeah.
fixed for your project now. So like when you add more data in the future, you don't have to go through this process of setting it up again. You've kind of defined a piece of infrastructure, which is really awesome.
So, and here's an example. So here we have all of our data now in our data sets, right? And here all in gray are all the new items that have been added. And these are all within the cluster of Jan. And it's actually so close that I can kind of sort of trust here that all of this is me. So we can actually start labeling quickly, very quickly, and even do it automatically. We also find stuff that is super close together, right? So here we have a photo that we have labeled, and then we have another photo that we didn't label, but it's almost the same photo. And because it actually understands the inherent structure of the picture, because it uses a neural network here, we know that that is all the same. So rather than just having to label all of this by hand, we just need to, confirm what we see, stuff that is really close together. Here, not so much, but we'll automatically label, so we can do whole clusters of stuff in one go. I think it's super powerful. It's not something released just, but actually already 6 months ago. But it's such a powerful concept. And we see our best customers, like customers actually deploy this at scale, use this super effectively to continuously learn about stuff that they've been doing. Then I have a question for you here, Dan. When you retrain models on different data sets, like how can you evaluate the delta in performance to evaluate the difference of the data sets? And maybe this ties into Perfcall.
Yeah, I really like this question because it's a smart question. There's this, the only tool we have in machine learning or any kind of data-driven process like this to evaluate our performance is our data set itself, right? Like we want to understand what is the performance of a system, like an algorithm we've built at maybe predicting something on a given data set. So we have to use a data set to do the evaluation by going through and understanding how the system's performing on each sample, for example, and coming up with like an accuracy metric or something like that. But the really valid question is, if we're adding stuff to the data set, how do we evaluate it? How do we evaluate performance? Because we're changing the data set, and you use the data set to evaluate itself. So how does that work? Typically what we're doing in an ML workflow is we'll split off part of the data set as a test data set or validation data set, and we'll use those set aside, held out sources of data to do our evaluation. Because otherwise, if you're evaluating on the same data you use to train the model, you're not necessarily going to see whether the model works on unseen data, which is the important part. So what we've got to do when we add new data to our data set, it kind of depends a little bit. So in theory, like it might make sense to keep your data, your test data set, your held out data the same. And then if you get new data, you can train a new model with the new data, and then you can look at what the performance is like on the held out data, and hopefully it improves. So in theory, that's something good that you can do, and you've kept the data that you're using for testing the same. So when you compare between different models, you're going to see that the results have either got better and worse, or worse, and you can trust it because it's the same data. However, as you build a data set from the beginning of a project, you might start out with very little data, and you maybe take away 20% of it, and you've got that as your holdout data. But when you're adding new data, you're going to be running into new, diverse sort of examples of different things. So like Jan's pictures there in this data set, what if Jan moves to a new apartment and takes some new pictures there, and those end up in the data set? We need to be able to evaluate that the system works well on that new kind of data too, not just the old kind of data that was originally in the test data set. So we need to really make sure that data is in both of these data sets. So I think the answer really is that sometimes you can evaluate the model or a system with a static set of data. But if you think that by adding more samples, you're going to be changing the distribution of your data and changing the diversity of it and changing what's represented within it, it's really important that that representation needs to also be captured in your test data. So I would say that over time, what you really need to be doing is as you capture more data, you can you need to make sure that you sort of resample and take data and put it into your testing data set. Essentially, the best way to do that is just to resample your data, take another random sample across all of the different subgroups that are within your data set. And then as you scale, you can use that to evaluate, and it's going to be slightly different. But as your data set gets bigger, and the amount of diversity that's represented within these samples gets bigger, it matters less that you're, maybe having one sample and not another, because in aggregate, you have a big representative sample of data, and your data set is hopefully big and representative too. So it is quite nuanced. It's something you should be careful with, but the key thing is to make sure that your evaluation data set is composed of data that is representative of the real world, because that's what you're using it to test. It's like, does this data set represent the conditions I'm going to see in the field? And we'll come into this in performance calibration next.
Cool. So this, to reiterate over the question that I have from AB, it's like, hey, to do this operation, the Data Explorer, like, do you use a model? And yes, that's what we do. So we use, to generate these features, we use a neural network. And we don't run it all the way to the end, but rather we cut off the last layers before we do the classification. And that's what we use to create these visualizations. So what you kind of see is what the neural network would think of this data just before it classifies. And we can do it in two ways. So we can either use a pre-trained model. So here we don't have our own model trained yet. So then we use MobileNet to actually label the data, and that generalizes very well. If you have your own trained impulse, you can also use that. In that case, it's going to be a bit more local. And typically what you see, typically what you see is that it's really useful to kind of get a quick look through MobileNet. And then if you really want to find these outliers, stuff that the model gets really confused about, using your trained impulse to go a bit deeper, although you're standardly a bit overfitting naturally, because you are tuning these parameters a bit more. And then a question from Norik. I have a question. When adding a custom, the other one from Kevin, I'll answer the Norik question during the custom learning block section. Can you use a foundational model to start building your model and adding your own data? And the answer is yes. So we have transfer learning available for keyword spotting, transfer learning for image classification, transfer learning for object detection. And with Bring Your Own Model, you can put your own transfer learning stuff in. So for example, YOLO v5 with frozen layers and only retraining that. And yeah, let's actually talk about that section. No, let's talk about performance calibration first. Can we keep to 10 minutes or so then? Just so we stick on time. I have a project here even for you.
We're good on time, Jan. No worries. I see.
Yeah, we have a lot more to talk about.
So, oh well, there's a lot more. Okay, then Dan, talk fast. Then Eric, I see you have joined. Yeah, your session is in a couple of hours still. What I'm going to do is I'm going to move you over to an attendee and place you over in that queue, and then Eric, I'll promote you right back up to a host when it is time. But I'll DM you. Go ahead.
Right, Dan, take it away.
Awesome. Yeah, thank you, Jan. And so we're talking about evaluation with data sets and representative data. And if we think about what does your data set look like if you're doing something like event detection, where we're monitoring a stream of sensor data and we want to understand when a particular thing has happened. Typically, what we're going to do is collect a bunch of sensor data and imagine that being a load of samples, and some of the samples contain just kind of things we don't really care about that much, just normal signal in normal operation. And then other samples will contain examples of things that we do care about. So that could be like a particular fault that a machine is having. That could be a particular sound that's occurring. And in this case, in this example, it is a keyword that's being said by a person. So in this example we're looking at, we've got a data set of people saying the word no, people saying the word yes, and people saying other random words, along with a bunch of random noise as well, that just kind of atmospheric environmental background noise. So when we train a model on this, if we go over to the transfer learning block there on the left, so we can see, like, when we're evaluating a model that's trained to do this type of event detection, what we're feeding in is these lovely curated samples that we've got, where we've got maybe a clip of audio with somebody saying the word yes, and the word yes is nicely aligned in the middle of that clip, and there's no other stuff going on in that clip, maybe a little bit of background noise, or we have nice clean clips of background noise or of other words. And when we look at this confusion matrix here, what that's showing is how our model is performing at basically the best case scenario, which is we're feeding in a nice clean example of the word yes within the middle of a window, and the model's giving us a score about what it thinks that could be. But in the real world, data isn't nice and clean like that. If you think about when we're running inference over a stream of audio coming in, what our model's job is and what our application's job is it's going to go as fast as it can. It will take a window of that stream and run that through signal processing and then feed it into a model and give us an output. And maybe it can do that once every 50 milliseconds or something, depending on what processor you're using and how big your model is and all that stuff. So what we really end up with, we've got this, you can kind of see an example on the right there, a long input, a big waveform, which is representing a bunch of audio that's coming in. And we're at any given time looking at like a small window of that and trying to decide, does this represent someone saying the keyword, or does it represent some other kind of thing? And what we've got to do, we then end up as the output of our model is this series of scores for a bunch of overlapping windows along our input, and they're coming in, you know, hopefully near to real time. And our job is to figure out, when has an event actually occurred? When has someone actually said the word yes or the word no? Because if you imagine we've got someone said the word yes and it's in the waveform here, as our window goes across it, we're going to see like, all right, nothing, 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 nothing. Yes, 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 nothing, 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 nothing. And so that's kind of this stream of outputs. And what we really want to know is, when did someone say the word yes, right? We don't want to see 10 different instances of the word yes being detected during a particular period. That's not very useful for our application. We want to just know, when are we confident someone said the word yes, so that we can trigger something in our application, or, you know, do some useful task. So what we need to do is run some kind of post-processing filter on this intermediate output, on all of the outputs from the model over time. And that filter basically will look at like maybe the average score for each class. And when the average gets to maybe a certain threshold, we consider that we've recognized someone said it. And so the problem is, typically, if you're a developer working on this stuff, like, you would have to write this post-processing filter by hand. There's some pretty standard ones you can use, but you'd have to write that by hand and then come up with the right parameters for it that tune it so that it works well on your particular data set. And traditionally, that's something that's done in a very hand-wavy way. We might deploy a version of our model and our filter to a device with some arbitrarily selected parameters. and we test it out by hand and give it a try, see how it works. If it seems to work okay, then that's great. If it doesn't, we'll tweak them a little bit and try again. And that's the kind of basic iterative process, but it's not really very scientific, right? And it's not very measurable. It doesn't give us a good insight into how things are actually performing. And it turns out this stuff is really critical. The filter parameters that you choose have a massive impact on the way that your model is going to actually perform in the real world. And the model itself, like the quality of your model itself, which is dependent on your data set and the model architecture and the devices that you're trying to target, that has a huge impact as well. So it's really, really, really important to understand and quantify how this stuff is working in the real world, because when you deploy your model to the field, the worst nightmare is that you've spent all this time and money developing a model and application, and then you find out that it doesn't work once it's got into people's hands, where it's kind of too late. So what performance calibration does is it lets you try this stuff out before you've deployed the model into the field, and it lets you quantify how it's performing so that you can have confidence in what's going on, how it's going to work in realistic conditions, and what the correct kind of filtering that you're going to do is. So you can see the UI here. What we do when we start performance calibration is we tell the system a little bit about what we're going to expect. So we've got maybe certain labels that we care about and certain labels that represent background noise. And then what we can do is either create a simulation of real world realistic audio, and in the future other types of data, or we can upload a sample of audio that's been captured from the real world and labeled. And so what we do to create synthetic data is we actually can pull data from your test data set and overlay it onto realistic background noise to simulate a real audio clip with people saying different words at different times. Or if you upload your own audio, it could have absolutely anything you want in there. And then you upload with it a labels file, which indicates which parts of the audio represent which labels. And when you've either uploaded your clip or we create this simulated sample, it ends up in the UI like this. And what we do is run the model across it, and that gives us a raw output. And then what we want to do is automate the process of testing out lots of different post-processing algorithms on it. So we'll try out loads of different combinations of algorithms and filters. And the problem is there's essentially like an infinite variety of different parameters these filters can have. So we can't try them all. It would take more time than there is until the heat death of the universe. So what we need to do is something clever to be able to explore all these options and give us the kind of lay of the land of how the different options perform. So what we do is actually use a genetic algorithm, which is an algorithm that's sort of intended to solve this type of problem where we've got to explore a giant space in a small amount of time. And the genetic algorithm basically comes up with different values for the post-processing filter, and it applies them to our model's raw output, and it figures out whether they perform well or not. And essentially it creates a cohort of these possible filters at random, and then it takes the ones that work well and combine them together, basically breeds them together and creates another generation. And over a number of generations, we get better and better filters. And so what we can do is plot the performance of these filter configurations on the chart. So this is what you see here with these purple dots. Each one of these represents a particular post-processing filter configuration that has a different set of trade-offs between false rejection rate and false activation rate. And those are the two key metrics for any kind of event detection. They basically represent the trade-off between precision, which is how sure you are that any one thing is correct, and recall, which is how good you are at finding all the instances of that thing. So a model with perfect false activation rate would have no false activations at all. So it will never think something was a word when it actually wasn't, for example. So if I say the word no, it's not going to think it was a yes. Or if I say a weird random word, it's not going to think that I said one of the keywords we care about. But that gets traded off against a false rejection rate, which is how likely we are to say something isn't the keyword when it actually is. And there's a continuum between these things, because the more strict you get about not having false activations, the more likely you are to have false rejections. So we get to pick the trade-off, and the right trade-off is different for every single application out there. In an ideal application, you'd have no false rejections and no false activations. That would be like the perfect one. So the blob that's towards the bottom left in this case is getting close to 0 for both, which is really nice.
Could you go to the end of your point then?
Oh, sure, yeah. So
very strict moderator here.
The key thing here is that you get to pick a trade-off between these values, and rather than doing it by randomly trying out different values and kind of eyeballing it and hopefully it works, what we need to do is be able to pick this in a quantified way and understand exactly how it's going to perform in the field. And that's what performance calibration lets us do. So yeah, it sounds like in the interest of time, I need to stop talking about it. But really, if you're developing an event spotting system, if you're trying to identify an event of some kind, you need to be doing something like this in order to be sure that it's going to work properly when you deploy it. And so I'm really excited that we have this capability now in Studio.
Cool. Yeah. And just to clarify, if you select the post-processing tuning here, it will actually be as part of your model. So if you do run impulse on your embedded device, post-processing will already run, and rather than raw probabilities, you will actually get events out. So really useful, awesome, really awesome tool. And I think, yeah, it's critical for anyone doing anything with event detection on embedded systems.
Yeah, this is right now available for audio, but it's going to be coming to all
yes.
sensor data types.
Cool. All right, let me talk about bring your own model. So we can only build a subset of all potential models, right? We can provide templates, we can do some transfer learning models, etc. But every day, new models are being pushed to GitHub. Being published in the scientific community, we can't do everything, ourselves. So for that, we have now bring your own model, and bring your own model is a set of loosely defined specs, in essence, to bring a custom model architecture or custom transfer learning model into Edge Impulse. And let me give you an example. You can search for bring your own model. So we have examples of basic Keras and TensorFlow model. Works really simple. The only thing you need to specify is where can I get my data, and your epochs, your learning rate, and your out directory. After that, you just write your model exactly in the same way as you would do it normally. You can use the tools that you use normally, so weights and biases, MLflow, etc., to write all of that. We already give you the data in the right format. So we just give you NumPy files with features, so you don't need to care about feature extraction. We have a really nice CLI tool to get that data in. I'll show it in a second. And it integrates nicely with all the rest of our tooling, data sources. So if there's new data and you want to get it locally as a data scientist, you just run our CLI command and you get that data in. It's, in all fairness, as long as you have a training pipeline that can output a TensorFlow Lite file, it is trivial to wrap that out. So for example, our YOLO V5, which is a pretty complex model, right? Our whole YOLO V5 training script actually fits in a bash script. It's just convert the data into a format that YOLO V5 expects. Train it, so here we actually do some transfer learning over it, and then finally convert it to a TensorFlow Lite file and write it out. After that, everything works as it would normally do in the studio. So you can retrain models this way, which I think is actually a really good benefit, because if I would be a data scientist, every time new data is there, I don't want to press a button and say, hey, run this in SageMaker again. And we'll handle the deployment for you. So I had this question from Norik, say, hey, if I add a custom training block, will this model code be generated, or should I write it all down in C++? No, we'll handle the deployment step completely for you in the same way as we do for our own models. Now, one of the things that this enables, and I think it's really cool, just say to Nadine, can we make segmentation models? We're limited to the stuff that we have support for in the studio. So object detection, image classification, audio, etc. But we don't have UI in the studio right now for segmentation models. So that's something we don't support. To make it easy to build these models, or say, hey, actually, or what this enables is also a new feature, which is edit block locally. So this replaces the IPython notebook exports that we had in the past. And that also was a bit of a pain in the ass, because it was a separate training pipeline from what we used internally. So it broke pretty often. It also didn't support a whole bunch of features that we used internally. For example, object detection models were never supported by this workflow. So what you now do, if you do edit block locally, you will get a zip file, and that zip file contains our training pipeline. So all the code that Dan and his team write on a daily basis to enable training of models in Edge Impulse, you have now access to. So that includes all the model types that we have, including FOMO. And the nice thing is that you can just modify it. So let's take a look at what is in a package like this. So I'm gonna open it up in VS Code. Do I trust it? Yeah, I trust these. So what is in the package here? So we have a README file, so that contains all the instructions that you need to run this model locally. And it has a train file. And yeah, it's exactly the same stuff. So you have a data directory, epochs, and your learning rates. And then we already pre-populate the complete setting that you had before. So we had a fully connected model sitting in here with 20 and 10 layers. And now the cool part is that you can just run this locally in the same way as we run it in the studio. So build my block. And train my model. So, same stuff as we had before, converting, and that was it, running my training pipeline locally. So if you have something in Studio that you want to run here, run it that way. If you want to get data, new data from this project, have our new Edge Impulse Blocks runner. Synedit, machine learning block, create a new block, and grab some data. And this automatically gets the new data, already runs signal processing, it updates, it runs the DSP block if needed, if you've added new data, splits it automatically in a train and test set for you. So you can't screw anything up here. And now we have the new data.
I'll find a way to mess it up.
Now, why is this cool? So there's a couple of things you can do here that you can't do in Studio today in terms of expert mode, for example. So we have this button in Studio to basically give you a Keras mode. But stuff you can't do in there is install Python packages. That's something you can do here. If you need another package, awesome. Throw your dependency and requirements to TXT and we'll get it. If you want to do something unique that we don't really have supported, like special data augmentation steps, awesome, do that. This is just normal Keras code that we have all in here. So really powerful way of modifying the stuff that we have and really powerful templates, including Keras, PyTorch models to go build something yourself. If you haven't seen it, the talk from Weights and Biases on day 1 actually goes into detail on how you can use our template. So download your block and then run sweeps. So Weights and Biases idea of kind of going over all possibilities of your model and run that so in the normal data science tooling that you're normally using. So really interesting. One cool thing that we've added as part of this as well, I won't show it because we're a bit short on time, is that we have a new API. And that's the latency memory information API. So this is a Python example where you post your trained model, and then we will tell you how fast it's going to run on device and how much memory it's going to take. So that's something that you can go track in Weights and Biases or MLflow as one of the constraints on your model. So if you have a model that's going to be too big, you can just like drop it from your search space straight away. The last thing that I want to put some interesting information on is we support scikit-learn models now, and those are not neural networks. But what we do here is one of the absolute most coolest technologies that I've ever seen is that we use a technology called JAX. It's a Google project to convert the inference function. So here the minimal predict prop A function from scikit-learn's logistic regression model, compile that Python code to a graph, compile that graph to a TF-Lite file, compile a TF-Lite file with Eon compiler, and now we have that automatically running with hardware acceleration on your embedded system. So mind blown. Take a look at the code. It's really trivial, and go try all of that out. That's bring your own model, and now I want to hand it over to those object detection models for TensorRT deployments. Not at the moment, but we are working on fixing that as part of our. We had issues with MobileNet SSD back in the day, and that's why we disabled that. But now that we have FOMO and YOLO v5 support, we're going to go bring that back for TensorRT. And yeah, I'm going to hand it over to Matthijs to talk about the new stuff that we have in the Eon tuner. I think you can steal my share button, Matthijs.
Going to try that right now.
Yeah, you should be able to.
You will desktop one, share.
We'll see what happens.
Oh no, it wants me to grant access.
Shit.
Again. Shit.
It should actually work. Oh, did he drop it? He's gonna. Well,
Matthijs needs to reconnect.
Yeah, that's okay.
So there's
no worries.
So just
That
as
was-
a recap, so what is the Eon tuner? So the Eon tuner is our AutoML pipeline. It works best in all fairness if you treat it as an engineering tool. So you've done some initial work on your model, you know what works, but then you're not sure. Like, okay, do I need filter A in place of my DSP block? Do I need 2 or 3 convolutional layers in my network, etc.? That's the kind of stuff what the Eon tuner can help you with. Yeah, Matthijs, go ahead.
Yeah.
Can you see my screen now?
Yep.
Perfect. Yeah, so a year ago, we launched the Eon tuner, and what we did is basically help you find correct configurations, interesting configurations for your model. I'm looking here at the data set that contains data of my cats and some of my other cats. Basically, we have 1,500 images. Now, what traditionally the Eon tuner would do, it would it would search in a very big search space of different models. For example, grayscale models, color models, transfer learning models, and also regular convolutional models. What we'd allow you to select the dataset category, your target device, and time per inference, because that widely varies between applications. Some applications can take a long time for inference. Some other applications need to run very quickly. But what this wouldn't allow you to do is to add more details to these constraints. For example, if you're targeting a device that only has the grayscale camera, then you couldn't tell the Eon tuner, I don't care about all these RGB models. Now, with the new Eon tuner search space feature, you can do that. What you see here is the default search space that we would be looking in beforehand. What you see here is that we are going to try 2 DSP blocks, a grayscale one and an RGB one. Now I can actually remove the RGB model, and the Eon tuner will only search for grayscale models. Similarly, I can decide that I only want to search for transfer learning models. And by just removing the whole section for the convolutional models, from that moment on, it would only search for transfer learning models. So for example, if I now do this, it would only search for transfer learning models using color RGB models. And for that, you can see the results that I've ran previously here already. So you see now we're only searching MobileNet, transfer learning models, only in the, only RGB models. And we could refine this further. For example, if you know that your device only has a 160 by 160 resolution camera, can remove all larger models. And I think this is really cool and helpful for showing more more useful search results that are specific to your device. And you can take this a step further. When I've been working on my own applications, developing my own models, what I would often do is over time, I would learn which models will run well for my application, work well for my application, but it would cover a range of models. I would learn details like, for example, I need a color model, and I could have 3 or 4 layers in my model. And as I would collect more data, I would continuously try all these variants manually by adding them to my impulse. Now, instead, what I can do is add constraints like this to the Ewan tuner, and then with one click of a button, I can retrain all these models and find out how my application performs now that I've added some more data to my data set. So that's pretty cool. And together with that, just looking at the clock, I need to be quick, I think. We've added some more cool possibilities to the Ewan tuner. For example, the custom ML blocks are now also supported in the Ewan tuner. And that's pretty cool. If you look at this project here, you'll see that the highest accuracy we are currently obtaining is 87%. So now what I have here is another project, same data set, where I'll show you how to set it up from the start. It's pretty easy. So I will go to a blank search space, and I'm going to add an image input block, DSP block. And now what I can do is, you see here at the bottom, there are these custom ML blocks that are in the organization that this project is in. So like this, I can very simply set up a search space, searching in the image space, and only trying out these custom transfer learning blocks.
So these are blocks that you've created using Bring Your Own Model, right?
Exactly, yes. In this case, cool. I've created 3 blocks for EfficientNet. So that's quite a powerful model. And here I already have the results for that. Let me go to the, it's already on test set accuracy. So you're seeing this is compared to the normal transfer learning blocks, the normal MobileNet blocks. These are getting crazy accuracies because suddenly we are hitting 100%. Of course, important here is to remember that these models are also very large. So this doesn't mean that our default blocks suck. These are just very large models, but this can be very useful to see these accuracies, for example, to just know what theoretically is possible. Say if you won't get any good accuracy here, then there's no point in trying to get the resource usage down. It's not going to work.
So a really interesting thing. So what we have for DSP blocks, so you can add custom DSP blocks here too. So if you have, and the parameters that you select there, you can also configure in the tuner. And yes, very soon we'll also have parameterization of custom ML blocks. So now Matthijs needed to add 3 different EfficientNet blocks, the B0, B1, and B2. But in the very near future, we will be able to also basically say, hey, we need a drop down in the UI to select which version of vision that you want in here. And then you can just like configure that in a tuner in one go.
Exactly. So here I have, to finish off, I have an example of custom DSP blocks. This is our health reference project. What you see here, if you look at the impulse design, is that we are using 2 DSP blocks. That is something, and one of them is a custom one. 2 DSP blocks in your impulse is something that from now on we will also support in the EUN tuner. And that is pretty cool, because if you look and memorize the model accuracy here, we see in our reference implementation we are at 85%. So now we're going to try this out with the EUN tuner. Same idea as previous project. I can easily just go to a blank impulse. I can add an input block. I can see here these custom DSP blocks. I can add 2 of them. I think this is pretty much what we had there. I can add a learn block, which is probably just this one. And then I could save this. I could run this. And now what you see is that we already found a model with an 89% accuracy on the test set. So quite easily, we got ourselves another 4% of accuracy by just searching for models. And then this is even without really fine-tuning the search space even further to zoom in further on what the good models are. So I'm quite confident you'd be able to find a few more percent here. And I think that's my that concludes my what I wanted to show you. I think we have 2 minutes for questions still.
I just wanted
questions
to
in line,
say
yeah.
it's really cool how you can then basically, it gives you another way to use your domain expertise, because if you say, hey, I think these ranges make sense for these parameters, or for, you know, maybe the input resolution of an image, if you know there's some fine detail we need to look at, you can add that to the search space. So it's another tool you can use to bring your expertise at solving this problem.
Yeah, I think, and and this work, the better this works, this works better the more you understand your data, right? If you look at PPG and we know actually, oh, probably the filter needs to be around 10 Hertz because that's, you know, probably the fastest we can go or whatever. This kind of stuff that helps a lot, and it just helps you run through all of these assumptions in no time, including all kinds of custom stuff. And with that, I think we're at time, so I'll hand it back over to David. Thanks to Dan and Matthijs. Some really cool stuff. All of this is available today in Edge Impulse. So go start hacking on stuff.
Yeah. Thank you, Jan. Thank you, Dan. Thank you, Matthijs. Incredible stuff there. And like you said, so all of that is already deployed and available in Studio, correct? And that is for all the users?
There's some limitations on the tuner and on the performance calibration side, but all the basic flow you can go through as a free user.
Yep. All right. Well, thank you very much, guys. Incredible stuff. I know you've put a lot of work into that. So I'll go ahead and have you guys drop out. We're going to take just a quick moment by Dan. And I'm going to bring Konstantin Krasiun into the conversation. He's going to be showing off some of the cool work that his organization, Zalmatech, does using, well, they use all kinds of hardware, but the project he's going to show you today is going to be one that they built on a Jetson Nano. So Konstantin, let me find you in the list, bring you in. Looks like it's going to bring him back now. Make him a co-host. And Konstantin, I can see you. I can hear you. Hello and welcome. Thank you for taking the time. I know that it's your evening there. I'm going to give you a moment to, of course, say hello and introduce yourself and the type of work that Zalmatech does. But I just wanted to very quickly say I appreciate it because I know it's your Friday night.
what better way to spend it than with friends? So thank you for having me, and yeah, thank you so much.
All right, perfect. Well, let's do this. We've got about 25 minutes or so for you to go through your materials. I'll turn it over immediately to you. If you want to say hello, give introduction, and you can take it away. I'll monitor chat for any questions and sort of just moderate them and filter them through to you as we go.
Sure thing. That sounds perfect. I'll start sharing my screen. Just give me 1 second because I have the slides and everything in here.
Yep. It looks perfect. It's there. I can see it.
Perfect. So yeah, I'll, as you said, I'll present recyclable materials sorting with NVIDIA Jetson Nano.
Yep.
But before that, as you said, let's for a few seconds tell who I am and what our organization is doing.
Yep,
so
absolutely.
Yeah, of course, Konstantin. I have been building electronics for the last 15 years. So a few years ago, I founded my own company to carry on this. It's called Zalmotech. And we offer hardware prototyping services from Eastern Europe, Romania. Of course, given our country size, we decided to go global from day one because it's a very small country. So we've been focusing on IoT-enabled products. And of course, when you're building IoT-enabled products, you end up doing computing at the edge. And that's what we like most. And this interest and our efforts earned us the spot in the Edge Impulse Expert Network. For that, we thank you so much. Just like a quick overview of our process, of course, we enjoy challenges and we take any project from sketch to prototype, let's say R&D in the middle. And after we complete this recipe, we give it to a manufacturing company that after that takes it to scale. So we very much enjoy this process of prototyping. And as you said, we like to play with a lot of development tools, be it software, hardware. And just to give you an example, our projects are so varied, and we do everything from wearables to industrial robotics, retail automation, like vending machines, cybersecurity, educational kits. They might not seem completely not related at all, but actually all of them have one thing in common. They are using embedded development and of course some sort of computing at the edge. And this leads us to the project that we posted on the Edge Impulse Expert Network, and how we found out about the Edge Impulse and the benefits that it offers for this machine that automatically sorts recyclables. Recycling still a problem in our modern society, and given the current other issues, a bit lower priority than others, but we do have to address it. For example, here in EU, there's a target of 50% for municipal waste recycling, and not meeting this target is associated with sanctions. And sadly, our country is still kind of low on that quota. And because why is that? We lack the infrastructure to collect it, sort it, and deliver these recyclables to the factories that could repurpose these materials. So it's a sad thing. Authorities they would rather be budgeting the sanction than doing the infrastructure. And that's why private companies are trying to do the best they can. Us, the people, are trying to do the best they can. My friends, they all like to try to recycle, to sort them, but all these efforts have to be coagulated in some kind of infrastructure. So we were amazed when we were approached by a client, large retailer of furniture, that wanted us to create a prototype for collection and sorting of recyclable materials to put in their shops. They also have restaurants, and they wanted to deploy this vending machine first thing in restaurants, and after that in other areas. You probably have seen this kind of machines that I'm speaking of around malls, other places where a lot of people gather, and it's quite funny they're actually called reverse vending machines, because rather than you getting the product that you pay for, it's the other way around. And so they're not vending machines, but reverse vending machines. And most of them are like the ones you see in this picture. They are with a logo or something that you can recycle only plastic, glass, cans or something, and you have to put it in the right box. But as technology progresses, others have been starting to appear that you can actually put all sorts of recyclables, and they go in the right box. They get sorted and put it automatically behind the curtain in the perfect location. So we had to create this prototype for the local market, because here there are some constraints and different aspects that were not available for other machines that are already on the market. For example, here in Romania, we have very large water bottles. Everybody buys bottled water that is 5 kilo, 10 kilos, so they are quite large, and they actually don't fit in this kind of recycling machine. So this was one of the client's constraints. Other than that, the actual size of the machine had to be perfectly for their size of the restaurant. So with this in mind, we started to prototype. We started to sketch, and to accommodate this type of recyclables, the size, and we started to think how we're gonna sort them. So for each category, we had a bin where it could get sorted, but we noticed that although we do like hardware and we do like electronics a lot, we're mostly software people, not so mechanical in nature. So we had to talk with product designers to see how we're gonna drive them, all these categories. And for each one, we had a removable container, and the actual recyclables were coming in on a conveyor belt, and they get sorted out based on their specific type. And the desired recyclables were plastic, glass, aluminum cans, and others if we cannot decide what it is. So also there has to be only one port to accept the materials. So the user can come with a bag of assorted stuff and just put it in only one port, and they get automatically sorted, as I said, behind the curtain. As I said, we were software people and playing with electronics.
Oh my
and,
goodness. Holy cow.
Yeah. It got hard and hardcore very fast. Let me tell you, welding is not soldering. We thought it was so close, but we wanted to do the whole thing from scratch. It's incredible how much mechanical work is required to create a vending machine. And but yeah, it was a enlightening experience, and we have much respect for vending machines right now after we did our prototype. And we did a lot of mechanical testing for each part, for how we're gonna drive the recyclables, testing motors, everything. And after we had some good idea of how to prototype the module itself, we went to electronics, of course. Let's now control them and sort the things. And let me tell you, we had another shock here. There's no plastic sensor on the market for glass. For metal, let's say you kind of have capacitive sensors that can detect them. If you put something on metal, you automatically know that it's metal or not. So what about plastic, glass, the rest of the thing? So we had multiple sensors in an array and combined their readings to kind of make sense and find differences in their response to distinguish what we're actually recycling. And we ended up with a combination of inductive, capacitive, optical sensor, and it was around 6 or 8 types of sensors that we found that were receptive, and we could match them up in an array to find the difference. And with much testing, this was getting us an accuracy of 70% with every type of recyclable we were putting there. Not bad, but of course we had to increase it. And with this setup, when you only have these sensors and you're not using anything else, the accuracy will never increase because it's set up. After you have this type of sensors, you write the programming, you read them, you'll never get anything better than that. And we know we had to do better, so that's why we searched for around and found the Edge Impulse platform. And we were using the NVIDIA Jetson Nano because at that point the Nano was available to us, and we were calculating this combination of sensors. And also it was great for us because it provided us with user interface for the vending machine, because it had a small screen for people to see what they put in and how much money they're going to get after was the transaction was over. So we were amazed about the power of this Jetson Nano kit, because it's practically a small computer hidden in this box, and full-fledged Linux running. You can do, it's ideal for learning, building, and actually mass-produced items if you want to put the brain in it. At that moment, the Orin models were not available yet, so we're so excited to see how that will go and how much power that could add to our solution. But for the time being, it was the perfect use case and the perfect dev kit. And we went along with what we found. The community around it, it's amazing. There are a lot of open source projects already created. So it was more of a, let's match whatever necessary features we needed to read sensors, to create an interface for the screen. And after that, to send them to the cloud to gather the data in an IoT platform. And yeah, now, as I was saying, simple sensors just wouldn't cut it. So we knew we had to find something better, and we were looking at computer vision, of course, to take pictures of each item, and especially those where the basic sensors could not actually decide in which category to place, to kind of see what they are, and if not at the moment of the selection, maybe afterwards, to at least label them correctly and see what they were in fact. Because actually when you're taking recyclables from people, they don't end up in the vending machine as perfect as they are when they're new. They're already emptied, maybe they're a bit dirty, maybe the label or something is scratched. So it's not the ideal use case. So you have to take this in consideration, and even something that might not look like a water bottle could actually be something else entirely from the range of the sensor. So that's why we had to take pictures and understand better what we had. What we found out, of course, is that it is best to take pictures of the objects you try to detect in the exact same conditions that you use in the production. So for example, right here, we started to take pictures of the recyclables on the same material that the conveyor belts from inside the machine were because the color could greatly influence your detection rate if it's different from your test to the production. So yeah, we starting taking pictures of a lot of them, and to see how we can increase the accuracy of our sensors. And at that point, previous to this little project, we also used the Edge Impulse platform for our tools, to sort our tools in a rack based on shape and color. So we said this might be actually a great idea for the recyclables as well. And thinking about the long term, having a database with recyclables could also be very important, and very good to go into scale, maybe to other countries as well, once we cover up what the Romanians, for example, are recycling in this. And yeah, as I said, we took just a lot of pictures of all sorts of recyclable and spinning them in all positions, so we have good detection from all angles, and starting training our model. And yeah, as I said, from non-ideal scenarios with ripped labels, not perfect containers, and especially the ones that were tricky. For example, there are some milk bottles from cartoons that also made of cardboard on the outside, but actually aluminum foil on the inside. They were very tricky because the system itself thought they were, with the sensors alone, thought they were actually aluminum cans because they have aluminum. But after we implemented the computer vision, and of course seeing the shape that is cardboard rectangle, they were put in the right category and sorted by the device.
Constantine,
So-
can I sneak in with a quick question for you?
Of course, of course.
So I see in this picture here, you've got the webcam up, you know, at an elevated angle, and the bottle is on green material there. Is that because the conveyor belt in the previous pictures were
Yeah,
all
exactly.
roughly that color? So you have to make sure that your background for your data collection is similar to what's going to be out in the field on the device, huh?
Exactly.
Yep.
Right here on the right, these are the actual conveyor belts mounted in the machine, in the vending machine. And the angle of the camera that we have used is also the angle of the camera that is mounted in the vending machine, because, okay, of course, it increases our accuracy and makes the same position and angle of the bottle and the distance from the camera be the same.
Interesting. Yeah. Good. Good,
It's-
good move there. Yep. No,
Yeah.
I've seen that as an issue in the past where, you know, you go to collect a data set when doing computer vision, of course, and the background, if it deviates once it's, you know, out in the field and it's deployed, what you trained on might not be applicable anymore. So nice, very cool.
I think in this case, I could add up another quirky fact, thing that we found. Actually, we're helped by the fact that the vending machine, it's a closed box. So inside of it, we had the same illumination levels, the same lighting, and all the time. It doesn't
That's
matter
nice.
the illumination around the store, because when we actually did training for the pegboard with the tools, having the light at a different settings or other lights around it was seriously deviating our accuracy. So luckily in the vending machine, when you close it, it's the same illumination. We put a source of light just behind the camera. And this actually helped, as you said, the color, respecting the color of the background, the same position of the detection actually helped stabilize the accuracy, because when the tests are the same in the production, then you get good results. So yeah, on the NVIDIA Jetson Nano, we've been running something simple, the MobileNet V2 model. And from what we read, the Orin series had been just launched, and I think I've read something about 80 times the power of a Jetson Nano, and we had the really small version with 2 gigabytes of memory or something like that. So, but it was doing just fine for us. So we're just curious if we could go for a larger or more interesting model to. Just about that, I see a question about.
Couple have just rolled in. Yep.
Yeah, we were based on comparison with the Raspberry Pi. The Raspberry Pi, it's an okay if you want to put something on the screen to make a small display, but we were interested long term in the machine learning capabilities of the NVIDIA Jetson, and the actual fact that it runs 64 bits Linux just like a home computer, so it was easy to create the interface and everything compared to the Raspberry Pi. Of course, it's a great contender, and with the newer versions for the Raspberry Pi as well, for the 4, could be actually used as well. But we decided NVIDIA Jetson for our use case was better, and having in mind the newer models, we can just imagine how good they will be in the future. So here's the vending machine assembled and deployed. This is the test pilot. For the time being, we have one of these prototypes and it's deployed in the restaurant, as I said, and people are using it. We're capturing data from what people are bringing. And the beauty of the system is that these unrecognized models can be further labeled by a human or something and on the cloud side, so we can redeploy the model when you have access to the actual JSON. And we can improve the accuracy of the solution as time goes and actually create a great data set of recyclables, especially for our country. I see another question about the model handling the contaminated garbage loads. I mean, it depends how much contaminated it is. For example, if it's something like a scratch on a label, or the bottle doesn't have the label at all, it still recognizes it as a bottle. And after that, we just kind of match it with the existing sensors to decide if it's glass or plastic. So it does help. It decreases a little bit of the accuracy if it's something that's totally messed up, like a aluminum can that's super trashed and we're not sure if it's not just regular garbage. We have a container that is just labeled other, so it's a smaller portion of recyclables that we are actually not sorting. So they will have to be either resorted or take it to compactor or did something else with it. But mainly the effects of what we sort is greater benefit than the actual few that get thrown in the other compartment. So yeah, could we use another data source? Sound, weight, glass and plastic sounds different as it's getting moved. Yes, we are already using weight because it's important for the manufacturer, for the recycling company to know the actual quantity of how much recyclables we have collected. So sometimes, but it's not a safe detection measure, because I don't know, it could be a very small glass bottle that has the same weight as a aluminum can or something, maybe not aluminum can, but who knows, it could be a plastic bottle with some liquid in it that could go to the same weight. So it's not a win-win situation, but
or maybe a combination of the two. If the conveyor belt is long enough, you can do object detection and then do the sense.
But we are doing basic weighting for all parts of sound. That sounds interesting. Who knows? It does rattle a lot, and as it goes through the conveyor, you get different sounds, but I'm not sure if could be worth a try just to capture that and see where the detection goes if we see some connection. Does it use GPU or running on CPU? Right now, I think I won't say a stupid thing because the developers went through this, but yeah, we're using the GPU part for the detection. And as I said, we're interested with the newer models that actually will have more computing power and redeploy the model once we explore more further analysis and bring in more data in the AgentPulse platform.
Awesome. Well, Konstantin, I'm looking at the clock. We've got 5 minutes left. I know we answered most of the questions on the fly as they came in. I'm also going to promote up to a panelist. I see that Raffaello has joined, and he's from NVIDIA. He would be able to certainly speak to the performance of uplift of the Orin, at least for what has been publicly, publicly announced. I mean, he is an expert in Jetsons. I'm going to bring him in one moment, and we'll transition. The other thing, though, to always keep in mind, I had made a comment somewhere further up. I see people there chatting. That's great. But and Gio, I see you there. I'm going to bring you up as well. Cost You know, you
Yeah.
have to weigh, you have to choose. Hardware selection is tough because you need to be able to, and I saw some other comments roll in, accessibility, availability, parts, you know, in today's world, you know, the supply chain issues. So availability, maintainability, long-term supply of a part, cost, performance, you have to weigh 5, 6, 7 different factors. So in this case, if a Nano did the job, that's great. You know, there could be other alternatives, but it looks like it was the right choice.
Yeah, for sure. We try to do the as much as the hardware part, the actual bill of materials for the manufacturing of the hardware part in here in Romania. But for electronics, of course, we will import what's of greater availability and greater performance for the solution. And in this case, NVIDIA Jetson was the winner. Cost of the machine right now as a prototype, it's around 30K. But we have not touched about manufacturing or going to scale, so things will greatly differ once we go towards that path.
Yeah, no, that makes sense. I mean, that is an industrial solution. That is not a, well, I mean, I saw the pictures of you in the metal shop doing the welding, which you clearly said was not the same as soldering. I had to laugh. So yeah, you know, it's of course pricey, but it is a end solution, and that's, you know, that's a whole nother session that we could have probably even explored, is prototype to production. That is always an interesting conversation. So, David, what, you like soldering or welding? No, I don't do either. Hey, B, I don't solder or weld. I'm not going near either of them, although I will admit, as Raffaello gets prepared, he knows that I did some soldering, because he's going to start talking in just 2 more minutes about the NanoSor project. And I did, in fact, do some soldering under the hood here, but I'll save that for him. But thank you, Konstantin. I appreciate you taking the time. Like I said, I know it's your evening there. You know, if there's any questions, do me a favor, Konstantin, and put into chat, drop in there maybe your contact information, your Twitter handle, your email address, you know, so that folks can follow up with you and get in touch with you. The last thing that I want to point out is, I've only got 2 minutes to find this link, but I'm going to do it. The last thing I want to point out is there was a question that I saw fly by in the chat. I think it was from Geo, is this project publicly available? And I'll grab 2 different things. So the first link I'm going to put into chat right here is the documentation that you and Zelmotech produced. Because we have a tutorial, a write-up on this project. I mean, it's certainly better to have you come and explain it to us. That's a way better experience, but there is a document. The second piece of it is the Edge Impulse project itself is also public. It's a public project URL, which means that anyone can go and see the training and deployment that you did. The data collection, the data labeling, everything that is in there. They can then clone it and iterate from there. So they can take that work and either sort of append onto it and deploy themselves, or they can at least get a feel for how you went through it and then go create their own. But I think that should do it.
Yeah, I would, one little thing with that, we are also making efforts to putting the actual mechanical parts and everything shareable as open source hardware, and
nice.
You have to believe me, that's the great effort to
I can imagine.
Things we have welded and everything. That's why that is taking longer, and this already got published. But we are doing efforts to bring that up and build it, help us evolve it, and why not?
Yeah, well, I mean, that's a great, transition then as we bring Raffaello and Gio in. But obviously that's your plug. Make sure you follow Zalmotech on social media. Make sure you follow Konstantin on social media. Like I said, Konstantin, get your contact information right into
Of
the
course,
chat
I'll
there
add
so
it in
folks
there.
can do it. And we'll say goodbye to Konstantin, and we're gonna say hello to
Thank you so much.
Raffaello and Gio. Goodbye, Konstantin. Have a great evening.
Hi.
And
Hello.
Raffaello, I can see you, I can hear you. Gio, I can see you, I can hear you. And I am excited to continue on with some more content here, still on the NVIDIA topic, the Jetson topic. After this one, we're going to transition from regular ROS into micro ROS. But I'm looking forward to seeing what you guys are up to. Let's do this. We're only 1 minute behind schedule. It's a miracle. So Raffaello, if you want to give a quick introduction and say hello, and then Gio, you give your quick introduction and say hello, and we'll take it away.
Okay.
Well,
So,
we start. Giovanni, do you want to start? Huh?
okay.
Gio,
It's
go
okay.
first. No problem.
Yeah. I'm just tired because here in Italy is evening, and we make in Italy with the NALUG, is the Naples Linux User Group, a big event, the No Hat Day. It's a privacy and security and cybersecurity event. So what we are talking about today is how to add AI capabilities to Nanosaur. And this is me. So hello to everyone. I'm a robotician and automation engineering in Italy. I'm a student. And I'm also a robotics designer. So I have designed some robots for some companies. Yeah. And I also generally help Raffaello in Nanosaur with some software that are always for fun things. For example, the video streams for the eyes.
Yes, will become soon.
Feature. And now on AG Impulse. And from this collaboration and friendship, I designed the AG Impulse ROS package that today I will show you. So here, if you want, are my links and my stuffs that you won't see. And also, before starting in this short journey, I will just to show you a cooperation, a collective that for robotician that me and Raffaello co-founded. Is called the Pizza Robotics. Why Pizza Robotics? Because we are Italian. Pizza is Italian, so we love pizza. We love robotics. So
And you know what? I need to thank you guys for joining, because yes, you're both in Italy right now, and I know that it is your Friday evening, Friday night. So I appreciate you taking the time joining in.
And
I'm an Italian in UK right now.
Oh, that's yeah. You're in Cambridge right now, huh? Yeah, it's still your Friday evening though.
Yeah.
It still is. So thank you guys.
No worries.
You're welcome. It's a pleasure to be there. So if you want, we are Italian makers. We make robots in pizza with crust. If you want to follow, the QR code is there. So we will be also in Maker Faire next week in Rome, in next weekend, and we also have we have 5 robots with ROS and with machine learning, and also in November I will take a workshop about Arduino plus TinyML using AG Impulse. So follow up all the things of Pizza Robotics, Maker Faire Rome, and you will see this stuff. So yeah. So we are talking, I started saying that I created this package, the AG Impulse ROS package, how to use AG Impulse with ROS2. So what is ROS2? A general introduction for people who doesn't know what is ROS2. ROS is the acronyms for Robot Operating System, but it isn't an operating system. It's just a framework to build fantastic robots like Nanosaur, and it is open source, and it allows to
have a quick design process for advanced robotics. So mobile robots with autonomous navigation, machine learning, SLAM, and this kind of stuffs, grasping, and etc. And it is widely used, probably is the most used framework in the world for robotics. And now it is used also in industrial. So academic plus industrial is the best community-based project with companies that support that. So this is why it's important to use ROS. And this is the new package, the Edge Impulse ROS package. It is very easy because it is a pre-release package, a preliminary stuff for a more big project. It is at the moment just one node. It's called image classification. So you can just understand what it is from the name. You have topics because ROS works on topics. You have an image topics in the input of this node and a .eim file, so from Edge Impulse as a parameter for this node. It loads and understands what the Edge Impulse project do, and you have as an output a new image. There is the classification image, and also a detection to the array with all the object detection and the vision info that give you information about your Edge Impulse project. So it is standardized on the ROS2 format because all the topics are standards, and it allows you to use practically any vision system that you can create with Edge Impulse with ROS2, just with 5 clicks probably. And when you want to import your project, just go in the output part of the dashboard, and you can choose, for example, Linux for ARC64 or Linux x86. In the case of this demo, we use the ARC because we are on Jetson Nano. It is the same of the Raspberry Pi 4, for example. And yeah, you can see the package on my GitHub. It is very easy, GBR1 Edge Impulse _ ROS. And just if you want, and I would that use it, just fork it, merge it. And also I have enabled the discussion session. So if you have ideas, you want to create pull requests or other stuff, just write on there. There is a little forum that you can create on GitHub. So let's try a demo before working on Nanosaur, just to show that you can use easily, for example, on a virtual machine or on a computer. This is an Ubuntu virtual machine with ROS. Here I am publishing a video. It is a video of me at Maker Faire Prague 2 weeks ago. And here I started the model, the person detection model. This is a standard and tutorial one, so very easy. And here there is the output. So this is the basic stuff that you can do. And also, okay, I can show you, for example, the detection output as a topic. So if you want not the image, but you want just to see where is located, for example, the centroid for the detection, you can just bring the topic. And it is what you need on ROS2. So this is my part. I don't know if you have any question or.
I did not see any questions come in. I put your repo in there. You know, I kind of suspect, let me unpin real quick. There we go. I kind of suspect folks are going to need to give this a try. This is, you know, obviously brand new. But like you mentioned, it's on GitHub. You have the discussion section enabled there. So there's a little bit of a forum there. Obviously, like you said, fork it, use it, merge, contribute, you know, issues, whatever. This is super cool though. I see Alex, you're right.
Yeah.
Ross does rock. And Gio, real quick, you're all over the place. So you mentioned you were at Maker Faire Prague a few weeks back. We just saw that. You've got Maker Faire Rome next weekend, and then you have another session in November. So if anyone wants to, keep up with that stuff, make sure you put your contact information maybe into chat, or I'll drop your Twitter handle in, or your LinkedIn in.
Yeah.
But because you're all over the place.
I will pass my link tree.
Yeah, perfect. Yep. All right, you're good. All right, Raffaello.
Much. And now is the Raffaello part.
Okay.
Go NVIDIA.
Yes. Raffaello, you're on mute.
No, yeah. Do you hear me now?
There, now we do. You're good.
Okay,
Yep.
much better. And thank you, Giovanni. Thank you. And I don't know if you can see now my presentation.
Yes. Yes,
Oh,
we
okay.
can. Yep.
Great. Okay. Short introduction for me. I'm Raffaello Bonghi. If anyone know me or don't know, there are some links about starting from my website, personal website with all my stories, what I do, because right now I'm working in NVIDIA, but before I have really an old experience in robotics. You can find me my Twitter and my Instagram account. What I do now, yes, I'm developer relations, more technical marketing. In fact, I'm making many webinars about robotics, Isaac Ross, and many examples are with this little baby Nanosaur. And the first step, what is Nanosaur? If it's your first time to see this robot, this is the website, nanosaur.ai. There is a QR code, and it's a little small robot. Just have an idea what we are speaking about. This robot is an Italian project. Well, I made it, but it's finally worldwide. Many people are making this robot. Fully open source, 3D printable. You can make your robot at home. I hope it's simple to print because there are some parts, example the TPU materials. It works with ROS2 and NVIDIA is across. This is the main support of the robot. And this year was the best ROS robot award from the ROS developer community. Before to start about the demo, I would like to show mainly the architecture of this robot. This robot is Docker based. There are some parts running in a standard Docker, other using the GPU acceleration on the NVIDIA. Example, when the robot using the Isaac Ross, or if you want to try a G-Impulse on GPU, or if you want to try GPU and CPU, there are different Dockers. What you can do with this robot, such as an open source platform, the idea is learning about what is ROS2, what I can do with the robotics, and example, which type of sensor I want to use. In this case, there are different versions. One example mine with a cover with a RealSense, but there is a Z, a MIPI. I hope soon we'll share a new version with a WAC Delight, and I'm still working for another version with another stereo camera in MIPI. Who is based the architecture with a main driver control, another ROS2 packages for navigation, other packages to drive the robot, example with a joystick, the perception that I was telling before, using different type of AI, like a G-Impulse or Isaac Ross. You can use the localization with a Visual SLAM, or the 3D mapping with MVBlocks, or it's up to you. This is my main idea. If you want to fork the project, really feel free to do it. It's all fully open source. And same story if you want to drive the robot outside from an external machine, or you want directly drive the robot with a ROS2 node on a robot. This is another example because you've seen before an example of the robot running, well, an overview. Now this is a practical and what is usually run on Nanosaur when you want to use example a real sense camera. There are, I don't know if you see my mouse, but there are different...
it's showing up. Mhm.
Ah, okay, great.
Yep.
There are different nodes. This is a really cool capability of ROS2. I hope part of the communities here know the ROS2. And by the way, Giovanni do an introduction about ROS2. But one of the cool capabilities is merge or use different packages coming from different solutions, or you can design your solution and you're working inside this huge framework to share packages between, share data between nodes. An example, this is Voicework Nanosaur for an example with a Visual SLAM. There are different packages. There is a diagnostic example. This is a diagnostic running now with a robot. You can see what the robot is doing, me, and the localization of the robot running real time on the robot. And going back to the example, this is what is exactly going on with different Docker running at the same time. Another point for many people can be interesting is this robot is made to work in CI. This is an interesting point if you want, example, learn how to make a CI for robotics application. Another news, this is I hope for the people already have a Nanosaur or won't know the news. I'm making a new expansion board for Nanosaur. This is right now what I made it, but it's a new design to use the Jetson Nano, Jetson Xavier NX, the Seed Studio Xavier NX board, and the Seed Studio Jetson Nano. With this new version, you can use Nanosaur for many new carrier board or different version of Jetson. And I hope one will be released for the new Jetson or Nano, such we are speaking before. Other features, the LiDAR, IMU, 2 LEDs, and the heads I was speaking before.
So you're telling me that I'm going to have to solder a new GPIO header is what I'm hearing, Raphael.
Yes, well, I will solder for you.
Nah, I can do it.
But no, I'm still designing. I'm just testing. I don't know if you see here on my camera, but I'm testing some parts. Because I'm changing really many, in particular the OU switch on the Jetson is completely different now compared before. Yeah. But it's under development.
It's okay. I will keep my eyes peeled.
And another point, I'm looking to some producer to help me to make a short production already sold.
Yeah, that takes the fun out of it. It takes the fun out of it. Well, maybe it saves time, but
we need to create a Nanosaur day with all of us playing with Nanosaur.
I mean, you know, the documentation, though, you pointed out earlier, the website, nanosaur.ai. And, you know, I remember going through, it's been a lot of months now since I've done it, but I remember following through the documentation and the tutorial, and just, you know, you describe all the components that are needed. You describe, you know, what needs to be wired from the from the GPIO board up to the front for the OLED for the eyes. You know, the ribbon cable for the camera is obvious, but the motor driver is up front. It's all there. I mean, I just followed along. It's pretty simple.
Well, thank you.
Yeah, I mean, it took maybe 1 or 2 evenings, but you know, it's fun. It's fun. So, and in the end, you come away with a functional robot. It's great. So,
well, all this when I made this robot, I was thinking, well, it's simple. There are a few stuff, but in the end, just to make the architecture you have seen before, you spend a lot of time just to design the software.
Yeah, the software. Yeah.
make
Well,
the
and I mean, and that's,
communication.
but it goes to show, right? Because if you think about this, okay, you have built a small robot. You could say that it is a prototype robot, or at least for learning purposes, you know, but it runs ROS, it's containerized, everything, you know, it's all there. But you used an off-the-shelf part, the Jetson Nano, and you know, obviously you've got the other boards in the pipeline, the NX, the Seed Studio NX, and you know, when the day comes that Orin is more readily available, then fine. But the point is you didn't have to build a PCB for the compute stuff. All of that is already. You just buy it, you know. So yeah, the bulk of your time was spent in the ROS and the software side of it, but other than a quick GPIO hat, away you go, ready to turnkey robotics platform.
Thank you.
So,
I don't know why I cannot see you during my presentation.
let me see. Are you? I wonder if.
No, it's an issue from my laptop. No worries, no worries.
Oh, okay. I thought
No
maybe
worries.
I accidentally pinned or something. I don't know.
No, it's my issue. No worries.
All right, we have just a few minutes left.
Oh, well,
and,
yes, I will.
Well, no, and that's okay. No, you're fine. I mean, you're right at the end. You know, make, build, star, and follow. Yeah.
And hold on.
Okay. All right. Go ahead.
This is what you can try with Edge Impulse with the node made from Giovanni. There is a new container.
Okay.
Is made or in GPU or in CPU, where there is the Edge Impulse node, the Nanosaur AI controller. In this case, for this short demo, you drive directly the robot, sending navigation messages and moving the eyes. Is in progress for a few parts. And well, where you can find it in this new repository called the Nanosaur Edge Impulse. All the system works with the different packages, the Nanosaur, just to know which message can use to move, example, the eyes. Edge Impulse ROS and Nanosaur AI Edge Impulse is the package to drive well, with the controller and the launcher for this part of the Docker. A nice part. This is a nice example for advanced robotics, because we are speaking about simple robot, education robot, but looking forward for a real industrial robot. Is just small, look simple, but finally is a robot with the same view if you want to make an industrial application. If you're working with an industrial application, container, make many containers. For each container, example, there is Edge Impulse. There is another one for Isacross, another one only for other controllers. It's simple to deploy, it's simple to manage if something goes wrong, and it's simple to update. Example, you can drive the robot in real time. Not, in this case, not Nanosaur. If you're speaking about, example, a robot for AMR, you can change dynamically a part of the robot, and whole system is running and updating. Example, you're updating only the model for the Edge Impulse, and this part of the Docker is updated, and the rest of the robot is going on doing other stuff. And just last part, but we already spoke, but we announced the new Jetson Orin Nano, the same size of the Nano, but the capability are really, really higher than the current Jetson Nano. We're speaking about more teraflops, 40 teraflops. We are moving from 4 CPU to 6 CPU. We have a different solution with the same size, Orin Nano and Orin NX, and will be available the modules from January 23. But if there are people or developers or maybe companies are working with AGX Orin, they can already try with a AGX Orin changing the emulation using an emulation mode. Again, another recap, you can find on Nanosaur AI. Please, if you want, make, build, and start or follow my GitHub account. And feel free if you want sponsor my project, because this is my personal project, Nanosaur. I was speaking by myself.
Yeah.
I decided before to join in NVIDIA, this robot. And really, I'm really happy if you want sponsor or help me just only with a start or a follow.
All right.
Yeah.
Well, thank you, Raffaello. Yeah, definitely don't forget, you guys, Pizza Robotics is going to be at Maker Faire, which is in what? That's only a week away. That's next weekend, I think. Yeah. We did have a couple of questions roll in. We've only got 3 minutes left until we bring Eric in from Seed Studio. You just had some links there to the Seed Studio Nano and NX. I'm sure he'll have some talking points on those as well. But real quickly, let's see if we can get through them. Which ROS 2 distro are you using in the Nanosaur?
For Nanosaur right now, if you want to download, install today, is running with Foxy. But with the new release, with Xavier NX, will come with Humble and change completely with new updates. But this will be available only with a new version in December.
Okay. Quickly. Oh, go ahead.
Just for information, the Edge Impulse ROS node works only on Foxy at the moment, because standing on the Vision messages, they change in each version of ROS, because they are evolving. And so I'm focusing on Foxy to then pass to Galactic and Humble, but it is something of next month. So,
okay. So coming soon.
Yeah, it's coming soon.
Stay tuned. The Jetson Orin Nano, is that going to only, well, you know what, this might not be public yet, but we'll see. I'll ask you the question, Raffaello. If you can answer it, great. If you cannot answer it, that is also fine. The question is the Orin Nano going to have a dev board available like the regular Jetson Nano, or only the big dev? You don't know. Okay,
I don't know. I
no
cannot
worries.
reply. Yeah,
that's
unfortunately,
okay.
I wish to have one on my hands, be honest, and one for Nanosaur, but
yeah, no, it's all right.
We're
I don't know if that was public, because we've seen the SOM, but I don't know that we have seen anything beyond that.
Yeah,
it's okay.
It's an announcement. In fact,
it's okay.
Not
No worries. Nico, stay tuned. Let's see. How much improvement in terms of speed do you get from Nano to NX? Naveen, I might be able to find that online for you. I want to say it was like a 10x or 15x. I can't remember, but I know that it's a pretty significant uplift. It should be documented though, because the number of tops for the Nano is 0.5 tops. The NX, I'd have to go find the value, but essentially that's going to be your improvement factor right there.
Yeah.
And then AB had, what role does Isaac play in this architecture? I'm not sure it's totally integrated right here, though, is it?
Well, I will be more general as possible. For Isaac ROS, generally, for Nanosaur, is the base to drive the robot. Well, not only drive, it's the perception of the robot. Example, there is the localization or soon the mapping. The mapping will come only with the NX7X because right now I don't have power to switch on all these modules. Speaking about the demo for Edge Impulse, in this case is a combination. Example, I leverage what can do or in GPU or in CPU, depends of the Docker. This is what is going on now. And the final integration of this module Edge Impulse on Nanosaur will be to drive from low power to high power the Nano. Is not for the demo that you can see today, but the idea is have Edge Impulse when all systems are in low power mode. Example, I won't save the battery, but if I see something coming, example, a person on my end, the robot directly switch on, because in this case I'm using the low power of the CPU, and I switch on directly full GPU, repump all modules, and I work in real time with GPU with all areas across, and I leverage between low power and high power. This is the idea, not right now. Well, it's the idea, and I will integrate soon.
All right, thank you. Well, I see that Eric has just joined in, and from what I understand, Eric is actually in a jungle. So, Eric, you're on mute, but that's okay. So I'm thankful that you are okay, because there were apparently some bears nearby. So, but he did not get eaten. That's good news. So he's doing AIoT for real. So thank you,
from the wild, from the real wild.
From the wild. IoT in the wild this is no joke. But thank you, Gio. Thank you, Raffaello. I appreciate you guys taking the time. Like I said, I know it's your evening, and you had your contact information in there. If anyone has any further questions, by all means, reach out to them. They'll get you sorted out. And I appreciate it. Thanks, guys.
Thank you. You're welcome.
Bye.
All right. Bye, you guys. And let me just move them quickly. And Eric, you should be all set. There we go. Okay. All right. I am 3 minutes behind schedule, so I am sorry about that, Eric, but we're doing our best.
No problem.
Yeah, thank you for taking.
You know, actually.
Well, thank you.
Sorry for jumping earlier because we lost the power as of now, so I was totally wondering how things going to happen.
You know what? It's no problem. I think I may have sent you the wrong time. You know, time zones are hard, and so I apologize. But no, I loved having you make a special guest appearance. It was great. We loved it. So it's all good.
Yeah, we keep like there's something up here behind me. You guys are the witness. Can you hear me? Okay.
Yes, I can hear you just fine.
Okay.
So let's do this. I'll hand it over to you. I'll have you give your introduction, you know, tell us about yourself and about Seed Studio. I've got my Seed Studio hardware with me. I'm excited, I'm ready to learn, and go ahead and take it away, Eric.
Thanks, David. Hi, everyone. Good to finally talk to you again through Imagine. So I'm basically not trapped, but threw myself into a jungle in Colombia. So the time zone is okay, but the connectivity might have some problem. So we have been doing open source hardware for many years. Today, I'm going to bring you how we're trying to make sense from the wild with your data. I'm Eric from Seed Studio. And since 2008, we started to create a lot of open source modules around Arduino, around Raspberry Pi. And I think we brought a lot of possibilities with the maker community. And it goes on, we see a lot of need for productivities. How can we really bring the prototypes into real world? How do we really bring more values to IoT? So this is how it's going. It's been 14 years, we still trying our best to create something different. And how we do that is still very simple. In the upstream, we try to bring in the latest microcontrollers, chipsets, accessories, algorithms, and also the software, the new materials. And when we threw them into our R&D system and turn them into open source modules at the first stage. And by supplying our global developers community, we hear a lot of requirements. So we generally develop more devices to make everybody's life easier, and it's also open for customization. So we work closely with our community members to contribute solutions that in the end, I think it's going to be the traditional industries adopting this new like IoT or technologies for their own transformation. So after about 14 years, our staff has been categorized into 3 parts. First is edge computing, and second is IoT network. And the third one is very much developing is smart sensors. And we also provide services so people can bring their prototypes into scale with us, no matter it's a startup or it's a research. So this is about what we have been doing for years. And after many years, we realized that a lot of the majority of our efforts are trying to help people making sense of the real world. So if we look at the Groove system, we have created over 1,000 types of Groove modules. So people can just use the popular platform and plug in the sensors with all the established library and projects. They can just do their project easily. And we see from all the Groove modules we make, majority of them are actually sensors. All kinds of sensors can, like, because people always want to know more of the world, to the visible ones and invisible ones. So we keep adding new sensors as the technology moves on. And this is the core value we create to the community is we help people to make sense. And this was a bit boring until we have Edge Impulse, we have the embedded machine learnings, because with the sensors, you can get the element data. You read it, so okay, I can understand more. But what if you have machine learnings? You can redefine the sensors. You can give a new meaning in a very innovative way. So we have, after we embedded the Edge Impulse into the system, into especially wire terminal, people to try different kinds of things. A famous example is from Benjamin. He published his creations on Make magazine. In the beginning, he wants to tell from different alcohols. He's not a scientist under these compounds, but he was very simply trying to use multi-gas sensors with Groove and Edge Impulse training like process. Then he can differentiating from beer, whiskey, or other alcohols. So this moves on, and he can like try different food, different coffee. So, and a lot of project has been following this path to make it more real. This is a recent observation from IEEE paper by Muhammad Zubia. So they use a very similar architecture as Benjamin to distinguish alcohol, but to detect the hazardous gases from the production floor. So they fine-tuned the machine learning model, and they published their new methodology to resolve the real problems. So it's still the smart nose, but it has been developing and evolving. And we see a lot of these ideas has been developing. This is one of our most exciting findings from the community for the past like 3 to 4 years. What's next? What's beyond this sense is where we look at the wild. And out of many possibilities, we feel that a lot of IoT sensing happens in a civilized world. You have power, you have electricity, at least most of the time. And importantly, you have the accessibility to maintain it. And you have the rooftop. And you don't need to worry it's getting like withered, you don't get it damaged. But if you look out the window, whenever you're flying through a plane, you look down to the ground, more than 99% of the planetary Earth is still wild. We have some data through scientific research, with some data through rangers, but it's just a very small portion of the data from the wild. But why we should care about that? It's a very tremendous climate change. We worry about biodiversities. We worry about the wildfires. We worry about how can we improve the yield of agriculture efforts. We worry about the infrastructures. So we need to have a new way for us to explore the possibilities. And there is a big opportunity window because we have a very fast growing LoRaWAN network. Because of Helium TTN, there were more than 1 million hotspots all over the world. And it's public, you can just use it and pay for it. If you don't find one near you, you can just deploy it by yourself, use it for your data, and also to share to other sensor and people who might use that. So it's a very outgrowing basis for IoT to sense from the wild. And people doing their best to install the hotspots on top of a windmill, on top of the mountains, or on the roof. So following this trend, a lot of people already start to do that. They do the penguin counting and monitoring with AI. They do the snow depth monitoring before they get trapped on their way home. They monitor the streams from the river with a current sensor. And the wild animal trackers, they start to make their own hardware to do tracking or to do the local testing in the wild. So we already see a lot of makers and projects that are doing the sensing in the frontier of civilization. And this is a recent project from the Smart Ocean System Laboratory. They do the ROV under Earth, under the water. So they have to do the inference with this whole system independently. So they use the computer with a heavier NX module inside by NVIDIA. So this carried on to the real life scientific research project. It's much more than just a prototype. And this is a similar project we mentioned about infrastructure. So cracks. Having a crack is okay, but you need to keep looking at that to find there's no more cracks or the crack is in a stable status. So instead of human beings trying to watch their eyes, climbing up and back forth, so this project is done by Naveel Kumar. He used a computer module, Raspberry Pi based terminal to use camera to tell from that. So he has created his own data sets to train, and people can reuse that. So this gives us a new hope that we can give smart infrastructure monitoring a new meanings instead of very intense human neighbors and dangers. Now you can use machines to do that. So we are not idling in Shenzhen trying to wait for people to do that. So we threw ourselves into the jungle as well. We want to prove that we can use imaging AI, like vision AI in non-time monitoring in long distances. So we just found ourselves a national park in Sichuan where they protect the wild pandas. Why we choose this place is because it's absolutely out of civilization. We keep it from civilization. There's no power, there's no coverage, there's no accessibility. You have to fly very deep into the mountains to monitor these things. Previously, it was done by the trigger cat. The ranger has to go there every month to collect them. And there's no live data. There's very much missing of enough monitoring basis. So what we want to do is we have the sensor with line inside with vision AI mechanism. So we don't need to send back the full data of the imaging or have someone in the back to keep filtering it. So we train in our office with the videos, images to make sure, okay, this one may be working. And we even for some customs, so our team member to play around as if it's a panda. So we verified within our office, and we verified the LoRaWAN connectivities through our other projects. and we went to the ranger stations, deployed the network because there's nothing there. And we find a place where, according to rangers, are likely to have pandas appearance. So we set up the camera to where it must pass through, and along with a trigger cam. So after a few days, we start to see the readings. To study the signal, there's a panda, probably 80 or 70%. And after a few months, after a few weeks, we go back to collect the cam. We see a similar time span, and it's working. We see the results, and we have better understanding is this panda appear about every 2 days about sunsets in that region. So if we can deploy more data there, it's going to be game changer. We have more understanding if it's the panda group is growing, is more active, or it's migrating. And also we can use a similar means to avoid the intrusions. So if there's anyone going to damage the biodiversities, we can know that. But it's not easy job. But by doing these efforts for a few years, we realized how easy it is for your wireless sensors to get lost in the wild. The first problem might be from the hardware failures. The number one is from the weather. It's temperature change. 4 seasons, you get frozen, and the lightning, which means the thunders might hit that and it damage the whole thing, burn into ashes. And we see rain, snows, hailstorms, which is a lot of pressure on the waterproof degree. And the sunlight was something we missed in the beginning, because through the UV, if you expose the hardware, even it's waterproof, for a few years, it's going to destroy the electronics inside. And the animals and chemicals, they will damage as well, like for herbicides, for chemicides, and that will erode the enclosure and make it vulnerable. And the second biggest problem is outdoor battery. Even with LoRaWAN, even with HAI, so you don't want to maintain them, go back to the trees and to replace the batteries. So with all the new means, we are trying to make it lasting for up to 10 years. So the technology is already there. And with HAI, we don't need to transfer the data back every time. So we just distill the events, the key information. So that's making it very durable. And if there is no signal, you just deploy your own LoRaWAN gateway, or you can extract the data whenever you're carrying a gateway with you. So we need edge computing. We process the data locally, collect them, and carry it back physically. And we need to worry about the data quality, because you cannot calibrate it every month or so. So we need to have multi-models to correlate it by itself. We need to have a new way of calibrations. So by only doing so many things altogether, we can make our senses from the wild and make it survive for years. So that's where we want to contribute to the community, is to have the LoRaWAN Vision AI sensor, which is designed for the wild deployment. It's ultra low power consumption. It has built-in AI inferences. It's long range, and we are seeing people trying to use it for disaster monitoring, landslides, wildfires, and for object detections, no matter it's for diverse biodiversities or intrusions. And it's not just a product launch. It's something we have been working for quite a long time. And we are releasing it with $79. It's available right now. And it has built-in aging pulse. So you cannot only just wait for someone to build a model for you. You can just retrain the sensors with a new AI model very easily. Like people ask a lot, can I use it for a meter? Because I have legacy meter and I don't need to rate it every minute. I just want to rate it every day, but I don't want to walk to the meters and take a picture. So this is a perfect scenario. Even in the wild, there is like a hydro generators or pumps. We want to monitor them, so you can have new meanings. This is endless. People can retrain the sensor with a very easy tool. Then you can have the inference back through a remote way. So we have done our job, is to making sense from the wild easier. But I think it's time to invite you to participate with your data. So our business model is very simple. We create the hardware, no matter it's a module or device, that's something we are good at. But we are not experts in specific domain. You are the experts in your area or in your domain. So we want to make the tools easier for even non-engineer experts can use their data, use their know-how, using their methodologies to work with us to create more solutions. So we can not only just making sense, but making them useful for agriculture, for like energy monitoring, carbon monitoring, traffic, smart cities. So this is not something new, but we are doing it more. Like previously, we have been done a carbon emission monitoring system with professors from China Academy of Science, from Maryland University, because they want to create an array to monitoring the carbon change in a very fine level, like less than 1% of a ppm. So we help them to set up the hardware, so they deploy hundreds of them around Beijing. So they have the data from the wild, have a map. They have the algorithm to tell from an aerodynamic way where is really emitting the carbon and where is offsetting it. So by doing that, we have much better system to systematically, with scientifically, to improve the carbon footage we have. They are the experts, and we support them not only finish the project, but also promote this project, this solution, to other areas who might have similar needs. And we just announced, I think 1 month ago, a SenseCraft open source software, because we feel that a lot of pains for the non-technical people to set up the whole system, to do embedded programmings. So we're trying to make this thing as easy as 3 steps. First, it makes sense to collect the data with some sensor modules, and the sensor module can be retrained with the aging pulse for their own AI, or for vision, for vibrations, for sound, or for like even new types of sensors. And then we process on the device, so you can choose what kind of trigger it's going to be. You just need to send out the events, the key points, instead of the whole data sets. And then you can choose different uplink through LoRaWAN, Wi-Fi, or any means available. So these are available on GitHub. We hope to improve this over time. In the end, people don't need to code. The new coding is the best coding. They don't need to realize that there's IoT in the middle. No IoT is the easiest way to use IoT. So there's 2 parts. First, the contributors, and we want people to use that. And also, we are opening up our group system as well. People are always asking for different types of group system, and we don't have the bandwidth. And also, if you are not a hardware engineer, if you have some special soft data sets, you can also train the group systems to make your own, to define your own smart sensors. And we are giving people bounty. We share the revenue of this product we created. So by doing that, I think we can co-create more sensors, which can be very innovative. And also, we are jointly to support a 2 group of things. First is called Open Metrology. You can check from the link that it's a course from MIT Artem Beach Center. And they are gathering a group of scientists who are inventing new scientific instruments with open source hardware. So you can see, you may know better than me that for a meaningful, disruptive science research, you usually need to make your own equipments, so you can have a differentiating data to have a different conclusions. So, but the majority of the project is still IoT based. We see very little AI involvement. So I think we can do a lot to this group of efforts. And there is a gathering called the Open Source Hardware Science. It's called GOSH for short. It's a very active male group, and I think we need more AI experts joining efforts with scientists and makers to create for the next generation of open science equipments. Okay, last page before I close it out.
You're doing great.
We provided too many contents. And this is the biggest event we do ourselves this year. It's called IoT to Wild contest. And we proposed the challenge. Let's look at the several important factors in the wild, and we invite the makers to use IoT, to use LoRaWAN, to use aging pulse, embedded AI, to create new solutions to all the problems in the wild. So we already closed it up. We have 122 submissions. It's about like the top 10 of the Hackster or the contests. And it's amazing quality and amazing participants. So people use it to like to do early flood warnings, and people use it to manage their chicken farms. People use it to detect the volcano eruptions, because before that it's going to some chemical coming out. And people use it to detect the illegally sand mining from the river. So there are endless possibilities. We are amazed by how people care about the environment, and they have the ability to realize that. So we're going to have the judging process going on. It's going to be announced in Hackster Impact Summit in October 11th. So
Yeah,
stay
which is
tuned.
soon,
We
very
believe
soon.
there's going to be a lot of interesting projects coming up. So that's about it. Welcome to join our Discord channels if you have more questions. We publish most of our open source projects with our customers, users, community onto Hackster. And you can follow us on Twitter or LinkedIn. And yeah, the final invitation is come to join us. So let's co-create some solutions to make sense from the real wild. Thank you so much.
Oh, Eric, that was incredible. I mean, the amount of material that you covered and the, you know, the impact that these projects are having is just amazing. I know you mentioned that you had created over 1,000 Grove sensors, your team already, and with that competition that you're running, I mean, people can literally design, fabricate, produce their own as well. I'm just blown away by all of that.
Thank you, David.
Yeah. I did not see any specific questions come in, so I think we're good. We're good on time. Jim, I see that you've joined. I'm going to push you down to a panelist for a bit more, and I'm going to bring Avi up from a panelist to a co-host in just a moment. Any last questions for Eric? I don't see any. I see some congratulations, some fantastic, some wow, some great. It was amazing. I really
Thank you all. And I see a question here. It says, what is the next Grove sensor?
Yeah, Naveen snuck one in on us. There it comes. Okay, what is the next Grove sensor? Oh, they come out every day.
Yeah, it's good. The next sensor is by you.
Yeah.
By all of you. So we will support you to create more Grove sensors and carry them, distribute them.
Perfect question. Yep. Perfect answer, Naveen. All right, well, let's do this. We've got 2 minutes left until we've got Avi coming in to talk about MicroROS. So Eric, thank you again for taking the time. Thank you again for joining literally from the jungle. I am amazed that you were able to pull this off. I cannot believe that happened. But stay safe down there.
Yeah, sure. So glad the connectivity lasts. Goodbye, everyone.
All right. Bye, Eric. Thank you. Now, let me grab Avi and promote you in. Avi, that will take 1 second and it will rejoin you. And there you are. Now I can promote you. And
hello,
there, hello. I can see you. I can hear you.
The audio is okay?
Yeah, it's perfect.
Okay.
I can hear you great.
Well,
and
how am I supposed to follow Jungle, David?
Avi, you don't stand a chance.
I
He was
know.
literally joining from the jungle in Colombia.
All
I
right, I'm
have
done,
n-
guys. Thank you. Bye.
I have no idea how you're going to compete with that, Avi. No, I'm teasing you. I'm teasing you because I got a sneak preview of your content and your project, and I'm excited for it because it is literally groundbreaking stuff. You are exploring areas, and I'm going to let you, of course, introduce yourself, and I'm going to let you talk about the project for the next 24 minutes. But all I'm going to say is that you are at the extreme bleeding edge of innovation, and the work that you are doing, I really, truly think you're the only person on the planet who is doing it, at least that I'm aware of. And
I hope that changes soon.
well, but that's the thing about being an innovator is you're at the forefront and you are blazing these trails. And yes, hopefully people see this today, recognize what you're doing, and join you in this. So let me do this now. Let's turn it over. Avi, if you want to take a moment to introduce yourself and say hello, and you can basically take it away from there.
Sure. I'm actually going to see if I can share my slideshow here.
Yeah, let's make sure. You should have permissions.
Yeah, I do. And tell me if you can see that.
Yes, I can see it. It looks great.
Okay, great. Well, yeah, thanks to everybody for tuning in online. And yeah, obviously a huge thank you to David for inviting me to present here, and also for supporting this project. And also, I don't know if he's here, but a shout out to Artie for getting me involved with the
Artie's not able to join us today.
No
his
worries.
brother is getting married tomorrow, cool. So he's probably at a rehearsal dinner right about now. Yeah. But I know he was. I caught him sneaking a look at his phone. So he should not be doing that, but no, he wasn't able to join today. And you know what? Yeah. One last thing, I need to say thank you for joining. We've had a global audience, global presenters. You are based in Israel. I know it is your Friday night, so thank you for taking the time.
Of course, my pleasure. Yeah, thanks. Yeah, I've actually been really happy to see how well robotics has been represented at Imagine so far. Like, we had the whole event starting with Zach standing next to a robotic arm, which I was very happy to see. And obviously Ben Gibbs from Ready Robotics, and just now Raffaello and Giovanni talking about the Nanosaur and ROS 2. So yeah, today I'm going to talk about an integration I've been working on with Edge Impulse and MicroROS, as David said, which I really hope will lead to some interesting innovations in the way microcontrollers specifically are used within a robotics context. So I need to remember also to move my slides. So a bit about me. By day, I'm an electronics engineer at a small startup here in Israel called Robotic Perception. We're developing a self-driving agricultural vehicle for vineyard care. So I have lots of fun with that. And by night, I'm a member of the Edge Impulse Expert Network, where I've worked on a few projects, including this one, which is the one I'm actually most excited about so far. And I know Gio already did this, but just in case people are watching this video, after the fact, I want to just kind of set the stage with some basic info about ROS 2, which is the parent framework for MicroROS. So so ROS 2, as Gio pointed out, is robotics operating system. It's not actually an operating system, but it is the most popular framework for robotics software development in the world. So it's used by hundreds of robotics enterprises around the world, and it has a massive, wonderful online community. And basically, in robotics development, there are many aspects that pop up over and over. And ROS really simplifies the development process by providing a framework to handle these repeating elements so that you can focus on adding your own functionality and not reinventing the wheel, things that will probably exist in most robots. And one of the things that's really, really nice about ROS is that it lets you use a node-based architecture. So basically, nodes let you encapsulate core functionality of your robot and communicate with one another using, for instance, a publisher subscriber connection or a server client relationship. So let's say, for instance, that you have a robot, which I wish for everybody, and you want the robot to navigate around based on images that its camera is taking. So this is a bit simplified, but let's say, for the sake of the example, the camera node will be responsible for taking all the images. It will post the images to an image topic, and then this topic can be subscribed to by whatever other nodes are interested in it. So let's say there's an obstacle detection node that subscribes to the images, performs its own calculations, and then publishes its own messages that give information about whatever obstacles might have been detected in the images. And then we could have another node that's responsible for the navigation, and that can subscribe directly to the image topic, but also take from the obstacle topic and sort of integrate that information and do with it what it will. So obviously there'd be additional nodes, maybe one for the robot's wheels and motor, maybe another node for the battery, and so on. So that's just a basic example. And as far as hardware is concerned, ROS2 can run on a variety of hardware targets, but generally you'll find it running on Linux computers, and especially a lot of single board computers like the Raspberry Pi or NVIDIA Jetson computers. And it's also not uncommon for a robot to outsource some of its some of the more heavy computational processes, like route planning. Often they'll outsource that process to a companion laptop that's connected wirelessly to a robot. Now, as far as existing work that's out there for ROS2, again, we haven't gotten to micro-ROS yet, but for ROS2, there is already some work out there. So there is a tutorial that I did showing how to build sort of a generic node that subscribes to an arbitrary sensor data stream, runs the sensor data through an edge impulse model, and publishes the results to an inferencing stream. And
I'll
that's
grab
out
that
there.
link. I'll put it in for you, Avi.
Thanks. Yeah, I appreciate that. And in case you missed it, or if you're watching after this is streamed, Rafael and Giovanni from Pizza Robotics presented earlier in the session their work with Nanosaur using Edge Impulse and a vision model. And they've done some really fantastic work there. So be sure to check out their session. Also, just great guys. So
yes, they
now,
are.
we can move on to, didn't realize I had pictures of them.
Yeah, there you go. Well, we just saw them. We know what they look like.
Yeah. So now that we're up to speed on ROS2, we can look into micro-ROS. So in simple terms, micro-ROS puts ROS2 on microcontrollers, right? So I was saying most of the time you'll see ROS running on a Linux computer. But with micro-ROS, you can benefit from all of the advantages that an MCU would have to offer, that a microcontroller would have to offer, while still using all of the familiar publishers, subscribers, services, clients, which then makes integration with ROS2 setups very, very smooth and very straightforward. And yeah, there are plenty of reasons you might choose a microcontroller over like a Linux SoC. For instance, easier hardware access and interfacing, lower power consumption, and maybe you have some real hard kind of real-time tasks that you need done. And then there's maybe a less obvious use case that I want to talk about, which is using microcontrollers as edge AI devices within a robotics framework. So this idea of edge AI in robotics, there is a precedent for it already within robotics. Basically, you take a device and you run the neural network very close to the data source, the sensor, and then the main computer doesn't need to concern itself with all the computation. That's all handled on board the edge device, and the main system receives only the inference stream. A good example of this approach in a commercial product is the OAK-D camera from Axonis. Actually, I have one here. Love this thing. Where they have a super powerful VPU, a visual processing unit, handling all the computation. And so what I would like to sort of propose is that by combining Edge Impulse, which is really, really good at neural networks for microcontrollers, and MicroROS, which is really good at making microcontrollers work with robots, you can kind of make your own edge AI robotics peripherals. Okay, so and this is what I like to call sort of a distributed approach to AI, where let's say you have a number of neural networks, right, that you have to run. And so here you have a ROS2 Linux computer with a smattering of sensors attached to it and a bunch of neural networks running simultaneously. It will very likely get bogged down quickly, handling all of the sensor data ingest and computation of the neural networks, especially if it's a low-cost platform like the Raspberry Pi. So instead of that, you can take the distributed approach and let the sensors communicate directly with MCUs running MicroROS. Let the MCU itself handle the neural network, and then the MicroROS agent that sits on the main Linux computer will just ingest all of the inference streams and pass those on to the main system, and the robot will do whatever it wants with them. There are a few good reasons why this match is very, very good, this match between Edge Impulse and MicroROS. For one, there's very good overlap between the officially supported boards on both platforms. So here are a few examples, and this list will be growing, but the STM32 Discovery Kit with all of its crazy sensors, the ESP32, the Raspberry Pi Pico, and the Arduino Portenta H7 are a few examples of boards that are cross-compatible. And the Portenta is actually the one that I have started this project with, and I'll be expanding that to other boards in the future. So before I actually get into demonstrating anything, I want to talk about some use cases, some ideas that came to mind, that areas where this could be useful to roboticists. So one thing that I thought about straight away is this would make it very easy to add sort of a voice command functionality to a robot. You know, like you can basically create a plug and play device that recognizes specific voice commands or sounds or wake words, and will pass on the relevant info to the robot, and the robot will act accordingly. That's really nice because, you know, you could actually create something that you could then pass between different robots, and it doesn't really care what robot it's attached to. It's just this sort of standalone plug and play peripheral that you've made yourself. It can also improve a robot's situational awareness. So by tacking on, let's say, an object detection unit, maybe an MCU with an accelerometer to classify terrain. By the way, somebody named Jalsin Suryo, I hope I'm saying his name right, posted a project a couple of days ago, I think, where he used an Arduino with Edge Impulse to automatically adjust the suspension on his bicycle according to the terrain. I love that.
I saw that. I haven't had a chance to, with Imagine going on, I haven't caught up on projects. I did see that though.
Yeah, and I really, really like that. And that's a really great example of like some functionality that might not be worth the RAM on the main computer, but like if you're able to achieve that using an add-on MCU, that's really nice. And there are certainly robots out there that could benefit from that. You could also add, like, to do some environmental sensor fusion or gas sensors. You know, you could add like an artificial nose to your robot, like Benjamin Kabe did. So all of these things can just add a kind of a extra layer of sophistication to your robot. Predicted maintenance. In one of my previous projects with Edge Impulse, I used a Raspberry Pi Pico, which is, again, a cross-compatible board between MicroROS and Edge Impulse, to do sort of MCSA-style anomaly detection. And that was basically analyzing the power signal of my O-Drive motor controller. So that's also really nice. You know, for a few bucks, you know, you can buy one of these MCUs and add that to a robot, and you really, it's a big win. You know, you get a lot of added functionality for pretty low cost. Basically, it costs you one serial port. Another idea that I hope to explore moving on is creating AI-based heat maps in RViz2. And if people don't know, RViz2 is the interface people use to visualize maps and the world around their robot with ROS2, among other things. But for instance, you know, imagine being able to color the map according to terrain inference or something similar. That's really cool too. So that's something I plan on working on moving on. So I've started working on this repository, and I actually, I even have a picture. I started working on a repository of examples to this end, trying to make this happen. And so far, I have a working example with the Arduino Portenta H7, and that's running an Edge Impulse image classification model. And I plan on adding non-vision examples soon, as well as additional board support. So that's very exciting. And one thing I also want to talk about before I go into the demo part of things is that I created custom ROS2 message types. So, and this is something a slide I added in like right before I logged on here. So I hope I'm
Sneaking in
right.
slides on me? What? I'm
Yeah.
teasing. I'm
Yeah.
teasing you.
Yeah, so if people don't know, ROS2, all the communication is strongly typed, right? So if you have a node that speaks in strings and you want something to subscribe to its topic, the thing that's subscribing has to know that it's a string topic. And that just saves a lot of headaches with like incompatible data types and things like that. So that's a feature of ROS2, but there weren't existing types within the ROS2 kind of standard messages interface list that matched what I was going for with these messages. So if people are familiar with Edge Impulse, they know that if you're doing an image classification model, you have this result object structure, and the result contains many classifications. And so one classification might be dog, 75%. And the full result, though, will contain all the labels and all the values. So I created custom ROS2 message types that are called EI classifications and EI results. And the reason I did that, I made them separate message types, is basically to allow the allocation of memory within the MicroROS device to be dynamic. And I'll back up for a second. One thing that let's say normal ROS2 users might not have to mess with so much is actually memory allocation. But on MicroROS, if you have an array, a message that's like an array or a sequence of values, you have to let MicroROS know ahead of time how big it has to be. And so, the fact, if I'm using an image classification model that recognizes dogs and cats, well, that's one size. That's a result message with 2 classifications. But if somebody brings in one with 10, I didn't want them to have to mess around with adjusting or changing values or anything like that. So the memory allocation, if you use the example that I'm going to link to with the repository, it's automatic. So it'll just automatically take from your Edge Impulse library that you deployed, and it will automatically allocate the memory no matter how many labels you have. And now I'm going to try to switch screens here.
Well, and in the meantime, I'm going to cross my fingers.
Yeah.
And while you're doing that, I just want to give you a quick heads up that there's a couple of questions that we've had roll in over in our Q&A. Yeah, Nico and AB say your prayer to the demo gods. Yeah, say your prayers. So AB was asking that, in this example, this is MicroROS, but you are offloading. So you're really also still making use of a central device, maybe a single board computer, something running Linux plus ROS. In this scenario, is that correct? Or can this be completely fully independent with no need for some other device?
Yeah, that's a great question. There are systems out there using only MicroROS. There's something called the Crazyfly, which is this really awesome little drone that, if I'm not mistaken, is only has a microcontroller on it and is only running MicroROS. The only reason I would think maybe that situation isn't ideal is because the neural network that's sitting on the MCU will basically, whenever you run the neural network, that will probably use up most of the device's resources, right? So if you have other things going on, that might be a problem.
Yeah.
But yeah, it's possible. You could, if you have, let's say, okay, actually the Portenta might be a good candidate for that because you have the M7 core and the M4. And that could be a good potential there for using the M4 to handle kind of the other robot
Yeah,
tasks
Yeah.
and M7 to run the neural networks.
Yeah,
So,
which actually then leads me into my next question. Well, I shouldn't say my question, it's Jen's question, but she would like to know why the Portenta was chosen for this project.
yeah, it just worked the fastest. So
There, yeah,
yeah,
Yeah.
I'm going to be adding more boards, but I wanted to get an example out there quickly, and it was a board that was supported and a board that I had, and it worked pretty
Perfect.
quickly. And so I'm going to be I hope to be adding the ESPi, which is significantly less expensive than the Portenta, and hopefully that will also open up experimentation for other people for whom the Portenta could be a bit pricey.
All right. We have one more question from Nico, but I'm going to hold it for a second, Nico, because I'm looking at the clock and we're starting to run out of time and I want to see this demo. So Nico, hang tight. We'll come back to yours.
Sure. So look, the things I'm going to show might only be interesting for people who are already familiar with ROS, but I'm not going to show here a crazy robot doing anything, but
Yeah, no.
I want to show that, so here's my Portenta, and it's got a publisher node loaded onto it with MicroROS. By the way, you can see I can't see my own camera, but you guys can see.
You know what?
camera.
It's your screen is what is mostly showing.
Okay, well, it's not
which
really
is
important.
fine, but
I have a Portenta in my hand,
okay.
so you don't need
Yep.
to see it. But it's currently disconnected from the computer. But I'm going to connect it, and basically, I'm running ROS2 Humble on my my Ubuntu computer. This could be any computer. It could be a Raspberry Pi, Jetson Nano, anything. But I'm going to connect. Oh, and this computer is running in the background the MicroROS agent, which just needs to be open, and it just kind of sits there patiently waiting for you to connect any MicroROS devices. So I just connected my Portenta, and for people who know ROS, you can check which topics are available. So I'll do ROS2 topic list, and we'll see. Yeah, sure enough, one of the topics is the EI MicroROS publisher. So that's a good sign already. And let's subscribe to it, or echo it rather.
Avi, we don't see your terminal. Is it off screen?
You must be
bring it over.
Okay.
We must. I don't know if we have desktop too or whatever.
Yeah, Zoom put the little thingy on the wrong screen, I guess. Now can you see?
Yep. Yep.
Okay. All right, so I'll move this over here as well. Good to know. So what I did before is just did a list of the topics that are running in ROS2. So the EI MicroROS publisher is showing up, which means that the MicroROS agent is doing its job and it's picking up on the MicroROS device. And we can echo it, ROS2 topic echo, and we should hopefully see a stream of inferences. So I have just a model running, not a very, very strong model. I trained it with like 40 images, but just a model that tells you, classifies whether it's a background image or
enough to get started. Yeah, 40 images will get you going.
Yeah, the strength of the model isn't necessarily the point here.
Nope.
But you can see that it's working well. And if I disconnect it, which I'll do now, it'll stop, and it'll just wait for me to reconnect it, and I can reconnect it. So it's really, it's like I just reconnected it and it's working again. So it's like I have this sort of this plug and play AI device that I don't know. To me, that's really cool that you can just kind of transfer it between different robots and it just works. And as far as subscribing to it, I'll minimize this for a second and bring over VS Code. So here's just an example node, what it might look like if you wanted to subscribe to it. So the result, the message type, like I was mentioning before, is EI result. And that'll be new for a lot of people. By the way, there's a full tutorial for this where I show how to add the custom message types and everything. And it's subscribing to this topic that we just echoed.
Yep.
And the message has a structure: message results, and there will be as many items as there are labels in your results. And here's just a function, for instance, that returns the index of the label with the highest probability. So if I just want to print like what the model thinks is most likely to be in the image, that's what this does. So actually, let's try to run that. ROS2 run a sub result stream, and hopefully, yeah, okay, and that's working as well. So that's really nice. And as I move the camera around, it's picking me up sometimes not. Anyway, but it's successfully subscribing and working. So yeah, these are just a couple examples of what you can do. I'm going to be adding hopefully a microphone example soon, as well as a like a static buffer where you can just add your own sensor data as you wish. And with that, I think I'll end the demo section, unless there's anything else people want to see on screen here.
Well, let's actually grab Nico's question that was remaining. How do you plan the sensors to communicate with the main system, SLIP plus TCP/IP via serial or a USB serial and Ethernet directly? Like, how does I guess what does that flow look like?
So if I understand the question, you mean you have an MCU with a sensor connected, and you want to get the raw sensor data in addition to the inference? Is that what I'm understanding?
We'll give Nico a moment. No, the message connection, he's saying.
I want to look at his question to make sure I understand.
Yeah, it's over in the Q&A. You at the bottom, click on Q&A and you'll see it. I could have butchered the question.
No, that's fine. I just want to have it in front. So you know, if I'm understanding the question correctly, this really is a sensor by sensor. It just depends on what sensor you're using. So for instance, in this example, the Portenta has a built-in camera, and that's working fine. I think it doesn't really matter how the sensors communicate with your MCU, as long as you're able to draw in the sensor data and pass it as an array or pass it as a stream of values. It'll work. So I think a lot of the boards that I'll be working with for the first examples will just have kind of built-in sensors. The Portenta has a built-in camera, built-in microphones, and that kind of makes it more convenient. But moving on, it would be good to also show examples of, let's say, okay, so for instance, the example I did with my Raspberry Pi Pico, where I had it doing power signal analysis on my O drive, that was like it was serially connected to the O drive over UART and just drawing in the values from that. So that's not even a sensor. That's just actually reading values from an external module. Hopefully I understood the question, and yeah.
Well, he says perfect. All right. I'm also going to drop in the link to the tutorial. Like I said, I told you, I think I emailed you. I don't know. It's been kind of a blur the past few days, but I think I emailed you and said that the tutorial is live.
Yes.
So I just put the link in for the tutorial. The GitHub repo is now right there as well. And we're down to only 2 minutes. Jim, I'm going to promote you back up to a panelist. So you're on deck in T-2 minutes for some Azure IoT, which is also actually really exciting. Today turned out to be so great. I got all my favorite topics selected. That worked out great for me. That's what happens when you're in charge of the content.
Yeah.
But the last question I'm going to leave with you is AB was asking, is MicroROS limited to only some MCUs? Are there specific, Cortex or others as well? Do you happen to know if there's limitations?
Great question. I actually just saw, so there are boards obviously that are like officially supported, that they just have fleshed out examples for, that, you can kind of trust that they've worked with and it's going to work. There are also community contributed boards that people are adding kind of as they go. The short answer is no, there's no limit. And actually, if you look at the ROS forum, somebody just, I wish I could remember her name. Somebody just posted a post where basically they said, now any STM board is fair game. They made a really great tool that integrates with the Cube IDE for STM32. And you can use any STM32 board now with MicroROS. As far as boards that are compatible with both Edge Impulse and MicroROS, you know, some might take more work than others, but no, there's really not, at least it's known to me, any hard limits on which MCUs you can use.
Awesome. All right. Well, thank you, Avi. I appreciate it. I appreciate you taking the time. Like I said, I know it's getting late into your evening there in Israel, and for showing this kind of work, because like I said at the start of this session, I'm not sure anyone else out there is doing this. You know, it's certainly possible, but I'm just not aware of it. So thank you for, you know, really, really bleeding edge stuff here. All right, Jim, let me get you promoted back in. Where are you? Here you are. I have to promote you to a panelist. Jim, you are coming into the stream. Get ready. And Avi has dropped out. Thank you again, Avi. I appreciate it. Jim is here, and hang on for a moment because I still need to promote you up to a panelist, make you a co-host, because I think you may have had some slides or something that you might want to screen share. So
I do indeed.
All right, we should be all set. All right. Well, thank you, Jim, for joining. Happy Friday to you. I don't know how long you've been watching, but we've had some excellent sessions thus far. I have to admit that Eric Pan joined from the jungle in Colombia. So I'm not sure. I don't know if you're going to be able to top that one, but you appear to be inside of the Death Star.
I mean, I joined from a long, long time ago in a galaxy far, far away.
So okay, so you know, this is actually, this is kind of, you know, it's a close second.
It's a close second, slightly more geeky, but not quite.
Yeah, no, that's all right. I love it. I appreciate that you're here. I'm excited to learn about the topic. You know, I have some basic background knowledge on Azure IoT, IoT Hub, and you know how to use it. So it's been a while though since I've played around with it. I'm really looking forward to getting some what's new, some updates from you. Let me do this. I'm going to turn it over to you. We're only 3 minutes behind schedule. Not too bad. Not too bad, right? So I'm going to turn it over. You go ahead. You can introduce yourself, say hello, give us some background, who you are and what you do, and take it away.
Awesome. Well, thank you. Appreciate the invite to be here. And as mentioned, this is all about what's new with Azure IoT, with the aim of getting you building your solutions a lot faster. That is kind of the big aim behind what we're working on in Microsoft around the Internet of Things. Now, I will mention this was told to me, but there is going to be a prize giveaway happening during this session. So there is a re-terminal that is being given away. There'll be things in the chat. That is the device.
I don't know if you guys can see me or not, but it is right here. It is on my desk. I've got it. And yes, I will try to sneak in a quiz or a contest of some type. So Jim, you can do your session. You don't have to worry about it. I'm going to monitor chat, and I'm going to, while I'm watching, maybe make a quick mental note of something, and we'll make sure the audience is paying attention. I'll give them a quiz on it.
Nice. I'm very jealous. I want one of these devices.
You want one of these? You don't have one of these?
I don't have one yet.
Compatible with Azure. You've got to get one. It's a certified device.
I will get one day. I will get one. Cool. Anyway, so let's dive into Azure IoT, but let's just imagine this. It's a Monday morning. You've got into work, or you're working from home, and donuts arrive. Your boss has sent you donuts with a little surprise inside, because bosses like to have a carrot and a stick, maybe give you a surprise with something bad. And that surprise is you've been told to create an IoT device. You've been given an IoT kit, and you've been asked to create an IoT device. Maybe you work in telematics and you've been building mobile apps and now you're looking to put an IoT device inside a vehicle. Maybe you are working in manufacturing, you're building machines, you need to put IoT devices, put sensors on them. For some reason, you have been moved to a project to build IoT. That's your problem. Because IoT is hard. I think we all agree IoT is hard.
Yes, I agree with you. I have some experience. It is hard.
It is hard. There's different tool chains, there's different devices. It is hard. To me, IoT is like desktop web development was 25 years ago. There's some tooling there, but we haven't kind of got to the point where we are now, where it's kind of one click and everything works. IoT is hard. And that is completely true, but it is getting easier. The acceleration from it's really hard to it's easy that's happening like the world of web and desktop has taken 25 years. IoT, that's happening a lot quicker. It is getting easier. And that's kind of what the focus is at Microsoft. So my name's Jim Bennett. I'm a regional cloud advocate of Microsoft, which means it's my job to do this, which is cool. But I'm all over the internet, Jim Bob Bennett. So feel free to reach out and connect. Any questions you've got after today's session or any questions you've got in the future about this, about IoT, anything like that, please feel free to get in touch. I love geeking out with folks on IoT. So all over the internet, Jim Bob Bennett, please feel free to connect. And so let's talk about a few things that make building IoT applications easier. And the first one is the rise of the RTOS. The RTOS is something that is helping us to build IoT applications quicker. The idea of an RTOS is a real-time operating system, and that's an operating system for microcontrollers. So if you've not come across RTOS before, we'll give a quick overview. If you have, feel free to doze off for 30 seconds while we just go through this overview. But the idea is it's an operating system for microcontrollers, so you don't have to dive in deep to vendor-specific frameworks. You can build your code against operating system APIs, and then if you need to port your code from device to device, you kind of can. So you're building against maybe a prototyping board, the one that your boss kindly hid underneath a glazed donut, and then you need to port it to maybe a production type board. You can do that. You can just take your RTOS code and port that over. Some code has to be changed in terms of deploying to the board, but in general, your OS level code stays the same. Now, a real-time operating system is that. It's designed to run at real time and process data from sensors and other hardware in real time. Very different to Linux, Mac OS, Windows, general purpose desktop operating systems that are designed to run games and videos and coding environments. These are designed to be as low level as possible, as lightweight as possible, and process data in real time. If you have a sensor sending a vibration data, for example, 10 times a second, this will be ready to pick up that data 10 times a second in real time. And these are lightweight. These are designed to be really small. In a lot of cases, you get the OS as code. So you literally just compile and link in just what you need. You're not getting a whole load of applications that you're not touching. You are literally linking out even down to the function level of stuff you don't need. So we're talking these OSs run in kilobytes of memory and run fast on constrained devices. And then the great idea behind them is you code against the OS on one device, and then you can port to different architectures or different tool chains. Your code stays the same. Now, in the Azure world, obviously I work for Microsoft, so Azure's my jam. We have Azure RTOS. We're not very good at naming things. We like to have very, very, very sensible names. So Azure RTOS is the RTOS.
That's not too bad. That's not that bad. It's I've seen better. I've seen better, but it's good.
It's not exciting, but it does what it says in the tin. This is an RTOS for Azure. It's got to inherit the name. But yes, Azure RTOS has got a whole of cool features that you would use inside your application. So you've got the basic scheduler to make sure your code is running in real time. But then you've got networking and Azure connectivity libraries, GUI libraries, file handling, and a whole lot of other technologies that you can then build into your application. Now, it starts off with this base called ThreadX, and that is our scheduler. That is what everything is built upon. ThreadX, and then you can start building up layers on top of that. So we have ThreadX, which is our scheduler, GUIX for UI, FileX for accessing Flash, LevelX to make sure that when you write to various different Flash drives, it actually puts the data across different sections so you don't end up wearing out one part of like a NAND array, for example. We then have NetX, which is for networking, connects into the internet, connects into Microsoft Azure, USBX to control USB. And you kind of bring in the levels that you want, and then you write your device code over the top. And then this whole thing sits upon whatever architecture you're building, so you can port it across different hardwares. Now, what's cool with Azure RTOS is it's been built against a whole load of industry standard boards. You know, any STM board, for example, you can run it on. A whole lot of other boards you can run it on. But we've also been looking to do community ports. So it runs on Arduino or RP2040 if you want to try it on different devices, which is really cool. So kind of great for prototyping before you settle on your final production level board. And it's all in C, so you write in C. So if you've got an Edge Impulse model, you just compile that up, drop it on, and you can kind of run that on your board under Azure RTOS, which is pretty cool. And it's battle hardened, for want of a better expression. It already is running on 10 billion devices across the solar system. Now, I'm not just saying this because I'm from a galaxy far, far away. It is running on 10 billion.
Solar system or a galaxy?
Only the solar system. Only the solar system. Not quite galaxy yet. But this may sound like I'm being a bit overdramatic, but it's actually true. It is actually true. So Microsoft mission statement: empower every person and every organization on the planet to achieve more. Yeah, we outdid that by putting HoloLens on the International Space Station, but really we are reaching the solar system. So NASA runs ThreadX on some of their deep space missions. So for example, Deep Impact, where they collided a rocket with a comet to gather data, that was running ThreadX. HiRISE on the Mars Reconnaissance Orbiter is running ThreadX. So literally the core of Azure RTOS is running on Mars, in orbit around Mars. So, you know, we are reaching the entire solar system. So this is space grade software, which I think is very, very cool. So let's just have a quick demo. Let's just look at one example of Azure RTOS to get going with. So I'm zipping over. I'm a Mac user by default, but Azure RTOS doesn't really work on Mac. So here I am on Windows, and I'm just going to launch a quick demo to kind of show you some of the code for Azure RTOS. So here I am inside Visual Studio Code, my favorite development environment. And I've got a very basic Azure RTOS application that runs on an MX chip Azure IoT Dev Kit, which is this board here. The reason for choosing this board is I've got about 100 of them. It's a great board, packed full of sensors, and it's just a really good developer board to get started with. And so I just want to build a simple thing, or simple application to pick up accelerometer data and send that 10 times a second that I could use to train a model. And so I've got my application here. I start off my ThreadX kernel. So I say start the ThreadX scheduler running, and then inside my ThreadX, I then say what I want to create. So I'm creating a sensor timer. Look at the code for that. I say to ThreadX, create a timer that ticks. You define how many ticks a second your application runs at, and then with timers, you say how many ticks per timer. So I've got 100 ticks a second, 10 ticks per timer. And so that gives me once every 10 times a second, my timer will run. But I can create timers and create background threads, kind of whatever I want, I can create, and ThreadX will manage all that for me. So I can just build this, and then I can run this. While this is running, I saw a question saying, what was the dev board that you're using? So it's the MX chip Azure IoT Dev Kit. I'll try and grab a link to that.
Thanks for grabbing that.
In a second. While this is launched, while this is running, let me actually. And here's a. I'll drop this in. Let me just. I'm going to type the answer and just drop it in the Q&A. I don't know whether that zips over to the right place, but that's a getting started guide for the board, including more details on the actual board itself and where to get hold of one.
Thank you, Jim. Perfect for grabbing that. Appreciate it.
Hey, no worries. I love this board. It's been around for a few years, but it's a fantastic board, and it's got the connector on the bottom is the same one as the BBC Microbit. So if you buy like a robot for a BBC Microbit, you can then plug this into that and control it, which is quite cool. Cool. So I've got my code running. I'm just going to connect a serial port, and unfortunately, there's no font size on this terminal, but you can see 10 times a second is ticking out accelerometer data. So I've got my data coming through. And then if I want to add more, I'm not just limited to a single timer or a single thread. I can add as much as I want, depending on how powerful my board is. So if I just bring in another timer, for example, bring in a heartbeat timer, let GitHub Copilot write my code for me, because writing code is, it's old fashioned. We don't write code anymore. GitHub Copilot does it for me. Yeah. GitHub Copilot for the win. So I've got a heartbeat timer here, same idea, except instead of doing it every 10 ticks, I'm doing it every 50 ticks. So twice a second, this will tick off. And like I say, I can add as many timers or threads as I want, and ThreadX will manage it all for me. So if I just run this, give this a second to build and deploy. And then you'll see, I'll just stop it to stop the scrolling happen. We have heartbeat, then 1, 2, 3, 4, 5, heartbeat 1, 2, 3, 4, 5, and so on and so on and so on. So I can just add as much as I like, and ThreadX will manage it all for me. And then what's cool about this code is everything in my app folder here, I can pretty much take to another board. Got a little bit of startup code that's relevant to the STM32 chip on the MX chip board, but I would then change this for the vendor specific code for different hardware, but the rest of my code remains the same. So much easier for getting code from one platform to another. So that's a very quick view across Azure RTOS and what you can do with that. Let's think about the other side of IoT. Yeah, Azure RTOS is about the T, the thing. Let's think about the I side, the internet, and talk a little bit about IoT SaaS platforms. This is another way we're building applications quicker. So an IoT SaaS platform is a software as a service to allow you to build an IoT application, ideally with low or no code. So if you connect an IoT device to a sort of a simple message broker style system, where you're just connecting data and sending data, you have to then build out your application. Your device puts data on a message broker. You then have to take the data off the message broker, plot your own charts, build your own rules, analyze your data. And that takes a lot of work. Whereas a SaaS platform is designed to give you all that pre-packaged in some kind of application. So you don't write code, you like drag and drop charts and dashboards, you add rules all through low code or no code, add data exports, kind of however you want to get data out, you do this without code. And the big power of this is this opens up your IoT application to non-coding individuals. So if you've been to any of my IoT talks before, I keep talking about how, as an IoT engineer, my best friends are machine learning experts, data scientists, and domain experts. And certainly with domain experts, sometimes these are not technical people. And so if I can have a platform where they can add rules without having to write code, that opens up to a whole load more people. And so in the Azure world, our platform is called Azure IoT Central. And that's our secure IoT software as a service platform. Secure because every device that connects has to be authenticated using either a certificate or a SaaS token. And IoT Central manages a lot of this for you. So whether you've got an IoT device, a gateway device connected to legacy hardware, or edge devices, light edge, medium edge, heavy edge, whatever, you can manage and provision all that through Azure IoT Central. Provisioning is where you put like a certificate on your device and it will automatically register itself with Azure IoT Central as soon as it's connected. And you can also export data. So it uses the standard protocols across the whole of Azure as a cloud to get data off and put this into other platforms. So if you want to put data into storage or ship it out to some kind of data explorer or a pipeline for machine learning, you can do that. You just set up exports. You can create alerts. If you're building telematics, for example, with a temperature sensor on a refrigerated truck, you could then get a domain expert to say, well, if the temperature gets above maybe minus 18 degrees Celsius, I want to get an email. They can create that without writing code. We also support this concept of plug and play. So that if a device is a known device, it's part of our device catalog, like the reterminal we spoke of earlier, you can plug that in, connect that to Azure IoT Central, and that will automatically set everything up for you in the application. It knows what data it's going to receive and it knows how to render that data on screen. It's got a whole load of power without having to write any code. Now, we're not quite as, I wouldn't say global, we're not quite as solar system wide with Azure IoT Central as we are with Azure RTOS. We have Azure RTOS on Mars. We don't have Azure IoT Central quite on Mars yet, but this is something that is being used by large companies for kind of fast deployments. Keurig, for example, have recently released some internet connected coffee machines that are all powered by Azure IoT Central. So this is a service that can scale. This isn't just like a little toy thing that you might want to play with 10 devices. This can scale to the hundreds, thousands, tens of thousands, hundreds of thousands, millions of devices used in a consumer device setting or industrial setting, which is pretty cool. So let's do a quick demo. Let's do a quick demo, and let's kind of bring the two together. Let's
Wait. Did you say your prayers to the demo gods?
I didn't quite sacrifice a chicken,
You,
but I did.
oh no, this isn't gonna work. You can say, oh boy, all right, we'll see. Give it a try. Tease it.
We're going to be fine. We're going to be fine. I did say a prayer to the demo gods. I've burnt the incense. I've made the offerings.
Oh,
I think we're going to be. But what I'm going to do, I'm going to bring together Azure RTOS and I'm going to bring together Azure IoT Central all in one. So I've got an Azure RTOS application here, and I'm going to use this to create a device in Azure IoT Central. So I'm going to zip to Azure IoT Central. It's over here. Create a new device in here. I'm going to call this, just call this one MX chip. MX chip. Give it a name, give it an ID. And I'm not going to give it a template. A template defines the data that the device is going to send. I'm not going to define that. I'm just going to leave it blank. Get this one created. Got no data here. Device is disconnected. If I click my connect button, this gives me the information I need to connect to device. Got an ID scope, which is like a unique ID for my application. I have my device ID, the unique ID of my device. And then in this case, I'm using a SAS token for security. So security is very important. You know, the S in IoT stands for security. We know the joke, but security is very important. I could use an X509 certificate, but I'm going to use a SAS token here. Yes, you can see my SAS token. Yes, this is not very secure.
Hold on, I'm trying to write it down.
Yeah, and yes, I'm going to be deleting this as soon as this session is over. So, you know, you can try and hack me, but good luck.
Ah, it's all in good fun.
Yeah. So I'm going to drop these tokens in here. While this is building, let's have a quick look at this application. So instead of creating a timer, I'm creating a background thread that connects to Azure. And this background thread, it's set on a thread priority, so you can define which priority threads run at, and it kind of chooses what's more important, what's less important. You know, reading from a sensor might be more important than sending to the cloud because you want to catch the data when it comes in. Doesn't matter if it's delayed a few microseconds going to the cloud. So I've got my thread here, and my thread uses onboard libraries to connect to the Wi-Fi, and then you connects to the NetX, which is the layer for talking to the internet, and then connecting to Azure. So if I just run this up, this will build, do its thing. And then when this starts up, it'll connect to my Wi-Fi, it'll connect to Azure IoT Central, it'll provision my device, and then some magic will happen, hopefully. Just need to give this a few seconds to build and deploy. There we go. We're running. I'll go back to my serial terminal, and we're connecting to my Wi-Fi. Give this a few seconds to connect. And then NetX is handling DHCP, it's handling the DNS, it's handling SMTP. I need the time because I'm connecting to a secure, I'm making a secure connection. So I need a time stamp. So I need to connect to SMTP or some from NTP server to get time. So it's all synced up. Then run the DPS, device provisioning service, to connect to Azure IoT Central. It's now connected, and my main thread is just running, and it's going to be processing telemetry every few seconds and then sending that telemetry up to the cloud. And there we go. Got humidity, temperature, and pressure. And so if I go back to Azure IoT Central, what we'll see under my devices, I set my device templates to unassigned. I just didn't assign anything. Now it's been changed to MX chip getting started, because the data that was sent what's called a model, which defines what data is going to be received. And so suddenly I get all these charts appearing. I didn't create these, just somebody created in our device catalog a model that says, when I get this data, this is how you render it on screen. And so I suddenly get all my charts here, and I can see graph of temperature, I can see data from all the various sensors on board. I can send commands, like I can set this to true to light an LED. We've seen the LEDs come on. I can send a command to write some text. Yeah, this is kind of operator stuff I can do. So we say hello, and I'm communicating with my board without writing code. If I want to then explore data, I've got a data explorer. I can just choose the devices I want. Let's look at maybe humidity, group by device ID, and I've got some data appearing here, and I've got a nice little way to explore data. So I've got this kind of built in. If somebody wants to do data analytics over multiple devices, they can do that from here without writing code. If I want to create a job. You maybe once a month send a message to the device to reboot. I can create jobs to do that. Again, don't need to write code. I want a rule, you know, if my temperature goes over a certain point, send me an email. I can create that. No code, operator level stuff. If I want to do data export, I can say, yep, you know what? Let's export data to storage or a webhook. Anything I want. Again, I don't write code. All handled through the SaaS platform for me, which is very nice.
This is too easy, Jim. This is too easy.
It's too easy. It's too
This
easy.
is just too easy.
We're constantly making it easier as well, which is really, really cool. IoT should not be hard.
I'm looking at the clock. You are right on time. We've got 5 minutes left that we can use for any questions. I haven't seen any questions come through chat. Mithun, thank you for joining. You are right on time, but you have to wait for 5 more minutes because Jim still has 5 minutes of Q&A. So you sit tight down there, Mithun.
No questions come in. I do have a couple more things to point out as well, very quickly.
We had,
just
well,
to
you
help
had grabbed the one question on the fly, and then the rest were mostly just some comments. But go ahead.
I'll drop this up. This is the link. So go to github.com/AzureRTOS. This is all the source code for Azure RTOS, all the license agreements for it, and the Getting Started repo in there has got what I did. So if you want to recreate what I did, the Getting Started repo has that for the MX chip, for the STM Disco board, and a few other bits of hardware as well. So that's kind of a good way to get started. A few more things I'll just run out very, very quickly. We have got things like a new out-of-the-box experience. You literally download a script and run it, and in 4.5 minutes, you get a number of devices connected to the cloud, which is really, really cool. And for that, this link here takes you to a video where the project manager on that actually talks me through how it works and gets an STM board connected to the cloud in 4.5 minutes, which is very cool. And we also think about what else we can do with the data. So we have the idea of digital twins, and then we've got a 3D scene studio. So if you set up digital twins of a device and actually render on a 3D map an actual device and the data with it. And one example we've got on a video here shows the International Space Station, live data from NASA being rendered to a 3D model. And you can put on a VR headset and see that in anywhere that you like. So yeah, so that is what's new. We've got our RTOS support growing, IoT Central improvements, and then we're working on out-of-box experience and 3D visualization. And from the biggest point I want to make is we are constantly focusing on our IoT platform to make it better. I know there's a bit of nerves around the cloud providers for IoT because one of the big cloud providers has recently deprecated their IoT service. You've got till August to get off. We are not doing that. We are growing. We are constantly pushing that. So kind of a good thing. Good thing to bring up. A couple of questions that appeared. One question says, what is the cost? So for Azure RTOS, for certain hardware, it's included. So it's free with the hardware. For bringing it to other hardware, it's a get in touch and we can talk about licensing.
Yep.
It's not free. Obviously, you can play with it at home, but if you want to use it in a production deployment, it's not free, but certain hardware comes with that pre-included. Otherwise, it's get in touch and we can talk to you about the licensing model depending on your needs.
Perfect.
Thank
you.
And then Jen's saying, what are my favorite applications for using an RTOS? I don't know, actually. I've never kind of thought about that. I mean, I love the whole on Mars thing. I love the fact that it works in space, the fact that it's reliable enough to put actually in space. The fact it's running on the MRO, I think is amazing.
That's super cool.
Yeah, that is super cool.
And thank you, Jen. I see you've been answering questions in chat as we go as well. Really appreciate that. What else? Anything else?
I mean, that's our kind of overview, really.
Yeah, I think
that's all the new stuff. You know,
I love it. I love it. That's super exciting. There was one. So Paul is asking, how does one get in touch regarding pricing? You know what? If you want to go back, you had your contact information, I think, on one of those early slides, Jimbo.
What I will do is, if you contact me, ask do the pricing, the answer will be, I don't know. I can tell you all about Azure. I cannot sell it to you. But if you just Google with Bing for Azure RTOS, we do have all the pricing on our Azure RTOS site.
There it is, right.
So here we go. So there's no cost to test, explore the source code. So if you want to grab it, test it, you can do that. And then if you've got one of our pre-licensed devices, So STM32, MediaTek, Microchip, NXP, or Renesas. If you've got one of those devices, then it's pre-licensed, so you just can use it. Other than that, you need to contact RTOS sales. If you contact me, the answer will be, I don't know.
I don't know. Talk to sales.
Yeah, talk to sales. I don't
That's
buy
what I
it.
say. That's my line.
Talk to sales.
Talk to sales. Yeah, here's
But
their
yeah.
information.
So yeah, if you just Google for Azure RTOS,
Yeah.
and then just head to the pricing, that's how you can contact them for more. Obviously, if you are a manufacturer and you want to get it licensed for your board, again, talk to sales. The more boards we can have pre-licensed,
Sure.
the better. So.
Makes sense. All right. Well, thank you, Jim. I appreciate you joining. Appreciate you taking your Friday afternoon.
Appreciate the chance
Super,
to be here.
super interesting. And let's see. Where is Mithun? He's going to be coming in to show us. There he is. Hey, speak of the devil. Popped right in. All right, Jim. Thank you for taking the time. I appreciate it. And Mithun, we're going to turn it over to you. All right. Let's get you set up. All right, Mithun, I'm going to promote you up to...
Am I live already?
You are, but I still need to promote you to a co-host so that you can screen share. And that will be right now. And yes, you should be good. So thank you, Mithun. I appreciate you taking your Friday afternoon and joining us as well. I'm excited for this this session because this is one of our first project deep dives that you know, the Expert Network built. We had earlier a recyclable sorter built by Zelmatech that was really truly intended to be a production scale device. But I think this is our first one where you're going through and showing off something that, you know, you as a maker built literally right on your desk and went through the, you know, the iteration of developing everything. So I'll go ahead and turn it over to you, Mithun, if you want to take a moment or two to introduce yourself. And I know you have a slide deck because you sent it to me. And you said, is this okay? And I said, of course it is. It's great. So go ahead, Mithun. Go ahead, intro, and take it away.
All right. Hi, everyone. Thanks, David, and thanks to Edge Impulse for inviting me. And I'm super excited today. Like, I think this is my second time presenting something in Edge Impulse Imagine. My name is Mithun Das. I'm a member of Edge Impulse Expert Network, though I don't consider myself as an expert, rather I'm a learner. But anyway, so today I'm going to talk about one of my recent projects, which I built using Sony Presence, DevKit, Edge Impulse, and Amazon Web Services. And at the very high level, that project is trying to solve one of the critical problems with oil delivery. I'm going to talk more about that. And if you have any questions while I'm presenting, you can hold on to that. And at the end of my presentation, I'll take those questions and try to answer as I can. So before I jump into my presentation, I like to make sure I can share my screen.
You should have the right permissions. Double check. It'll be down at the bottom in the middle. No luck.
Yeah, it's saying one panelist can share at a time. And I think I'm the only one.
Share at a time. Let's see. Who else is screen sharing? I don't see anyone else screen sharing. Make.
There you go. I think I'm getting it.
Think you got it? All right. Come on, Zoom. I'm not screen sharing, so why could Mithun not? You got it. You're live, and I am seeing some PowerPoint right now. We're good.
You're seeing it?
Yep, sure am.
Awesome. Okay, so let's dive in. So as I was saying, today I'm going to talk about a project which is basically measuring analog gauge using computer vision. So what is the problem actually we're trying to solve? So if you live in a cold country like East Coast of America or some places in Europe, probably you are familiar with this situation. Like we use heating oil to heat up our space, like a home and commercial building and all those areas during winter months. And just based on the statistic, in 2020 and 21, about 5.3 million households in the United States alone used heating oil to heat up commercial spaces and the resident. Also, statistics shows 17% of total heating system in Europe actually run on heating oil. Now, so the companies, like how that the whole system works. So we have heating oil companies like who deliver oils. Like we have big tanks, like 100 gallons or 200 gallons, somewhere sitting in your basement or maybe outside of your residence. And then there are the delivery companies. They have big trucks that comes like every month or maybe every 2 weeks based on the based on how brutal the winter is, and they deliver the oil. And the problem is they actually do the estimation based on some algorithm, like how based on your previous usage data, and there are some other factors like they call it K factor. So that's basically checks the degree of change in the temperature during winter months, and it also take into account your previous uses, and based on that it calculates and then it actually delivers the oil. But imagine like this is just an algorithm based on some data which is not real time, and there are a lot of errors. So imagine a family is going on vacation for 2 weeks and there is no need to like refill the tank, but your oil delivery company will come in and then probably they'll just fill 10% and then they'll go. On the other side, there are situations where you are getting a lot of visitors during Christmas and you are using a lot more oil than you usually do. And if the oil company is just going by estimate, like they will never show up. And then if you are not actually observing your oil meter, then you are out of luck. Like all of a sudden in the morning, you will see like your heating system is not working, and because you don't have any oil. So that's a big problem in the cold countries like where I live.
Yeah, I think Mithun, I'm sorry to interrupt you, Mithun. I think it's interesting because, you know, I'm in Phoenix, I'm in Arizona. I don't need a heater. It's always hot. But I actually grew up on the East Coast, and we had the scenario that you described, which was a giant tank in the basement and the truck comes once a month. It's I don't know if it's a worldwide thing or not, but the entire eastern seaboard of the United States and the whole Northeast, every single house has it.
Yeah, exactly.
Yep.
And even like with the older houses, like we usually have like diesel, and even with the newer houses, they are using propane, but still the system is there.
Yep.
Like there is a delivery truck.
Literally millions of people, every single house. It's a whole distribution network of this legacy infrastructure. Yeah.
Yeah, exactly. And now, so as I was telling you, the problem, so the incorrect estimation actually creates a lot of problems. So one is definitely no heat during cold winter months. That's a big problem. It can take lives. And there are some other problems, like if the oil delivery truck is coming too frequently, or like when they don't need to come, they come in and then fill up your tank like 5% or 10%, then they are actually wasting their money to make the trip. During winter time, they are paying extra money to the drivers. And also don't forget, every time they are driving their truck, they are adding CO2 emission in the environment and wasting fossil fuels. So there are some environmental issues as well, like not very big, but still, if we can reduce some, that counts. Like every little CO2 footprint we can reduce, it counts. Now on the slide, you can see a beautiful picture, like a very like snowy day, white all around. So we love that during Christmas. But just imagine, like whoever live in winter countries, they can relate this picture. Like it looks beautiful, but just imagine, it's just after a snowstorm and you lost your power and there is no heat. And that's exact same situation which might happen if you run out of oil and there is no heat at the house. So it's all about the problem and how we can solve this problem. Like, is there any better way to do the estimation rather than legacy algorithm-based system? Of course, we do. Like with the use of TinyML or machine learning model, we can actually make better prediction instead of just using old legacy algorithm. We can try to see the gauge, like though it's analog, we can still using visual regression model, we can try to see and then make a better prediction than the legacy algorithm. So what I try to do here is basically, though you can imagine there could be other solutions, like you can put some sensor in the tank and all sort of different things. But the idea here was to build something non-invasive, because those tanks, those are sitting in basement, like those are old. Like there are houses which are like 50 years old, 100-year-old, and those tanks are like equally old. And no one wants to touch that. Like no one wants to put and like open the tank and put some sensors. Like that's very risky, and you can damage the entire tank, and then the replacement cost would be very high. So the idea was to do something without touching the tank, like non-invasive. And using machine learning, particularly computer vision, you don't need to touch the tank. You can put that camera somewhere from where you can see the gauge, and then it will read the gauge, and based on that, it will run the machine learning model on the edge device, and it will give a prediction. And that predicted value can be sent to the cloud, and the oil delivery company will have their dashboard, and they can make real-time judgment, like when to schedule the delivery and all sort of things. So basically, idea is real-time monitoring using visual regression. I'm going to talk more about this in subsequent slide. So of course, as I said, it's a visual regression. So I'm talking about machine learning model, and of course, I used Edge Impulse to create the machine learning model, particularly it's a visual regression model. And before I go in deep, let me talk a little bit about the hardware I used. So I have used Sony Presence Dev Kit along with LTE like expansion board and the camera. I put the QR code here. So if you scan, it will take you right to the page from Sony where you can see more detail about this dev kit. But in a nutshell, this is a compact like dev kit with a camera and LTE module. So it has the SIM card and it can connect to the internet using cellular connectivity. And of course, it's fully supported by Edge Impulse. What does that mean? Is basically Edge Impulse has firmware created for Sony Presence. You can just flash your device and you can connect to Edge Impulse Studio right from the device without doing any coding. And you can gather data, like you can gather images and build your model, and you can deploy back without even doing any coding. Now, what I did here, so basically, with the gauge, like you can imagine, as I was talking about reading the gauge and then making a prediction. So what I had to do is basically just go to my basement every morning and take a picture and then build my data. But that's very tedious and very time consuming. And so for that, to not to do that, what I did, I basically built a 3D model of the gauge. It's not exactly, but it's kind of representing the gauge. So in real life, like if we want to build this project in real, probably we'll be taking real pictures from the tank. But for now, as part of this POC, I was good with the gauge I created. It's a 3D printed, and you can let me show you. Like I already have it in front of me. So this is the gauge I created, and I can do these things, and I can move it. So this is how I basically collected my data. And this is the whole setup, and you can see I have Sony presence with the camera mounted on it, and this is the whole device. And then comes the data collection. So I use the firmware created by Edge Impulse, and I flashed my device and started collecting the images. One thing to notice here, like usually when you do image classification, you put the labels, like something like you see something or you not see something, dog versus cat. But here I'm using a visual regression model where the output is basically a scalar value. It's not a label. So what I did is basically when I was uploading the images, so in place of label, I was actually giving the like reading value. So whether it's a 10%, 20%, 50%. So that's where it basically gives you the scalar output, like your percentage of your reading. So that's the difference between regular classification versus the visual regression model. And challenges, as I was explaining, like it was very challenging project, honestly. Like just collecting the data itself was very challenging. And imagine in real life situation, you'll face a lot of other problems just about the images, because in the basement, some basement has no lights, or some basement has different lighting conditions. They have different backgrounds. Some of the basements are really crowded with so many different things. So it's not exactly same all the time. So you have to gather a lot of different data. But if you're just building it for your own purpose, probably it's your own basement, probably kind of static background. But imagine if you're going to do it for a lot of different people, then you have to think about collecting variety of different images from different backgrounds and different lighting condition. Now, once you collect the data, basically the images, then you go to Edge Impulse and you create your impulse. So creating impulse, if you are new to Edge Impulse, then you can just create an account. It's free, and then you can get started. There are a lot of materials online, even from edgeimpulse.com. A lot of materials which you can follow and get started. But this is create impulse is basically creating your model. So you give the input as images, and then you choose your like a digital processing block, which is again image here. And then you select your learning block. So basically we are doing visual regression. So I chose Keras regression model. And then, as I said before, the output would be a scalar value. So your predicted value. And then once I was done with that, I did some testing, and the testing accuracy was pretty good, 98%. but honestly, like don't just go by that number. It shows very high, but honestly, it was not that high when I actually ran the model on the device. But still, I was getting around like 80-90% confidence level, but not exactly 98%, and that's maybe because of I did not have a lot of variety of data and different lighting condition. I was basically testing in my home office and also in the basement with different lighting condition. But on an average, I was getting quite good prediction, like I would say like 80 to 85% confidence level. And then when you will build that, like if you are curious about this project and you want to give it a shot, one thing you need to keep in mind is basically the RAM uses of your model. So when, because that's another challenge I faced during my project, because initially I chose 96 by 96 RGB image, and the model size was a little bigger. And I don't exactly remember the peak size and flash size at this moment, but it was high, and I had trouble flashing that, not flashing, running on the presence. It was getting out of memory issues. So I had to reduce the model size, like image size, and move to grayscale image rather than RGB. So those are the things you need to experiment. And there are options, like if you are just using Arduino IDE, then there are options you can select different footprints or memory uses. So those are the things you need to experiment and then try to find out the right model for you. So this is what I use. So definitely I chose the quantized version of it because you can see the RAM usage was 144K, which was perfect to run on the device. I chose that, and that was the confidence level I said before. And if you need to, and I documented the entire project on Hackster, and there is a QR code. If you scan that, it will take you right to the project, where you will see all the details about the project and what I did, along with some other information which I was not able to cover during this presentation. And then, so that was the TinyML part of it, machine learning, Sony's presence, and all good. But actually, what you'll do after once you are done with TinyML model, you have the prediction. You need to send that to cloud, or I mean internet, and then do something. So that part is here. So again, as I said before, now Sony has LTE board, and it has a SIM card, so it can connect to internet using cellular connectivity. And what I did is basically once I was getting the prediction on the device, I was using cellular connection and making connection to AWS IoT code and sending the predicted value to AWS. And then from there, I basically created one AWS IoT rule. So what it does is basically whenever there is a data in the topic, it will call or invoke the Lambda function, and then that Lambda function will basically use GraphQL mutation and send that data to DynamoDB. And on the other side, I had that dashboard where I'm basically showing the data coming from DynamoDB. So also I have the demo video on YouTube. I'll share the link as well at the end of this presentation, and you can go and check that out, where I basically explain in detail how the AWS part of it works, along with the dashboard. And challenges, I already mentioned. I'm not going to go in detail again. And what I did not tell yet is basically GPS connection. So that's something I could not get it working, honestly, with Sony. So probably just my bad. But I'll give it a shot some time and to see if that works. And as I said before, so this is the YouTube video link. You can scan it and you can watch it.
Yeah, Mithun, I put the GitHub, not GitHub, the expert documentation repo into chat for everyone. And, then from there they can sort of branch out. But this is perfect. You've got your contact info here. Mithun, you talked too fast. We still have a minute to spare. You're
5 more minutes. Awesome.
You went too quickly. Yeah.
Yeah, I was basically nervous that I won't be able to finish the slides.
No, you did perfect. We did have one question come in from Carlos, and he says, why did you use a combination of AWS and Azure? But I don't know. Wait a minute, can you go back?
I did not. I think the previous presentation from Jim was from Azure, and so probably that's why the question came in. But in this project, I used AWS only, not Azure.
Only AWS on that. I was still chit-chatting. I had some commentary going in chat. I have been a little bit behind on getting my quiz questions entered. I get wrapped up in the presentation and the material and engaging with the speaker, and then I forget to do my prize questions. So I'm way behind on my prize questions, but I'm trying to make up some ground. Because quite honestly, if you go back a few slides, you had a picture of the Sony hardware that you were using, and Armagon, I know you're in that in there watching. Armagon gave me a couple of, which way is the camera? A couple of these senses. Yes, because Armagon was at Imagine in person 2 days ago in Mountain View, and I've now traveled back home. I'm back in Phoenix, but while we were there, Sony had a demo table and a booth set up and was showing off the hardware, was showing off a couple of projects actually. And there's Armagon, she's in chat. I knew she was there. And she gave me a couple more to give away. So I'm a little behind on my questions and my quizzes, but this but I'll get to them. I'll get through them all. And we'll do some Sony giveaways because I've got them here with me. They came home from Mountain View to Phoenix, and I'm going to get them in the hands of a couple of the attendees. So, anything else?
This is pretty neat. Yeah, I love this board.
Yeah, hold that up. Let me, you know what? Let me do this. Let me have you turn your screen share off, because when your screen share is on, it will fill up the bulk of the view. And then, now let me pin you, and hold that thing back up, because you also, so you took yours and you 3D printed that around it. So let me pin you there. We can see it now. So now that little holder there that you created, is that, did you literally, I mean, obviously you did the print, but did you find that on Thingiverse, or did you actually make the model for that? Like using
so this one I made, I designed on Fusion 360 and printed that. But if you go to Thingsgiver or Printables, I don't know if you know about that website, it's Printables. That's basically by Prusa 3D Print Research, and they have I think there is one 3D printed case for Sony Presence, which is perfect. So you can just go ahead and print that, or you can take mine. This is not so good, but it works for me. But there are good ones available.
That's perfect. All right. Well, I think we got it. We actually had 2 last questions, and Walt, I saw you pop in. We'll be with you in one moment. Walt is from, or was that Angus? No, that was Walt popped in, but is from Canary AI. They're on deck. They're coming up next, but let me get these last 2 in quickly. Armagon had asked, Mithun, your project is running on 1 core, or are you utilizing multiple cores for this?
No, actually, I am running on single core at this moment for this particular project. But yeah, there are options to run on multiple core.
Yeah, you could, of course, run it on multiple cores. I mean, running on single core, if the single core is sufficient and doing everything that you need it to do, I mean, for power saving, that might be the way to go. And then Khalid is asking about lighting conditions. You know, as I think about, like I said, when I grew up, our oil tank was down in the basement and it was dark down there. So I guess you would definitely have to consider having an LED or having the camera close enough plus a strong enough LED. But is that something that you explored at all, Mithun?
Yeah, exactly. So I was thinking about if you know ESP32 cam module, like it has little LED which you can flash, like if you can program like that. So I was thinking sort of things. So we can mount a little LED, and then regardless of your lighting condition, it can flash just before taking the image, and probably you can eliminate some of the low lighting condition. But again, there are chances of overexposing, like if your basement is bright enough. So yeah, there are certain things to consider.
Yeah, most basement AB is asking us, is the basement dark? Most of them are. As I think back to mine, it was pretty scary down there. It was usually pretty dark. Well, and the oil tank is in the corner because the fill tube goes up. The fill tube to the tank. So tank is, you know, essentially basement is below ground. So the fill tube runs up to the outside of the house, right through the, you know, through the concrete wall of the basement. And then the cap is on it. So it's in a corner, it's tucked out away, it's dark down there. So yeah, lighting is certainly something that would have to be considered. But all right, well, thank you, Mithun. I appreciate you. AB doesn't know anything about oil heaters. No, it's a Northeast American phenomenon, but I am telling you, it is everywhere, the entire Northeast, millions of units.
Yeah.
It's a localized thing. Yeah. But all right, Mithun, thank you very much. I'm going to bring in Angus. Angus has actually brought himself in, saved me a click. That is wonderful. And we'll get Walt in as well in a moment. And Mithun, have a great rest of your day.
You too. Bye-bye.
Bye, Mithun. And Angus, you are right on cue. That is
fantastic.
Awesome. Great timing. Link worked out. We had Walt for a second, so now I just need to grab. He's back.
I'm here.
He's here. He's watching. All right. And Angus, you've got screen share already going.
Good to go.
You are so far ahead of the curve, which is good because I'm 2 minutes behind schedule. So I'm excited to go through this. We, throughout the course of the day, have kind of talked about the prototype to production, path or life cycle or process. And for anyone who's gone through it, they know that it can be quite painful. And that's kind of one of the things that you guys specialize in. And, you know, I think you're probably going to focus on some of, you know, real deployments, things that are out in the field. But I'm definitely really, really excited to hear about, first and foremost, you know, your background, Angus, your background, Walt, and give us a little overview of what Canary AI does. And then I think with that said, Angus, you want to go first? Give a little intro.
Thanks so much. Thank you, David. Really good to be here. As David said, Walt and I are from Canary. So we founded Canary not long ago. It's still early days for us, so I will caveat this whole talk with that. Our background is on the sort of technology side. If I can change the slide, there we go. We're a couple of geeks, basically, like probably a vast majority of people here.
Everybody watching is.
Indeed, yeah,
so
exactly.
you're among friends.
In good company.
Yeah.
So my own background is more on the hardware side of things. I used to work at Dyson and GE and a music technology company called Roli. Walt, just a bit about yourself.
Yeah, sure. You know, it's kind of a crazy background. I'm lifetime embedded developer. but I've also worked pretty extensively in the financial field, and I'm also academically a mathematician, or that's how I'm trained anyway. So that's my background, and eventually I ended up opening a consulting business that did firmware and you know, other sort of work for embedded devices and stuff like that. It's actually how Angus and I met.
Yeah, exactly. I mean, this is very good, nice segue into sort of part of the reason we're here, really, which is, you know, Walt and I were discussing this consultancy project we were doing. I was working on the hardware, Walt was on the firmware, and we were chatting about, you know, some of the, you know, the tricky bits of doing this. And actually, as Jim said in the talk one before last from Microsoft, the world of IoT development is still pretty, it's not as far developed as the world of desktop development. You know, there are so many tools that embedded engineers don't have that have been around for years in the desktop world. So we got a bit frustrated with this. We were chatting, and we figured we could actually do something about it. So with our sort of background, myself on the hardware, Walt on the firmware, we figured that there's a really interesting gap here, which is where Canary came from. And fundamentally what we're doing is building a set of tools to allow customers really to use the power of machine learning. I don't need to tell you how powerful it all is, but to actually apply that to real world problems. So we go from like an idea, very early stage concept, all the way through to actually having something out in the field, doing something real in, you know, dirty industrial environments, and as sort of a lower friction as possible, lower friction way as possible, to take a lot of the obstacles away from that path. So yeah, why are we doing this? I've already kind of alluded to it. Oh yeah, thanks, Snap. Nice, I like it. So in fact, it's exactly the same one. So yeah, why are we doing this?
Ready.
So as Jim said, you know, designing these connected products is pretty tricky. You know, it's not straightforward. There are loads of things that can go wrong, loads of sort of complications, and you know, that's frustrating when you know that it can be better. And sort of reinventing the wheel. So I see this quite a lot in my world, where you sort of use the same blocks of circuitry over and over again, and it's an inefficient way of doing it. And you know, Walter's the same with firmware. You find yourself using the same blocks of code over and writing them in, you know, maybe a slightly different way, but there's a lot of waste that you know is pointless, you know, waste of our time. And there are lots of things that can go wrong. As I said, I mean, we'll talk about this more later. We've got some first-hand experience here, but there are so many things. There are so many technical challenges between this nice little Arduino on your bench and something that's, let's say, up a wind turbine. So yeah, we're trying to address those challenges sort of one by one. And lastly, I've got most importantly, really, like ML is, I mean, I don't need to tell all of you, it's a really fantastic technology. There are so many applications which aren't even, you know, thought of yet, which is coming, you know, daily are coming about because the likes of Edge Impulse are enabling these amazing use cases. And it should be more things. You know, we've got so much stuff in our house, like the boiler and I don't know, a lot of the oven. All of these things are, you know, relatively dumb devices. And instead of just throwing IoT at it for the sake of it, we're looking at it the other way around. You know, having it to be able to predict a failure before it happens is an incredibly powerful thing. So this technology should be in far more things than it is, and it's that challenge that we're hoping to sort of meet. So yeah, our embedded tools, I'll sort of hand over to Walt on this one.
Yeah, sure. I misplaced my windmill, or we could all play like windmill
time. Yeah, Walt, come on.
Yeah, I'm sorry. I think it's in the basement. Next time. I'll bring it next time. We'll have fun. Yeah, so, you know, anybody who's worked trying to build some of these things or really has done any embedded development at all is very well aware of the many pain points in building firmware and really anything for the embedded world. You know, it's only recently that we're starting to get sets of build tools that enable us to deploy software more quickly, certainly in a more robust fashion where we're a lot less worried about, you know, did I get all the registers just right and all that sort of stuff, you know. And even code management, DevOps, things like that it's all still a relatively new world. It's somewhat anecdotal, but in my consulting world, just hooking up clients to DevOps has actually been like, it could almost be its own career. It's such a rarity still in the embedded world. But yeah, so, you know, we set out to hopefully come up with ways to mitigate all those real pain points a little bit and enable people to go from a design idea where they want to add machine learning, IoT, you know, cloud connectivity to their devices and go in a very low code or even no code way from their concept to an actual deployment.
Yeah, and similar for the hardware, really. You know, there's no reason why that can't be done for hardware too. And it, you know, hardware typically does lag behind. You know, it's a fairly traditional area, and you know, the standard way of doing things has been fine up to now, but it is not the most efficient way of doing things. You know, I find myself, as Walt did, doing the same bit of circuitry over and over for circuit X or circuit Y, and it's, you know, it's not the best use of my time. I could be doing, you know, something else with that. So, you know, we need to drag that into the 21st century. And similarly, as what we're saying with the low code, no code side of things, you know, there are very few hardware alternatives. There are a few, but it's still a relatively new area. So there's definitely scope for, you know, really improving the state of the art so you can have something that's customized for your specific application from both the hardware and the firmware without having to start from scratch and employ a consultant like Walt or me to go start from scratch, because you don't need to, because, you know, we will have done all this already, and, you know, we already have these building blocks there. So that's sort of the approach we're taking here. So yeah, I mean, the reason we're kind of chatting is a kind of real life use case, and our first customer happens to be a company called Winfinity. So it's a really interesting company. So they, it's a German company, and they buy wind turbines and operate them en masse. So in Germany, it's a little bit different from sort of most of the rest of the world. A lot of a lot of landowners in Germany sort of buy kind of 1 or 2 wind turbines to have in their field on their farm, but don't make a lot of money from it because it's not very efficient to sort of operate them sort of singly. So Winfinity are sort of buying them up and operating them en masse to make it far more economically viable. But because they've got all these different wind turbines with subtly different systems, they wanted to have one single system to add sensors to their turbines and actually monitor various elements, the most sort of physical elements, in one sort of under one roof on one platform. So that's where we came in, really, to do that. So a really stupid remark, but I mean, it's really true. So they're really tall. So this is a photo of the one in Germany that currently has our equipment. It's 150 feet or 50 meters. Now 50 is not a very big number. It's like, you know, 50 meters. But it's when you're climbing up, and I did climb up it, it's really freaking tall. You can't just about see the little platform at the top. That's where I was sort of sat taking a couple of selfies after climbing the ladder in the middle. And that's the little sort of platform you stand on to then open the hatch to get into the top bit, to then actually install the sensors.
Gonna ask, so there's a ladder, so the ladder is inside the middle of it?
The ladder looks like that. So that was from about 1/3 of the way up, I think. And I think the reason it's blurry is I was probably still shaking, but yeah.
I wouldn't do it. Nope.
No
chance.
My wife's comment was, my wife's comment was, why did they make the ladder out of ice skate blades? And I was like, yeah, that is, well, why did they do that? I don't know.
That's fair.
Kind of felt like that climbing it. So anyway, there's the ladder, and yeah, quite high up was the long and the short of it. So not very useful remark, but there you go. So oh yeah, so let's see if this works. I don't know how well this will work. So this is just a quick video from inside it. A bit laggy on this computer, sorry, my laptop's struggling. So this is basically just a short video from inside the actual, it's called the gondola. So you can see our sensors here. There's one in the foreground, just about see one in the background there. We're looking, say, from inside the gondola at the back of the rotors, so you can see the inside of the blades turning, and it's quite spooky being up there. So yeah, so you can see here that these are the accelerometers we fitted. There are 6 in total dotted around, and these are, say, measuring acceleration. This is it's called a direct drive. So the actual rotor is attached directly to the generator. There's no gearbox. So this is where our sensors are. No, that's not going to play again. Let's try and, you're going to have to watch again, sorry. I don't know if you can hear the noise, but it's kind of a slightly weird, spooky noise in the background. And yeah, so these are some of the sensors we fitted. The goal of this is to monitor the vibration, basically. And again, I'm sure most people here are well aware of what you can do with predictor maintenance. It's an incredibly powerful tool. And so what we did here was we installed a bunch of these accelerometers to monitor the acceleration in 3 axes in various places around the turbine. So on the left here, this is called the azimuth drive. So this actually spins the whole top of the turbine so it catches the wind. And on the right here, this is the actual main sort of shaft itself. So that's what we did. It's up there now. And what we're doing is to say, it's something called predictive maintenance. It's an incredibly powerful tool, very, very, very important for something like this. A wind turbine is millions of dollars, right? And the maintenance can take a pretty big proportion of the actual, the outlay. So you're only up to about 30% of the money you make from this can actually be spent back on maintaining it and fixing things when they go wrong. So it's a big problem, these things failing, especially unplanned failures are the worst because you've got to scramble someone to go and climb up it. And as I've said, it's not very fun. And you can predict a lot of this. So I mean, the corner here is from Edge Impulse's own site. One of the key elements of Edge Impulse, one of the core things being looked at right now is machine health. So, and this is what we're doing here. So the graph at the bottom here is just it's a sample graph, it's literally sketched by me, but it sort of gives you an idea of what you can do with this technology. You can look at the various bands of vibration, the various frequency bands, and detect issues before they turn into real showstoppers, before your wind turbine stops working completely. And typically, the further up the frequency you go, the earlier you can detect faults. So it's a really interesting sort of theories behind it. But if you can detect up into the sort of ultrasonic frequencies, you can predict failures in sort of days or even weeks in advance. So it's an incredibly powerful tool, and you can apply it to basically anything that moves, which is the really exciting bit. I mean, I'm talking about wind turbines because that's where our first installation is, but every person here has experienced an elevator going wrong or their car going wrong, or anything that moves is at some point likely to go wrong. So you can imagine applying this technology to anything that moves and things stop going wrong, which is a pretty powerful proposition. So anyway, so this is applied to a wind turbine. The reason we're talking about, the reason we're here really is to talk about some of the challenges in getting these things deployed. And one of the caveats I did give at the start was this is our first one. So this sort of brings me neatly onto talking about some of the challenges. So this here is the little sort of dashboard that our IoT provider, our SIM card provider gives. And you can see here the little red thing that says offline. That is the state of our kit right now at the turbine. So, I'm not going to pretend that everything's perfect. We know exactly what we're doing and it's all working beautifully. There's no point in lying. We're being very open and transparent. So we found this issue. We think we know the problem and we've already solved it. But this is a perfect example of where things don't work out as you'd hoped.
What was it that Jim said on the previous session? IoT is hard. That's what he said.
I mean, we are living proof that IoT is hard, and we are making these mistakes so you guys don't have to. You're welcome. So yeah, this is sort of leads us on to some of the challenges. I'll hand over to Walt now because he's sort of more on the firmware side of things.
Yeah, sure. And of course, the challenges are many and great. So some of the things that we ran into when we deployed for Winfinity, and actually what Angus just showed us here, probably the biggest issue is that this is in the middle of a cornfield in very rural Germany with very limited LTE connection. So writing firmware, writing a really robust routine that will enable you to mitigate those connection issues as much as is humanly possible becomes extraordinarily critical. And not only that, but for us, we found that we ran several times into having to think through the entire connection process, pretty much soup to nuts, and to make sure that the order in which things happen is very well thought out. It sounds like an obvious statement that you need to really worry about how the connection protocol is going to occur. But as it turns out, it's even like more important than I'm making it sound. You really need to be extraordinarily thorough and logical in almost an algebraic way to ensure that when this thing disconnects, which it absolutely will, that you're going to be able to get it to reconnect at some point in the future, if ever your connection is available again. Because one of the, I guess the first thing we ran into is obviously when it went offline, it could have been anything, right? I mean, it could have been anything from the LTE and connection goes down, all the way through to a maintenance person showed up and chucked our entire unit into a trash can or something like that. Completely possible.
Could be a bird.
Yeah, it could be any, birds, could be anything. Yeah, or a squirrel runs up there, you never know. Yeah. Another challenge that again seems obvious, but it's not an easy problem to fix, is ensuring very robust over-the-air firmware updates. It's one thing to, try to implement whatever, you know, software, whatever firmware that you're sticking up into a wind turbine. But clearly, you need to be able to update that on the device pretty much at any time without having to have anybody go up there and hit a button or unplug the thing or any of that. You know, I mean, that's half the cost right there. So yeah, so we spent a considerable amount of time actually having to run through different firmware update scenarios, including, you know, what happens with connectivity issues, what happens if, you know, your connection goes down, do you just have to reset, do you continue on? We ended up sort of attacking this with a multi-protocol solution where there's some negotiation over one set of protocols, and then in the end, the actual firmware OTA updates sort of happen in a completely different way, and you know, and so far that has actually not been a pain point for us, but it's the kind of thing that if it's not very well thought out could really hurt you. Some other things that we noticed, you know, so when pulling data off a device like this, really, while getting the data off your device is very important, knowing where that device comes from in terms of, you know, what data set is this data from, you know, how does it need to be organized, how can we look through this data afterwards. This is something that for us is actually just starting to rear its head for our client, but it's the kind of thing that I think involving a good deal of forethought can save an awful lot of pain in the future by ensuring that you can access the data in a way that you want to, you know, that's going to be productive. And then of course there's the whole problem of reconfiguration. You know, you have this device up there. Not only do you have to sort of be able to reconfigure things, but how does that happen? You know, if you plan through thoroughly, we're starting to see that you can do a considerable amount of reconfiguration on the device remotely, which is a really good thing, without actually having to do a firmware update. So we can do it via software with a web application, and then, you know, use the variety of protocols that we have available to actually transmit that information and reconfigure the device in real time. And then of course there are bigger, uglier configuration updates that require a full, you know, firmware OTA sort of thing. So yeah, that planning that out well has sort of saved us a little bit of trouble, and where we didn't plan out so well is and will continue to give us all sorts of trouble. Yeah.
Yeah. Well, let me jump in real quick with a quick time check.
Oh, sure.
We got 8 minutes left. I don't know exactly how much more you have on the slide deck, but we've had quite a few questions roll in
cool.
that I want to have you guys take a look at. Yeah.
Yeah, I can pretty much just wrap it up by saying, you know, on the software side, our big challenges were just getting through all the different layers. Obviously, I'm a firmware developer. Angus is a hardware guy. So putting together a bunch of like, you know, Kubernetes style things and microservices or something isn't our strong suit, but you know, it's a real pain problem if you don't have somebody on your team.
Oh yeah, no, you definitely need subject matter expertise in just that portion alone. So I don't know if you guys can see it. There is down at the bottom. If you click on Q&A,
yep,
you should get a little pop-up, which is going to take over your screen, but you'll see the questions in here. If you can see them, great. If not, I will read them to you. Got them. All right. So I'll just jot them out anyway, though. The first one's from Nico, and he's saying, our failure vibration look the same between different types of vendors of wind turbines? Do you need do you have to come up with a different model for each turbine then, I assume?
I mean, this is largely yes. This is a question primarily that we don't necessarily answer ourselves. We are providing the tools. I mean, the fact our first installation as a wind turbine is sort of was by chance, to be honest.
Right.
So we are not wind turbine vibration experts, sadly. You know, we'd like to be, but you know, there are people far cleverer than us that know this inside out. So as we understand it, it's going to be a question primarily of a unique model per turbine, and that's one of the things we're trying to build at Canary is this really seamless way to go, right, well, I need to retrain my model on this new device. Go. It will grab the data, send it to Edge Impulse, bring the model back, deploy it. So, you know, you can do that when you need to. It's a really seamless thing. But yes, I mean, there are techniques, I think, to be able to apply the model, the transfer learning to apply, but it's not yeah, right now to give you a really good answer, I would be making it up. So I'm not going to pretend to know the answer.
Makes total sense. I mean, really what you're describing overall, I mean, you talked about this implementation and that's wonderful, but realistically, more abstract, more higher level is build a device that you can put on anything, let it sit there, capture the data from it. That will now be your reference point, your data for training the model. Then once you've got that, you can sort of wait for anomaly, predictive maintenance, so on and so forth. But every device is going to be in a little bit different situation. Got it. We've got some connectivity questions in here.
Yeah.
What is the cellular protocol or NB-IoT?
It's an LTE-M modem. So it's a Nordic device. Actually, it's the NRF 9160. It's a very amazing bit of kit. So completely integrated module with the modem, all the RF stuff, and Cortex M4. I want to say
33. Right?
33.
Can't remember.
So so it's LTE-M. It's nice because it just works. I say when it works, it will just works. Put a SIM card in, and the reason for that, I mean, I think there was a question about that over other connectivity solutions. LoRaWAN is an obvious one. And we wanted to be able to, we knew the signal was available there, and that's something we can check easily beforehand. LoRaWAN obviously does rely on either putting your own infrastructure in, your own LoRaWAN sort of bridge, and we weren't sure at the time because we had never visited the site before. We weren't sure what was available there. So we wanted to go with something that we knew would work. And in Germany, LTE-M is basically got 100% coverage. So that was the main reason. Although there's a question from Nico about having this sideband or a different wireless protocol. Absolutely. I mean, the reason we didn't choose a lot of other things to do, we limited time, and primarily, and this is our first installation, the first time we've done this. So we've learned a lot, and next time we'll do it slightly differently. And so some of these questions are really useful. You may well have those things.
Yeah, and I mean, in this case, of course, we actually had the LTE-M. We knew it would be available, whereas, building out a LoRaWAN network or something would have required a different set of challenges, really, for us.
Briefly, I think the model one size fits all. I think that was answered previously. Generally not, but with caveats. Challenges on the hardware is literally on my next slide, so I'll hold off on that one.
Perfect.
And security issues. I mean, LTE-M obviously is pretty secure in itself. Walt, you can probably comment briefly on the security, given that we've got 3 minutes. Keep it short.
Sure. The security stuff was interesting. We had to sort of be able to deploy SSL pretty much across the entire thing from end to end, which comes with its own challenges. So actually, the security was a challenge both in the hardware and the software side of things. Yeah.
Cool. And there's a question about hardware. I'm just going to talk about this very, very briefly, just because this is my bag. I've got, like 1 minute. There are loads of hidden challenges with hardware, and it's, hidden depending on, if you've never done hardware before, it is hidden. Things like certification are a real pain in the backside if you've never done it before and you don't realize that you need to. Things like EMC, which is electromagnetic compatibility, and radio testing. All these tests you need to go through to be able to certify and legally use this device. There are lots of hoops you need to jump through, and ones that for the uninitiated are quite, that can be quite tricky. There's also lots of environmental things. So ESD is electrostatic discharge. When you get zapped from your car after a long journey on a hot day, you can build up a big charge, and you need to design your hardware to withstand that. It can be in quite nasty environments. The human body can generate tens of thousands of volts, so it can easily destroy hardware you've carefully designed if you're not careful. So there are loads of things in the environment that you need to think about. Things like vibration, humidity. You may well be in a very horrible environment. So these things you need to think about conformal coating, for example, to make sure that humidity doesn't affect circuitry, and things like reducing the risky parts there. Things like vibration could play havoc with connectors. So you've got a wire and a connector, and you hit the natural frequency of that, and then 5 minutes later your connector's fallen off the board. So there are loads of things that you need to think about, and you need to just overlook one, and you end up with hardware that doesn't work or firmware that crashes. So it's the point here is that it's quite tricky. And as Jim Bennett from Microsoft said, there are lots of things that can go wrong. There are lots of areas of complexity here. So we're trying to address that. As I said, we're not perfect. We haven't got it yet, but we are close to being there. And for us, this is quite early on the kind of journey for us at Canary. So we're already chatting to other customers. Funny enough, our next customer has a bunch of wind turbines that they want to monitor. So you know there are other.
Hey, imagine that.
Yeah. So I think, yeah, there we go. That was all I had to say. I think we just about scraped in under the
yeah,
the time.
made it with 1 minute to spare. But this is perfect, actually, that your final slide's got your contact information here. Will you do me a favor and drop your email addresses and website into chat as well?
Okay.
So that folks can follow up with you, because you're doing some really interesting work. And, you know, we've talked throughout the day. We've shown a lot of prototypes and projects that folks can build. I mean, Mathun showed off, you know, the oil tank project not too long ago. But you're out in the field doing real work and gaining real experience, and you're in a position where you're building products. So I have a feeling that as folks are watching this, you know, there's 60 some odd attendees still alive, and then who knows how many thousands will watch once it's on YouTube. I mean, our channel gets pretty good viewership. Point being is that there may be folks out there that could certainly take you up on you know, your services and opportunities. So yeah, get that in there.
Brilliant. Thanks very much, David. Really good to be
You're
here.
welcome, you guys. And let's see if we have Paul. I'm gonna go take a quick glance at the attendee list.
Yep. Oh shoot, let me see. I can switch my camera.
You are here, Paul. Yeah, you snuck in on me. I was about to promote you up to a panelist. I saw you
That's-
hop in as an attendee. I've got, so I can hear you,
Yeah,
but
let
I
me see if I
don't
can-
have your camera feed.
Yeah, it's doing that stupid thing with the Brio. Let's see what we can do here.
Take your time. We're only a minute behind schedule, which means we gained 2 minutes on the last one because we kicked the last one off 3 minutes late. So we're good. I have a Brio and I have that problem. I've seen it before.
Let me duck out and try to come back. I'll be right back.
Yeah, no problem. No problem. Give him a minute to reconnect. AB knows this problem apparently as well. All right, I see another
Okay.
Paul.
Yeah, it shows my normal camera when I'm joining, and then it doesn't. Worst case, I'll just kind of roll with it.
Well, down at the bottom left, I mean, what are we in? We're in Zoom. So at the bottom left, the little up arrow next to
There we go.
stop video. Hey, we got you. There you go.
All right, cool.
That's exactly what I had to do. So, all right, Paul. Well, welcome. And you seem to be joining from a galaxy far, far away. Also, Jim joined earlier from a galaxy far, far away. I don't know if your galaxy is near his or not.
Oh, nice.
But I'll give just a quick, brief, momentary introduction, and then I'm going to turn it over to you to take it away. But I'm really appreciative, really thankful to have you here with us today. Paul is from Google. I'm going to let him do his own intro, but he's going to be talking to us about Coral and show some really cool updates that I got a sneak preview of. So I happen to know what's coming, but you guys are going to want to pay attention. All right, Paul, go ahead and take it away.
All right. Let's see, there we go. Perfect. So I do have a bit.ly link up here just because there is some code. It's always impossible to keep following along. So if anyone wants to follow that, you can see the code and everything else, or the slides, and I'm guessing the video as well will be available afterwards.
I'm going to make all of it available. Yep.
Cool. All right. So hey all, I'm Paul Reese, and I'm a developer advocate for the Core ML team here at Google, based out of Boulder, Colorado. So that said, my main focus is actually on mobile and specifically Android ML implementation. But I do play with IoT hardware somewhat regularly as a hobbyist. So this talk is going to fall more under the umbrella of, I think these things are cool, and I want to tell people about them rather than being a huge expert, but it's probably okay. If you end up leaving this talk later and you want to know a lot more, I would definitely recommend like our TensorFlow YouTube channel. And then we have docs for pretty much everything we're covering today. So since this talk is focused on how you can do machine learning on IoT devices using the TensorFlow platform, I should probably start by briefly mentioning what TensorFlow and TensorFlow Lite even are. So first and foremost, TensorFlow is an open source library for machine learning. It's all out there on GitHub. You can send up pull requests, judge all of our terrible coding decisions, or whatever else people like to do with open source. So actually, just in the short time that I've been with the TensorFlow
Issues.
team, I've honestly seen some really
GitHub
cool
issues. Yeah, we all know 'em. It's okay.
Oh, did we run into issues?
No. I was saying GitHub issues when users,
Oh.
when you say open, when you make a joke about, look
Yes,
at our
yes.
terrible code, and then somebody comes along and opens up an issue, and it's, oh man, yeah, okay. So,
Cool. So yeah, I mean, there's been a lot of cool things that I've seen out of the community too, though, just because it is open source. So what was it, a week ago or so? Somebody was able to get stable diffusion image generation working with TensorFlow, which has just been kind of exciting. So we're working on converting that over to TensorFlow Lite now to run on mobile, just to see if we can even do it. So yeah. And then what's a little bit more interesting today is a subcategory of TensorFlow called TensorFlow Lite, which is what I was just talking about for running on mobile. It is an optimized version of TensorFlow, specifically designed for running on edge devices. So that includes mobile, microcontrollers, and pretty much anything else in between that people are going to put together. And then for our purposes today, that's probably all we really need to say about TensorFlow and TensorFlow Lite. I figure with this event being centered around ML and IoT, most of you probably know more than I do about training models, optimizing them, data cleanup, and kind of all of that fun stuff. So I'm more in the camp of, hey, I'm an engineer. Please give me a model so I can do something with it. So the focus for this talk is going to be more on kind of the hardware options that are out there, and then a few examples of actually implementing something. Since that's pretty much the more interesting part, at least for me, I'm hoping for other people as well. Cool, so let's actually talk about what hardware you can use to get started with TensorFlow Lite on the edge. I figure once you know what hardware is out there, it's a lot easier to pick the ones that are going to fit basically your use cases and then actually get into the development stage of it. So there's two ways to approach this. There's production hardware such as SOMs, which you're just going to design straight into your own custom boards. If people don't know what SOMs are, that's a system on module. It's basically just a little plug and play piece for it. And then there's hardware that's solidly intended for prototyping before you even get to that real board design phase.
Paul, real quickly,
So-
I can't remember if this slide had a picture of those. Can you check to see if your slide is advancing or if it's stuck? Or you might be on the same slide, but let me just have you double check.
So there's the one with the list of boards right here on the image, and then there's one where it switches over to this ++.
Okay. I am viewing, maybe it is stuck or frozen. I don't know which one you think you are on, but I am seeing TensorFlow and TensorFlow Lite.
Oh, okay. Let me go ahead and reshare and hope for the best.
Yeah, let's see what happens. Aha,
Ah,
perfect.
Okay, cool.
Now we're good.
All right. So today I actually wanted to focus on the prototyping hardware, since that's kind of where you would normally start, either as a hobbyist or professional. Plus, I think it's just kind of a lot more fun to be able to throw together a project and then move on to the next one. So I'm kind of hoping others feel the same way.
Our audience does.
I'm sorry?
Our audience most certainly does.
Awesome. So while the three devices here kind of fall under that Coral brand, I actually added this little ++ here because there's more options than just the Coral products for running TensorFlow Lite. So I figured I would kind of run the gambit here. Did that switch to the Raspberry Pi side?
It did not switch. It's
Ooh.
on the same ++, so it's not advancing your slides for some reason.
Oh, that's not cool. All right.
Oh.
See, what can I do? Let me see if I can just share the window, maybe? Maybe that's the issue.
Can certainly give it a try.
All right, how is that?
Well, it's not actually coming through. It says that you have started screen sharing, but there's nothing there.
Oh boy. All right. Let's see. Let's stop again. We'll share. Can I do a Chrome tab?
Let me make sure that your permissions. Now I see the Raspberry Pi.
Okay, and then
now it's going. Now I see TensorFlow Lite for microcontrollers.
Okay.
We're good.
All right, let's hope for the best.
Okay.
All right, so first off, we do have the Raspberry Pi. This thing is, I'm sure as most of you know, a prototyping workhorse and kind of a staple, and I love it. So I've got the 3B up here on the screen, but TensorFlow Lite does work on most things that are going to run Linux and Python, such as the Pi Zero that's included with the newer AIY kits. AIY, for people that don't know, were these little things that we kind of included or like released out there. This one's running on the Pi Zero. It's a Vision one, so you can plug in like a ribbon camera and do general like classifications and other fun stuff with it. And then the older one we had was on the 3B, and this is like the voice hat. So they used to be like a little cardboard thing. You hit a button and it would do stuff. Cool. So yeah, if you really want to get up and running with a prototype where power isn't a concern, you kind of want to have that solid internet connectivity, expansion pins, USB, or any of that other fun stuff, Pi is a great way to go. I mean, as I said already, it's kind of a like that workhorse staple that I just really like. And then something awesome to mention here too is that I've been able to get TensorFlow Lite to run with both the ribbon camera that's there, or the USB camera, or USB microphone right out of the box. So it doesn't actually take a ton of configuring to make something, which is great, especially if you're just trying to run through an idea. If you do want to cut your prototyping down to essentially as small of a footprint as you can get, then there's also a version of TensorFlow Lite designed specifically for running on microcontrollers. So this board has the longest name in the world, but here you have the Adreno Nano 33 BLE Sense. And what it's doing is it's recognizing the keywords yes and no, and then it's lighting up that LED for red for no, green for yes, when it actually recognizes those keywords. We do have a list of supported devices up on the TensorFlow Lite for microcontrollers, or TFLM website. I'll tell you right now, it's kind of bluffing. It lists maybe 10 boards, but I've seen this running on way more than that. I think we actually list more of them on our GitHub page, and I would trust that a little bit more. So for example, I've gotten this working on an ESP32, which we don't list, but it was actually pretty easy to get. And I feel like most of us have at least one of those somewhere around. I also know that Adreno sells these little kits with a microphone and camera. Actually, I think the board already has a microphone on it. But they're pretty nice for just kind of getting your models out there with pretty easy to use Adreno code. Which, do I have one of those here? I do. I've got a pile of hardware. So just normal, what is it, OV7675, it's attached to this little expansion board, and it's that BLE Sense board. Let's see. So this is actually something that I thought was kind of cool too. So if you are going to look into TensorFlow Lite for microcontrollers, it's kind of cool to know that your trained models are actually converted into these huge arrays that represent your model, and then you can pretty much use them for whatever task you're doing. So here you can see this is an array that represents the word no. Then when it does pick up that audio, it tries to match it against that. So this is essentially like how you would do, not essentially it is how you would do keyword recognition. If you really want to do a deep dive into how this works too, I have a student from the recent Google Summer of Code. His name is Vishwa. He wrote a whole lot of kind of in-depth tutorials over on Hackster. I think you can find him if you just look for the ESP32 Hackster.io TensorFlow Lite for microcontrollers. His account there was the Evil Doof with 2 O's. There's also a tiny ML book, which is kind of cool. It focuses on, I'm sorry?
I was going to say, Paul, I'll go find it while you're speaking, and I'll put the link into chat for folks.
Oh, awesome.
Yep.
So there's a tiny ML book. It was actually, one of the writers is the head of ML with Edge. So that's kind of cool. It's worth checking out just because he really knows what he's talking about. And I want to say he was on my team before I started. So next up, we have the Coral USB Accelerator. So basically, it's a tensor processing unit, or essentially a different kind of chip designed specifically for working with ML. And you can plug it into USB and offload a lot of your training or inference to this little device. got him here too. He's actually, I think he's about the size. Yeah, same size as a Pi Zero, so that's kind of nice. Anyway, so you can offload your training and inference to it, rather than making your poor machine kind of suffer if you're not using cloud for training and all that kind of good stuff. I do know this works with the Raspberry Pi, and a couple weeks ago I actually saw a really cool demo where somebody was able to hook it up to a web app and then do device ML from a browser. I know we put up a tutorial for how to do that as well on the Google Dev Code Labs pages. So if that is something that kind of sounds interesting to you, definitely go check it out. And then the final set of prototyping boards that I was going to go over are the Coral Dev boards. So there's two versions of them right now. You've got the one on the right with the giant fan and all kinds of other stuff on the expansion board. And then you have the mini on the left. Cuts down on like the extra USB out and in, the Ethernet port, a couple other things. Doesn't need the fan, which is nice. It doesn't run as hot. I like to think of these like a Raspberry Pi, since they both run a flavor of Linux, but then this has a TPU accelerator that's already built in rather than needing that USB one. So cool. So that's what already exists, but honestly, it's a lot less fun learning about hardware that's already floating out there rather than what's coming up. So let's go ahead and look at that real fast. The next thing the Coral team is releasing is this little DevBoard Micro that'll be joining the last two Coral boards that we just saw. So I was really hoping to be able to say that it was going to be launching today, but for now it is still coming soon, unfortunately. But I do have one right here. It does exist. I can promise it actually is in the pipeline. So it's just not there right now, but soon actually seems pretty soon. So that said, there are a few things that make this board really cool. So first, the board support development using FreeRTOS. I've only ever read that, so I don't know if it's FreeRTOS or FreeRTOS. I'm going to just say RTOS for now. But that's kind of one of the OSs that we support with it. This is going to give you some useful things like blocking events. And I don't really think they can make a small microcontroller without also having some Arduino support. So what's cool about this board is it still supports TensorFlow Lite for microcontrollers. So you can do some basic ML in a low power way. And then when your low powered model sees or hears something that needs a bit more attention, you can switch to using the embedded Coral Accelerator TPU. So this combination will basically allow you to run a mostly low power device that can just float out there in the wild. And then you can switch to doing more complex machine learning tasks once it's needed. And then finally, there's the actual hardware that's there. So it has a built-in camera and microphone. Plus, there's currently a couple expansion boards that'll give you Wi-Fi, Bluetooth, or power over Ethernet, depending on what you've hooked up into it. Cool. So now that we have a rough idea of what the board is, let's actually look at actually making something rather than here's just a vocabulary. There are a few things involving flashing your FreeRTOS program to the board from a terminal and kind of all that stuff that would be in the documentation. So I'm not really going to spend time on that during this lightning talk, also because it's not super exciting. So it's in the docs. So for this example, I'm going to go over how a general face detection program would work. So in this image, I actually have my phone recording pretty much next to my chest, just so it's not obstructing my face. And then I raise the device towards my face, and that little green LED in the middle will light up to say, hey, I see something. Distance is actually pretty good on it too. So in this case, I have it pretty much outstretched from my arm, but I pointed at other people probably 6 feet away or so, and that worked. And I never really tested max distance, but for what it is, pretty good. So there is some boilerplate to this app. I'm not really going to dive into it because it's not super important in the grand idea of things, but there are a few things that I should probably point out. So here you can see we're actually providing a path to a TensorFlow Lite model that gets stored on the device, as well as values that say, hey, give me at most 5 results where you're at least 50% confident that you see a face. What's really cool about this too is you see this is the Quants MobileNet TF-Lite file. TF-Lite is the file type that you would use on mobile. So we're able to take that, which is just one step removed from like a normal TensorFlow file, and then put it on this little device. So it's kind of cool that you can just use similar things across your projects. From there, we can create the TPU context, which is how we're going to access the onboard accelerator, a resolver for handling the ML steps related to inference, and the interpreter that will perform that inference. There's a few other values here, such as the tensor arena and arena size, but that's more memory related and not something I would worry about too much for this. The resolver also does a couple things like dequantizing the model, adding some custom operations, that sort of thing. Also a little bit out of scope for what we're talking about right now. So the next step is going to be starting the camera, because you are going to need that for face detection, and then setting a few values based on our already trained model, plus the input tensor pointer that we're going to use to store the data that we're analyzing. So once we take that picture, it's going to go into the input tensor, and that's when we analyze it. Let's see, so those values are used for formatting the image frame that our camera receives. Oh, did I do this correctly?
Yeah, I could see it. It's still advancing properly. The I mean, the slides are, you know, it's got the starting camera, camera frame format. Yep.
Oh, perfect. Okay, it froze on my screen, so I was a little confused.
It was going.
Cool. So basically, these are the frames that our camera is going to receive. So we have the specifications for that data that we're going to throw into that input tensor pointer, like from the last slide. So here we're basically just giving it a rotation. So basically, the device is going to just sit pretty much straight up like you saw in the original image. We have the model width and the model height, which I think is 320 by 320. So we do have to make sure we're taking in and having our model set the same way. And a couple other things here where we're just getting the frame from the camera. Then finally, we just need to invoke the interpreter and then block other operations until we have our results. So if there are results, then that's when we're going to do something like turning on that green LED or printing a message to say that the face was seen. And then again, here's that demo image that we saw earlier. But now we actually have some context about that LED turning on and what's happening as we move it. So let's actually take a look at a different example now, since we can do the same sort of accelerated ML through an Adreno sketch rather than only using that free RTOS. This time we'll go over how you can implement pose detection through the Coral DevBoard macro. So for my setup, I just leaned the board against my laptop and then I put my phone right in front of it so I can film what was going on as the board was doing its thing. So it's nothing too fancy. And then the end result of that we're going to be working towards with the sketch is that you can pinpoint landmarks on a person. So using the coordinates that were printed out by the example sketch that I'm running, I made a quick illustration that just maps those points up to what I was doing during the inference. Honestly, it was just walking. So nothing too fancy, but you can see that it will detect nose or eyes, ears, shoulders, elbows, wrist, hips, knees, and ankles. And because the phone that I was recording with was actually lower than the actual device that was doing the inference, it got a little wonky, but not too bad. So you can still see the general shape of things. One cool thing to point out here too is that we actually have a PoseNet data class, which is going to mark which landmarks it's looking for. This is available in the sample that will be published once the board is out there and everything is ready to go. And then from there, we create the same item placeholders that we did with the free RTOS example. This includes the resolver, the model, TPU context, interpreter, and the model path. And again, you can see that we are using a TF light file for PoseNet rather than that big array one that we saw with the TensorFlow Lite from microcontrollers. And then from here, we'll initialize the app by retrieving the model file, getting some of the general information about it, then creating the model that we'll be using for pose detection. We'll also want to make sure that we open the TPU for the accelerated inference. And then next, we'll set up the resolver and the interpreter, then initialize the input tensor and the other necessary values. So this will include our image height and width, just like we saw with the other example, as well as the number of channels. So this is going to be basically taking our image and saying, hey, I'm going to look at the red, green, and blue channels in order to do our inference and figure out essentially where the things are that we're looking for. And then the final initialization step is simply to start the camera and then make sure everything was able to initialize correctly. And then once that's all done, you can just go into your main loop, grab a camera frame every second, load it into the input tensor, invoke the interpreter, and then do something with the output poses that the model is at least 50% confident in. There should be some error handling here too. That is going to be in the sample app. It would have taken up a lot of the slide, and yeah, errors, it's fine. So coming back to our example, you can see that the output text looks like, or what it looks like rather, based on the work that we just did. So you can see how everything was kind of converted back into where all your points are and all of that based off of this general image. So at this point, you might be wondering where you can get your hands on one of these Coral Dev board micros as soon as they are available. So another board is listed on the Coral website, so we should have links on that later. And I believe Mauser
is one of the vendors. You know, the Coral products are generally very well supported. Obviously, it's Google, right? You know, so I would suspect Avnet, DigiKey, Mauser, Element 14, all the normal vendors, and they all have global distribution. So, you know, when the time comes that the board is ready for shipping and distribution, I have a feeling it'll be easy to get a hold of.
Yeah, I'm pretty sure we're actually putting a lot of effort into this one, just because it does have that TF Lite micro to and the TPU accelerator built into it. It's kind of one of those really useful things, and because the price is going to be relatively low in the grand scheme of things, it's one that we're hoping a lot of people are going to start using for prototyping and all other kinds of cool stuff.
Yeah, very cool. Well, I want to do a quick time check. We're at 1:56, so we've got 4 minutes left. We do have a question now. You're not all set because we've got a question that rolled in. AB is asking, he had originally asked what pose model it was. You did mention PoseNet during the during that slide, but he's asking, are there samples somewhere? So is any of this on GitHub, or, you know, you showed off a lot of code. Is that available anywhere?
Not yet. As soon as we hit the point where we can officially launch it, there are quite a few Adreno and FreeRTOS examples that will be out there.
Perfect. So with that said, then definitely what you'll want to do, AB, is make sure you're following, you know, Paul on social media. Obviously, keep an eye on, he had shown earlier that the TensorFlow Lite, well, I guess that's more TensorFlow Lite. I was about to say, you know, keep an eye on the repo, but I guess that's probably more of the core. You know, I'm sure that
their own repo, and I think that'll be a good one to follow. Let me double check that real quick.
So, you know, just keep your eyes open, but I would guess, you know, when launch occurs, yeah, those samples will go live too. He says he's on the lookout. All right, perfect. Awesome. Anything else? You covered a lot of ground in 20 some odd minutes. So thank you for taking the time out of your afternoon.
Oh yeah, no, it's pretty exciting. So this is the first time I got to do a talk like this on our IoT stuff.
Yeah, that's awesome. Well, I'm glad.
Yeah, meant I get to take work time to actually learn it, which was fun.
Yeah, absolutely. My last question for you is, what's on your t-shirt?
Oh, it's the Hackster shirt.
It's the Hackster shirt, you say?
Yep.
Well, that's convenient, isn't it? Let's bring in Ginger and Jessica, who I see have joined, because they're up next. And yes, that was a trick question. I knew that was the Hackster logo. But Ginger, I know that you are already in. If you are ready, if you turn your camera on, you should pop in. Oh, we just got an Alex as well.
Yeah. And our previous, can you hear me?
Yeah, I can hear you just fine.
Hey, hey.
And Alex is there. We lost Jessica.
She seems to, like, it looks like she's here, but her video's not there.
Oh, you know what? There's a setting. There's a setting. I just have to figure it out. No, there we go.
Hey.
She's there. All right. Our Hackster crew is here. And Paul just dropped out. I don't know if you got to see it. Ginger, I know that you did, but he was representing his Hackster shirt was on.
Yeah.
I saw that.
Okay. Awesome. I'm glad you guys got to see it. And thank you, ladies, for joining today. I'm super excited to close out Imagine. It has been a great 3 days of content. You were all there in Mountain View on site Wednesday. I was there as well, but I had to take a quick trip back home. So I'm back in Phoenix now, but I feel like I just saw you. Well, actually, I did just see you. So thank you for taking your Friday afternoon with us. We're gonna do a community fireside, community hangout. I'll give each of you a couple minutes to give some introductions. Who wants to go first? Alex, you're going first because
I
you're
can
on
go.
the top.
Did you say
because you're on
introduction?
the-
Sorry, I was sneezing.
Yeah, you were sneezing. Yeah, just a quick
Take a minute.
couple minutes to
I did a quick
introduce
reboot there,
yourselves.
you know.
And you can introduce yourself and the guest who's on your shoulder.
Hello, everybody. I'm Alex Glow. I'm the video host and hardware nerd at Hackster. I'm not the only hardware nerd there, but
No, you're
many years ago, 2014, I joined as like a community builder, manager person, inviting people on the first few platforms onto our site, and now we're excited to have Edge Impulse on there. Y'all do amazing stuff, and I've been having a blast. But nowadays, I do more of the video stuff, and I was running around with my camera. Can't wait to share what we saw the other day. And I build weird stuff and make open source tutorials. As you may know, we are an online community for open source hardware developers, bajillions of tutorials on everything from wearable tech to robotics to smart homes to smart vehicles to agriculture to industry to everything. And okay, getting excited. But yeah, and this is Fenrir, who's one of my projects. He is a little Fennec Fox robot that I could make his motors go, I guess, who, as I said, is modeled on a Fennec Fox and was originally designed as a sort of demo project for OpenVINO, an AI platform with a distro by Intel that we've also been hanging out with those folks this week. And yeah, so I do projects, tutorials, teach people how to use new technologies, do unboxings and intros, and also get to interview a bunch of cool people, including some people who showed up here at Imagine this week, and some who will be there in the future.
Yeah, we did some good filming. It'll take us a few days to get it edited, but we saw some really interesting stuff there. So I'm looking forward to it.
Stuff.
Yeah. Ginger, do you want to go next and say hello?
Sure. We'll leave the best for last. Hi everyone. My name is Ginger. I'm the current contest manager at Hackster. So I see somebody gave a shout out to all the cool contests we have on Hackster.
Nico, who
Thanks,
gave that
Nico.
shout out. And Alex, check
Yes.
your email for an intro to him.
Oh yes.
Yeah, and thank you. So I also come from open source background, open source community background. I was the community manager at for a drone software called PX4. Traveled around the world, arranging, like developer events all the way, from meetups, to big conferences. Really enjoyed that. Before that, I had my own hardware startup. Also, I think I was around that time met Hackster's founder and put our open source tutorial on Hackster. And yeah, I'm really glad to be here, with Jessica and Alex and David, to chat with everyone on community. It's my favorite topic.
Awesome. Thank you, Ginger. Jessica, last but not least, give an intro.
Here I am. My name is Jessica, and I run the business side of Hackster. So a lot of what I do is not out in the open. I'm not as visual on camera as Alex and the Gingers of the world, but I'm behind the scenes pulling all the strings and creating partnerships with all these awesome companies that joined the Imagine conference this week, and finding ways to bridge the community with the technology that exists in the world, and creating opportunities for the community to get access to resources, showcase the work that they're doing, and then finding ways that together we can build the next big thing for the future.
Awesome. Well, thank you, ladies, for joining. Like I said, to close out the day and honestly the week, I wanted to have just a fireside kind of chat. If I was still there in Mountain View, I would have just come up to the office and we could have all been on one stream. I don't know if you have enough chairs in the office, but we could figure something out. We'll make it work, but this is going to have to do.
Honestly, this audio is better.
This is better audio.
Yeah.
All right, hold on. I also noticed I'm not quite on brand, so let me get my.
Oh.
Okay, now I'm on brand. There we go. That's
I meant to
better.
use my awesome Edge Impulse tumbler that I got at the event, but
You got a tumbler? I didn't even get a tumbler.
I should be.
you gotta grab one of those gift bags, man.
Oh,
I need to be
Hey, look
on
at
brand.
It's amazing.
See, all of us are co-branding.
Yeah, totally. We got all
supporting each other.
Yeah, well,
Shameless
we've
plug,
all-
shameless plug.
We all totally rated each other's swag bags, is what happened. So, all right. Well, Jessica, we didn't have a chance to go through sort of a dry run, so we're gonna have to wing it. But
Let's do it.
Oh no.
I have a couple of questions that, I guess topics for conversation, not so much questions, but bullet points that you had come up with a few weeks back. And I thought I would kick us off with those. I want to pick your brains because the three of you, honestly, are the best in the business, the foremost subject matter experts on the planet. And I want to talk about the importance of dev communities for brand loyalty and user adoption. And I know that that's rather open-ended, but I'm just wondering, what kind of observations, what kind of experience, what kind of thoughts on the topic related to loyalty and adoption that a dev community, and why that's so important? And who wants to go first?
Yeah, I mean, that's what open source, obviously community is the lifeblood of open source. Like, it doesn't matter if it's open, if there's no one to pick it up, then it might as well be closed. It's sort of like, there's stuff that's on the edge where it's like Tesla open sourcing their patents for, car batteries and stuff. And obviously not a lot of us are going to be able to use that, but by open sourcing it, that means that the people who do have the drive and the ability, or even, want to build out their ability to create those things for their own aims, for helping solve the world's problems, will have the ability to do that. And so obviously we're facing a lot of challenges globally. One might say more than ever, but they're always changing. And with the fact that there's so many humans with so many ideas out in the world, that no matter how much things change, there's always going to be some people who are out there thinking about those problems that are coming up now. And open source allows us to reach those people, not just the people who are employed at your company and that are on your payroll, or people who can sign NDAs and stuff, but it really allows us to take advantage of all those minds who are out there in the world, people who are already passionate. You don't have to convince them to work on this. You don't have to necessarily have companies pay them, people who are will found their own companies to solve these problems, and we're just feeding that by putting open source materials out in the world. And it really, honestly, it's like a supercomputer made of billions of smaller computers all linked together for a common purpose, and like tiny little supercomputers being spun up all the time spontaneously to solve this problem, that problem. We've got the Impact Summit coming up around air and water pollution, and that's going to be a subset of these people, but everyone can find their niche and find the tools to jump on those problems. And as a business, you're able to capture those people's loyalty because they see that you're really walking the walk and really giving something into the world that's not just profit motivated. And there's lots of other reasons as well. You know, I'll let my friends speak on that, but yeah.
Thanks, Alex.
Yeah. I would say from a business perspective, companies that are represented within a developer community, one of their biggest priorities is exposure, right? You know, no one knows what they don't know. So when you're in a community of like-minded humans, as Alex said, a very passionate people who believe in a mission and are already excited and curious about electronics and hardware that is either existing now and want to know what people are doing with it, or it's something that's totally brand new and they want to know what companies are innovating on. You're getting exposure as a company by existing within that community. And then by providing opportunities where people get their hands on your technology by doing a contest or a workshop, a hardware giveaway, you're giving them the opportunity to start to tinker with that product. So in their day job, they may be a double E who is, you know, within product design, and their boss comes to them and says, hey, a customer is asking for X solution. The first thing that's going to be top of mind for them is the last thing they worked on. Right. So if they're already familiar with, let's say, a particle board or, you know, an Arduino board or the latest Xilinx FPGA product, they've been taking workshops on it. They're familiar with that. They've built an application. And so that's going to be top of mind for that. And they're going to bring that into whatever their day job is. Right. So you're feeding into that brand loyalty and the product adoption by providing the opportunity for them to be exposed to it.
And the same thing goes for students, both people who are hobbyists from their day job and students. And Ginger has been doing some really cool work with universities that, you know, once those people enter the workforce, they already have these skills based on the open source tech that they've been playing with in school or like learning on in school. I shouldn't just say playing with, like it can be really serious people. But Ginger,
You're on mute, Ginger.
Oh.
Yeah.
She knew that. She knew it.
Yeah, and I think a huge part of it is in terms of just with a lot of like more modern tools, you know, that was invented, you know, just even recently, like, you know, like GitHub and stuff. It just, you know, the collaboration is amazing. So, you know, I like a huge part of my life is, you know, it's really related to NASA like PX4, and itself, I think is a pretty amazing story to share as an open source success story, where it was originally just, you know, like hardware and software that university students built for their competition. But the original team, they open sourced both the hardware design and the software, and it got just worldwide adoption really fast at like, I don't want to say zero marketing costs, you know, but basically, you know, it's like a volunteers, you know, and collaborators, you know, from all around the world who adopted the code, and because they made it open and free so that people can build on top of it. And so, you know, like people can focus on, you know, not reinventing the wheel, but actually contribute to that part. So in the end, like where it is actually nowadays, you know, if you look at PX4's GitHub, it's built by, you know, more than 300, you know, different like developers from around the world, and nobody have like a sole dictated like ownership over it. And then actually throughout all the years that it's been developed, some big companies contributed, like Intel at one point in time, you know, like contributed to it, Qualcomm contributed to it, and actually a lot of also company startups contributed, but they probably fail. But itself as an open source project lived on, you know, like throughout all these time. So I think that's where a lot of like the brand loyalty, and why a lot engineers, you know, like really also push for a lot of companies adopt the open source strategy, you know, even in their just technology in their tech. It's like, okay, you know, if this company, especially for drones, that's like so new, a lot of companies can fail, and they want to be able to actually make sure that the work they have worked on have like a longevity. So you know, they contribute back to the main open source project that, you know, gets re-nurtured with the whole ecosystem, with the whole developer ecosystem. So itself, it's a, you know, like quite amazing in terms of just, like how technology, I think, nowadays, even sustain itself and grow.
Yeah.
That's a
And
good
not-
point on. Oh, sorry, go ahead, Alex.
Oh, sure. Not to hog it too much, but I gotta mention right here, taking off what you were saying about Jones Ginger. I interviewed Ramon Rutre for our channel on the Hackster Cafe recently, and he mentioned this blog post where it's really open source. The only way upward is what it's called. I've dropped the link in the chat, and talking about how interoperability relies on open source, or it's really fed by open source, and so like, this business and that business all are able to work on a common ecosystem and make all their technology work together. And so Oterion and all these other companies that have been featured in this blog, let's see, Freefly Systems and Watts Innovation, they all work together. They're all feeding each other's communities. So, my community works with your community, works with your community. People are able to adopt this one ecosystem, and there's already tech that's made. It serves the users and it serves those companies because they all, it's a natural choice for them to use your company since it works so well with the other technology. And that's all thanks to open source.
Yeah. And the last point I was going to make on that was just with brand adoption, with that open source solution Ginger had mentioned, everybody's feeding into a single thing and adding to it and evolving it and making it better. One thing with brand adoption, then you have a solution that someone can then customize for the exact need that they have, right? So it could be a very generic thing that it began with, but then, you need it for something very specific. So you can tinker with that and evolve it into your personal need for a customer that you have, or a space that you need a tech solution for yourself. If you are staying agile in that sense, then you'll get a lot more people using that because they know that they have a little bit more flexibility in how they develop it.
Yeah, so even for like for Linux Foundation, right? Like Linux Foundation, we went to their event like this summer, and you can see a lot of like the big companies like Microsoft, like the big name like Google in China was like Baidu. They all actually contribute to open source projects, and they actually now, I think within their organization even have like KPIs or metrics in terms, of how much to actually give back to the larger ecosystem.
And when you're open source, when your company is open source, you can take advantage of that as well. So you get the Intels, the Microsofts, the other big companies that want to jump in, and they win by having feeding the tools that they rely on to make sure that they stay alive and stay up to date. And then they also get to meet their KPIs like you were talking about by contributing back to open source. And then everyone else gets to benefit from these large companies investing in these tools. It's so good.
David, did you have any other questions?
No,
or
you know what?
We're just kind of riffing on
though?
this, honestly.
The thing is, but that's perfect. There's two things there. That's exactly what I wanted, was for us to just get together and have a chat, because I know that you are literally the best, the foremost experts in the field. And that's exactly why I wanted to have the three of you join and have this chat. You know what? Just allowing the three of you to brainstorm and carry on that kind of a conversation is incredible. So no, and then the second piece of that is no, I mean, you've really nailed it, right? Between the three of you, you have summarized succinctly everything that it's a template. I mean, you gave everyone what they need to know, why companies should be, well, I mean, investing in their dev community, because it's an investment. The brand loyalty, the user adoption comes along for the ride. But the same way that I'm in a position here at Edge Impulse to empower the development community, I mean, you just explained why that is critical and crucial. So no, I appreciate it. Any other thoughts on that topic specifically? Importance of dev communities for brand loyalty and user adoption?
I would make one additional comment, because I get this a lot from companies who are not familiar with how to work with dev communities. And there's a misconception with a company trying to get more involved in a developer community is developer communities are not free R&D ecosystems. They're not used to come and not pay people for work that they're building on a specific technology. And I think that that's important to say out loud to a lot of companies that come and go, oh, well, I'll just host a contest and then I'll get 50 projects that I could sell to customers. That's not why we're here. And that's not why developer communities exist. And that's also not, you know, there's no argument behind open source or the concept of open source that should contribute to a big company coming in and throwing, you know, a couple $1,000s down and being like, okay, I'll just, you know, take all of your IP and all of your ideas and then I'll go sell it and make money. I think that it's important for us to point that out while we're talking about dev communities.
Yeah, I have another one that we didn't quite cover yet, I think, which is that, you know, when you're at a company, you know everything that your project can do. And sometimes it feels like if someone asks you what you can do with your product, you're like, well, I can do anything. You know, it's got infinite power, unlimited potential, because you do see it that way. And because, you know, it's true to you, and it may be true, but like when someone who comes in who isn't familiar with your technology, that can actually be really intimidating. Like, I have a blank page. What do I do? Like, just give me somewhere to start. And so having people's projects out there gives them all these examples. I think I was going down the line of a bunch of different ones with OpenVINO yesterday, where it's just like, you know, maybe I shouldn't be mentioning them. I don't know. But
I mean,
it's been quite a week.
We're talking
also,
ecosystem. It's fine.
I was wandering around, you know, your demo hall and seeing Sean's toaster and seeing Renaissance's little rover and seeing all the different applications that people are building with these. And it's more inspiring than saying the potential is infinite. That's terrifying. What's really exciting is seeing all these different ways people are already using it and how I could build off of that to build something that's suddenly sparking in my brain, like, oh, I could take that and turn it into this thing, and I can use this tool that's already out there. And it gives people these concrete places to start, so that they're able to actually adopt. Once they're already excited about your thing, they still need to have a place to start. And so it really helps them get that sort of on-ramp. That's it.
I
rant over.
No, it makes a lot of
really
sense. Inspiration is like the key word that sort of comes to mind right there.
Yeah.
And I really want to bring up like a point in the global aspect of Hackster. And I think, you know, like one of my key favorite part of also about, you know, I have a Hackster community is that we're global. So actually, when like 30% of our, you know, like developers, you know, are based in Asia, and the other 30% Europe. And then, you know, we have developers from Africa, from South America, all over the world. And when you have the same piece of like hardware, or even like you think like the documentation is like so well written or like whatever, that might not be the total case actually on another side of the world. And for me, you know, sometimes to think about that, we have a platform and a community actually where we know, you know, like let's say how a piece of hardware, you know, like functions or whatever, you know, like on another side of the world, and sometimes see that kind of like a localized innovation, to me is super empowering and inspiring. And you know, like actually during Imagine, one of my favorite session was the impact panel. Their impact panel.
You're jumping ahead. That was going to be my next talking point, but you know what? That's okay. That's a good transition and segue, because I do want to talk about impact. So go on.
But yeah, that impact panel, you know, like there was you know, like the Elephant Edge project, you know, was brought up, and that was one of the contests on Hackster. But you know, like it actually happened before I joined Hackster, but it's probably like one of my favorite thing that I always you know, like rave about in terms of just, you know, like real technology at work out there. And it's just even something like, you know, like communications technology, you know, but how that works, let's say here in, you know, like United States, is a totally different scenario in Africa. So, you know, and that's even more important in terms of, you know, that kind of like learning and sharing, you know, via the open source way, you know, not so much also about free, but it's just whatever is accessible, right? You know, we can share as a common knowledge to exchange, so that, you know, like in the other part of like the world, they can reference it and then innovate faster and less barrier to them. So I think, you know, that's also just, you know, like a huge aspect of what we do that makes me really happy to be here, and yeah.
If I may take off with that, there was another person on that panel, I think you might have referenced her, Kate Calo of the Maya project, or Mara, I forget. But talking about how, you know, she was sitting in New York doing stuff from there, but then she ended up realizing that she needed to be on the ground in Africa, working with people there, because it's not only about, like, you know, people like to think that, you know, in hackathons in Silicon Valley, we can solve all the world's problems from there, just like sort of being like, oh yeah, you know, I know people have this problem. Here's a thing I came up with to solve it. And that's cool, you know, that can be read. And but a lot of the times the people who are best equipped to solve a problem are the people who are on the ground with the daily expertise and experience with what they're doing, and what they build there, sort of as the counterpoint to what you're talking about, Ginger, bringing, you know, stuff from one place to everywhere in the globe, at the same time bringing solutions from everywhere in the globe and helping us all solve each other's problems, instead of it just being centralized in these sort of hubs and locuses where you know, there happens to be a lot of funding and a lot of, you know, resources for technological development, bringing that to everywhere and having experts in their fields, you know, become experts in AI and ML through these tools and bring their solutions, which they're able to iterate on rapidly and inform the rest of the world about what they're developing. It amazing.
You know what's really cool? Because we say we're global, and it at a certain point you say it so often that it feels like more of like a marketing shtick. Yeah, we're global. We have people everywhere. But the really cool thing is, like, we do a contest where we're giving away 100 pieces of the required hardware, or the featured hardware of that contest. And people submit their proposals because they want access to that hardware, because they want to participate in the contest. And then all the proposals are selected by the hosting company. And then we export that list to send to our warehouse to start arranging shipping. And you go down the country list of everyone who received hardware for their proposal. They're based off of what great idea they had for what they wanted to build. But then you look at the diversity of representation in that list and be like, oh my gosh, we're literally shipping hardware to every nook and cranny of this planet, and equal access to that hardware for that contest, because we truly believe that being a global platform gives us a unique opportunity to provide that hardware and that opportunity to anyone, regardless of where they are, because they're making an impact locally where they exist. And it's just really inspiring, I think, to go through that list and be like, holy crap, man, we got everyone everywhere. This is so amazing.
Yeah. And even talking, like sometimes like talking to those people are like brings out even like more joy, because like some of the hardware that's like really easy for us to get here in the US, or, you know, like in China is even like more ridiculous. You know, you can get it, you know, with a guy that comes down on a bike, just, you know, like sending you this, like, yeah, because in China they have this this Taobao thing that yeah, when I moved back to US, everything slowed down for like 3 times. And you know, but then, you know, I remember, you know, when I was in China, and where I would talk to, you know, developers like from Cyprus or something, you know, for them to get that type of hardware, it would take them 2-3 months, and sometimes get stuck, right, you know, at like customs and stuff.
Oh,
so
yeah.
Yeah, so it's
we all know.
We all know that one. Yeah.
And yeah, so, you know, just in terms of you know, I think a lot of like when we're talking about developer community, especially global developer community, to have that kind of cultural empathy in terms of just, you know, like things might be really different, right? You know, in Africa, like how someone would appreciate something that they just, it's like the first hardware in their whole continent. That's literally like what one of like the ambassador, you know, told me. Oh yeah, we love Hackster because, you know, back in 2017, you know, like when we did the AWS dot thing, those were like the first dots, like in our country or something like that. And so that kind of, you know, just giving accessibility, you know, to more people, and really to be able to enable that, you know, I think it's just so important, and a big part of like what we do.
Equal accessibility, also equal representation on the website most of the people that exist on Hackster are an avatar of some sort. We don't know exactly who they are, and they're not being judged by where they're located, and they get the same representation. You know, they get an entire community hub or a tiny startup and a giant company, Microsoft, Intel. They all have the same access to the free resources on the website, and we promote them just the same, because no matter how big or small they are, they all have probably some brilliant idea and the dedication and passion towards making a difference. And so that's important for us to give them a voice.
Oh yeah, and constraints breed creativity. People who live in places that have a harder time getting stuff shipped to them. We've got all these people in the comments being like, customs.
Yeah, they all know the pain too.
Yeah, I talked to Ahmed Oyenuga, the creator of the pick and place wheel, which I'll drop in the comments here as well in the chat. Who was talking about how he created these 3D printed ball bearings, bearings for his, his Almsville dial, which is a really cool little controller, and the pick and place wheel, which helps you with, manual assembly of PCBs. And he created his own 3D printed bearings for that because it was hard for him to get those shipped. And so he's coming up with these amazing, now I can use that. I can go and use my 3D printer and 3D print some of his tech based on those innovations that he's made. And that's something that I wouldn't have come up with myself, partly because I just don't have those skills, but also if you do live in a place where it's really easy to get ball bearings shipped to you, you might not think about that. But then you're like, why should I wait like even 2 days? I can just print something based on his design, and it helps all of us accelerate our progress.
So cool.
Awesome.
Yeah, and make sure you host the project on Hackster.
And put it on
Oh,
Hackster.
yeah.
That's interesting. I mean, even something as simple, I take for granted something as simple as a ball bearing, but I should not take that for granted, because clearly there are people out there that is not readily available for. I want to take one quick second, though. You may have noticed that a wild Sean Hemel appeared for a moment.
Yeah.
He actually has a very, very good question. And rather than just have him like type it in chat or whatever, I thought, hey, Sean, why don't you just come on in here and ask the question?
Nice.
So you did see a wild Sean appear, but he has now returned.
Sure, it's him. Sean, where's your
Can't
photo?
recognize him.
It's not actually me. It's a doppelganger.
You're
No,
evil
I'm sorry.
twin.
I'm sorry for popping
Yeah,
in
it
earlier.
doesn't look like that 2 days ago.
It's
I
fake
know.
Sean. It's an AI generated model.
I blame it on David, because I was like, oh, I've got this question for the Hackster folks, and I was like typing it in. David's like, you want to come on? I'm like, yeah, I look like a bum because I'm just like recovering from the in-person event and traveling, and I'm
I
just
thought
like,
you like slept in your bow ties.
I
Don't
need-
you have
I
like a
need-
silk one that
oh, that's like from How I Met Your Mother with like the sleeping suit. I need like the
talked about this
sleeping
the other
boat.
day.
Yeah, I know we do need it. You do need it. Okay. Anyway, keep it on track. I won't take much of your time, but I love the presentation. I love what Hackster does. The idea of project sharing, and you're talking about open source and contests, and all these things are things that both Hackster does and you do with you try to like connect companies and the developer community and provide all of this. And my brain always goes back to this idea from a marketing perspective. We're building trust with our users, right? We're trying to build trust, not just like the flashy billboards of yesteryear where it's like, look at me, right? Like drink Coke, the polar bears are cute. No, it's really like, we want you to like us. We want you to be
polar bear.
It's amazing ads, but it's so like 80s 60s Mad Men style of like, oh, what's catchy, right? It's really about building trust with your community. So Hackster does a great job with making sure things are open source, the project sharing, the contests are fantastic. Are there any other things you can recommend, especially to companies or anybody who wants to like start a company, build a community? What can be done to build that trust? Does that make sense?
Yeah, well, a lot of it comes down to, having people who are experts talking to experts. There's this very long-standing cliche of like, you go to a trade show and all they have there is marketing people, and you're like, let me ask you some questions about your product, and they give you like a rehearsed spiel that has nothing to do with the question you asked, and there's nobody there that you can talk to. And so, we're sort of like that trade show, only it's always going on. You can communicate with people in lots of different ways, including like discussions on your not to be like too sales pitchy, speaking of which, but like we do have all these different ways that you can communicate directly with people, and we really encourage companies that are running contests to get into the trenches in the discussion areas where you're answering people's questions hands-on, where you have, you know, office hours where you can have people talk directly with people who know, who want to talk with your developers and your DevRel people, your FAEs, whoever's going to help people actually build what they want to build. And that's a lot of where the trust comes from, right? It's not just a spiel. It's not just like oh, it's shiny and new, you know, you want it because it's shiny. You know, I really have appreciated the deep dive this morning at Imagine that Jan and Dan and I think Matisse did with all the new features and stuff. Oh yeah, we got to get that call back in. But yeah, they really did a really solid deep dive, which helped me kind of integrate the stuff that I saw people talking about on stage the other day, but it was kind of really rapid fire. And now I'm like, oh, that's what that means. I might actually be able to go and use it. And also, like, those people obviously know their stuff. They're showing me, they're walking me through it, and they can answer questions cogently. So I trust them to help me if I need some help with what I'm building.
So it's not just the, like, you know, the Steve Jobs walk on show the iPhone kind of thing.
Yeah.
It really is breaking
And
it
we
down.
know that a lot of that stuff was kind of faked. He like had a very scripted walkthrough because if he went off that track, it was gonna explode.
I mean, that's the Windows demos, right?
I love about live demos. We do them on the cafe sometimes. And you know, I love it. I love it when people's live demos go wrong because it's like it's authentic, it's real. And then you can see their troubleshooting process.
Yes.
That's the most fun part. They're like, if I ran into this problem, okay, there it goes. And then we got to go and like walk through it. And maybe it takes like 5 minutes out of the interview, but that's sometimes the most interesting part.
Yeah, you bring up a great point, Alex, and it's authenticity. You said it, authenticity is huge. So being honest with your developers, I think, is huge. Like, show them your pain points. Tell them, like, hey, this part really isn't working yet, and not just like gloss over and it's like magically solves your whole problem. Like, work with them. They want to see, right? Developers, right? I don't know about, you know, the executives, customers, sales folks. That's a different. Where we're talking about the developer community.
We
right?
know it's not magic. You can tell it's magic, but
it is duct tape and glue.
Yeah, if you tell a developer that it's magic, they are going to be so skeptical.
I want to break this
sliced bread.
Yeah.
Show me.
And I think a lot of people coming from like more like clean corporate side, you know, sometimes get like really anxious when they see like a really messy like makerspace, right? You know, or that kind of like cleanness. You know, like it's like, you know, like I think hackerish. I mean, not every hacker, but a lot of hacker, you know, also probably have like ADHD or whatever. But I'm sorry, and it's like, but I do think, you know, just being able to be more open, you know, to.
Sorry, now sorry.
Alex's desk.
This is the stuff behind the stuff.
Goodness
and
gracious.
it's supposed to look like that. I mean,
It
there's literally, you know, I think there's also it's like kitchen, right? You know, a home that has warmth is actually a kitchen that gets used, not a kitchen that's just so clean. And you know, so I think. So for me, you know, for in-person event, if like people really, if a lot of like corporate really want to know like where to get started to develop, I mean, I always tell them, you know, organize a hackathon, you know, like do like even like a hackathon, you know, like a one or 2 day thing, and just interact, you know, with you know, like with the developers directly, or even join a team, build something together with, you know, within like 24 to 48 hours, you experience that, and then you really understand what these people are, just on a human level, you know, like at the end of the day, we're all humans. So it's just
most of us.
Yeah. I'm trying to become an AI. I actually played an AI.
Well, you know, we could probably do something about that between Sean and the rest of the team. Not so much me, but I think they could create an AI version of you, Ginger. I think they can do it.
I want to be teleported onto an edge device, right? You know, like, right? You know, like I want to be in Edge Impulse Studio, like, you know.
But coming back to the trust thing, actually. Sean is a great person to talk to about this because you're building your own projects, and I know for a fact other people that I know in the maker world are talking about how you're helping them build what they want to build as well. There's this collaboration going on, and that also builds trust. Like, you're building your own projects, you're sharing your process and being like, I'm getting caught up here. You're doing this exchange with other people. And honestly, as a bit of an introvert, it's kind of the hard part for me, but like I see it and I'm like, Sean's the real deal. He's like, not only like through your company lens, but also personally, you're involved, you're really living it. And I can see that, like with Oddj, another amazing robot maker, you know, you guys have been collaborating on some stuff, and it's like, yeah, you care about helping people get their stuff off the ground, and are open to you know, asking for help from other people as well, which is very authentic.
Yeah, and not to pat ourselves too much on the back, but your stuff as well, Alex. Like your stuff is amazing. Like you post your struggles, you show what you're doing, your process, your videos are so much fun, lots of energy.
The struggles.
It's like you bring the passion, you show the struggles, like you have the amazing storytelling built into yours. Where mine are usually like more
guys.
Yep. It's usually mine are usually tutorials, right? Like I don't do the like cool art projects, but I like love you. I love Oddj. I love the people who like take them to the next level of like, show me that art, show me the product, show me like it doing something cool. And I'm like, look, we blinked a light, right? But
And
like,
you're excited
hey.
about it. So you're like feeding back into it. And that gives everyone else energy. There's this really real sort of positive feedback loop that happens.
Yeah.
Okay, I feel like I need to come in from the business side.
All right,
Yeah.
Okay, Jess, what do you got?
Spoil all our fun.
I did say the dirty word maker, which sometimes
You
businesses
did.
are allergic to that, and I wonder if you're gonna.
Oh man, that's a whole nother topic we should get into.
We can talk about that forever.
Oh, we didn't
that major term.
open source and business. It really is helpful.
Yeah.
But sorry, Jess.
So from the business side, because Sean, your original question was, as a business, how do I build more trust with the developer community? And I think what we see a lot of times is for companies that are not 2-3 person startups, they come in and they may have resources available. They just want to better understand the developer community or be represented within it and get feedback on a product or get brand exposure within that community. I think the first thing that a company really needs to understand when they're getting introduced to a developer community is their own intentions and expectations of what they want out of the developer community. Companies come to us and they go, we want to run a contest. And I'll go, why? And they're like, because we want to get our name out there. And I'm like, that is not the way for you to engage best with the community. If it's just about, you know, representation for your brand, place an ad, you know. If it's actually building a relationship with people, you're giving them your product, and then for the next 3 months, you're hand holding and teaching them how to use it and giving ideas for applications and providing trainings on that. And that's a very personal, in-depth, you know, journey with people who are getting exposed to your product and your brand. Then do a contest. If you have the resources and the team available to provide that level of support, then a contest would be right for you. But if you don't know why you're spending money or time or bandwidth or real estate within a developer community, then you're never ever going to feel satisfied by existing there. So I think that's the first priority for any company coming into a dev community is just, what are you expecting to get out of it?
Yeah, and like we mentioned before, the fact that, you know, if you're not ready to commit developers' time to answering questions and helping support people in their journey, then all you're doing is like throwing free stuff at the community, which can be good. But also if it's something that's a little bit more proprietary, that runs well on certain systems and not on others, that maybe have a few kinks to work out, anything like that is going to destroy the credibility. But if you put in the time, you know, like Jessica said, you know, if you don't have the time to put in, you just run an ad. But if you are really interested in engaging with people, and also what you said, Jessica, about feedback, like it's not about just being like, we have this thing, here you go. You know, there's got to be that curiosity about like, how will people use it? You don't necessarily know what it is that people will find the most compelling about your product, or what the best use cases they'll find for it are. That's like a huge part of the point of running a contest, is to be like, what are the possibilities that we haven't already scripted out? And that openness to hearing what the community is actually interested in is such a huge part of that credibility.
Yeah, that's such a dramatic difference between just placing an advertisement, you know, some banner ad
value.
somewhere or whatever.
Yeah.
Okay, fine. Maybe I see it, you know, I recognize it. I mean, I know about a Coke polar bear, but that's a dramatically different experience than I want to see users take the product and give it a try and then capture feedback and lessons learned and see how it's being used, interacted with. Like that's a whole different perspective.
And Nico in the comments brings up a good point: is don't abuse your customers or your contest entrants.
Yeah.
Do you want to talk about that one, Alex?
Yeah, that's where open source comes back in again, because another benefit to companies is that like there's all these different interesting things that you could your product could integrate with, coming back to interoperability. And but developers who are there's always going to be like a small community, like even just 2 or 3 developers who are obsessed with this one thing that they want to connect to your product, and might end up like writing an integration for that. And that really helps keep it alive. So Nico mentioning that, you know, there's companies that basically abuse the community to build their product or restart something from years ago, but don't want to write the examples, don't want to add functionalities that they don't want to spend resources on. Take a breath. But that's, you know, when you do it right, then you may get people who are voluntarily building that stuff. And of course, the other side of that coin is you do have to like do them the honor of recognizing them and doing them the honor of supporting them, and it will be really fruitful.
Yeah.
And if they're like building an actual product out for you or a very specific project that you're requesting, pay them for their time and their expertise.
Yeah.
Oh,
absolutely.
That feels like a no-brainer, right? You're asking them to provide their time, their skill set, their own knowledge to create resources for a project, to even create educational resources for other people to learn from that content.
Yeah,
absolutely.
They're
I mean,
an expert. Pay them.
Folks have, yeah, you got to. You know, folks have a job. They go work throughout the day. They have things they need to do. They have family obligations. They have, you know, kids, wives, lives, sports, activities, whatever. And you're going to ask them, the husbands, kids, wives, I should say wives, husbands.
This is generic.
And they
Who's trying to rhyme?
Have kids, wives,
I'm sorry, I
lives.
derailed you.
No,
They have these obligations.
But they have obligations, and it's you know, it's a big ask to then say, and I run into this quite often when, you know, our Edge Impulse ambassadors and experts, they want to build a project, but they have limited hours in a day. And I go and I set an expectation up front with, you know, the hardware manufacturers, the vendors, the partners, and I say, now look, these folks are busy. It may take them time to build. It's the same thing. You gotta pay them and compensate them for the time, because there's only 24 hours in a day. Every single time I check, it's always the same, 24 hours.
Yeah. Dang it. I think it should be noted that that's not why we exist either. We're not a farm for companies to create content for. We're a space for engineers to be engineers, right? To get exposed, to understand what exists in the world, to showcase stuff that they're working on, to learn from each other, right? To try things and fail and fail again, and then try something new.
It's okay.
Yeah, this is a no judgment zone. It's a space for you to get exposed, to learn, to share. We're not a content farm for companies.
Yeah,
coming back to Sean again, you know, I mentioned
Ginger,
that you do collaborate with other creators and builders and stuff, but again, like that's something that shouldn't necessarily be expected of people unless they're being like, you know, compensated in some way or other. However that works out, it doesn't have to be, you know, free hardware. It doesn't have to be money. It doesn't have to be, although money is good for everyone. That's the universal, you know, but definitely pay people for their time. But at the same time, like, it shouldn't necessarily be expected. We've seen this in the software community where more and more people are expected to have like open source contributions on their GitHub profiles. And that is an accessibility thing. That is a a thing about privilege where, you know, if you have the free time to
Yeah.
do that, if you don't have as many obligations, if you're not working multiple jobs, if you're not taking care of loved ones and stuff, then you have more available time to do that. And we recognize that with the contests and stuff, and we do actually often end up like extending our deadlines to make sure that everyone gets a chance to contribute. And so like working with people as people, I think, is what a lot of this stuff comes down to. Like, we're all humans and we have creativity and passion and drive, and also we need to eat. And you know, we've all got curious minds.
Yeah, it's so true. And Jessica, you made a point a while ago about the idea that you know, understanding like we're building trust with a developer community, but like not necessarily all businesses are going after developers, right? Like, I guess that's first and foremost is like understanding who your audience is.
Yeah.
So yeah, if you're not a developer focused company, like, is this the right choice for you? So I guess answering that before you even like post a contest, right? Or do you see other
Yeah.
companies that are not dev focused, right?
Well, I think Hackster and who we are, it's not necessarily a community of developers. Granted, the majority of the people, the persona of a Hackster user is a developer, a self-taught or by training. But we also have other resources on Hackster to expose people into what's happening in the world of technology. So a Hackster user might come onto the website and they might be a product designer. They might be, you know, a C-suite person who has no engineering background. I'm not an engineer. I'm not trained in engineering.
Yes.
Everything that I know is through osmosis of existing with all of you smart people. But
Me too.
there are people that are still curious about what's happening in the tech industry. So they might subscribe to our newsletter. They might read Hackster News on their Google news app on their phone. They might, you know, they just want exposure to know what's happening in the industry. And I think that some companies, if their expectation is we want brand visibility, or maybe it's a thought leadership thing where they want to be positioned in the tech industry to be known for their work within the sustainability side of things, then it's for them, it's more a matter of we want to make sure that we get the word out. It's not necessarily we're expecting developers to build with our product or buy stuff from us. So I think it truly is the question of what is your expectation by being present within this space of like-minded humans?
And Ginger, I feel like you'd have a lot to say about this just from what you're doing with contests. Like, this is a really key way that you interact with companies and with individuals as well. Like, what do you see?
You're muted.
Oh no.
Sorry, I keep muting myself.
It's good, respectful.
It's good.
I really love running the contest. You know, there's, you know, like when I actually first, Jessica, you know, approached me, you know, like with a position, you know, I was a little bit worried about, you know, there seems to be gonna be a lot of like really nitty gritty, you know, ops type of things, you know, but I loved actually the whole aspect all the way from start brainstorming at the beginning, you know, planning the whole campaign, you know, like with a partner, educate them about, you know, like the whole contest process, about, you know, like where you know, on the creative side, right, you know, in terms of, you know, like even, okay, this technology, you know, how do we you know, like market this, you know, to and get people to be excited about it. So from that until, you know, like usually you know, the couple months, you know, once, like, although I'm not there seeing like people like building their projects, but, you know, like you can kind of sense the energy that happening, you know, like in the community, you know, on the contest page, you know, when people start asking questions. And then what usually like most excites me is when people say, oh, you know, I run into this issue, and then later, you know, like they solved it, right, you know, and then they come back and share that. And then, you know, so you know, even they're competing against each other, but they are peer-to-peer, like helping each other. That kind of energy, you know, always amazes me. And yeah, you know, in actually talking about money wise, you know, equity wise, you know, like building project, you know, there we have quite some super users, definitely, you know, have won lots of prizes, and, you know, and actually use that also. I think, you know, what's amazing thing is you can use it as like almost like a portfolio, right? You know, I want like a GitHub portfolio, and then so you know, there's you know, if there are a lot of like smart people really leverage as a way to market themselves and become like really big like influencers and stuff. And I've especially, you know, when it also resonates me when let's say people from, you know, like outside of the US start doing that, and then they get actually paid, right? You know, by and they would never have that kind of opportunity, you know, if our online platform never existed. Because like they won't, you know, like let's say somebody in Turkey or somebody in Eastern Europe, you know, like wherever that is, you know, they would never have the opportunity to have such a great way to showcase their technical capabilities, you know, like through the documentation and the projects and then, you know, so I believe, you know, I think a lot of them do get compensated, you know, by a lot of like the different companies that we work with. So we always say, you know, we are kind of also like a cradle and a matchmaking platform, you know, for you know, like this kind of amazing relationships that happens.
Nice. Did we answer your question, Sean?
Did we get it
more than sufficiently. More than sufficiently. 'Cause like I'm a big proponent of like the original question was about building trust, and I'm a huge proponent of like marketers building trust with their audience, right? And whatever that means. And I feel like I kind of understand the dev community a little bit and what it means, but like, right. But if you talk executives, the Hackster OkCupid, it's like Hackster. Oh my goodness. The matchmaking. Yes, I love it.
Great. We're going to have a t-shirt with that on there now.
Oh no.
Yes.
Alex's brain's going.
Yeah.
We got to have quizzes.
No.
That's like the thing that they were really using to bring people around to it. I do actually, I did just give a talk on the 7 personality types of hardware developers that are like in Hackster and in the broader open source community. I'm going to be publishing an article about that soon.
Oh,
so
I'm going to take
I should make it into a quiz.
No.
Personality quiz.
It should be a BuzzFeed style quiz. Oh my goodness, I will take that. Oh my
We
goodness.
should integrate that into our profile, into the Hackster.
Yeah.
Yes. And then you just need Hogwarts style houses to go along with it. Like make up some phony thing. You're like, oh, you're this, you're this. Oh wait, did any of you all watch Owl House?
No.
Okay, real good. Alex, you would probably enjoy it if you like those like cartoon style things. I loved Owl House, but they have like they make fun of Harry Potter with the different houses, and there's like different covenants you can join. King, yes, somebody loves King. King is great. And so like you could have like the different like covenants or whatever instead of like a house, but there could be like 12, or like how would you say 7? There could be 7.
You know, I have 7 of them. It's the magician, the polymath, the alchemist, the challenger, the astronomer, the catalyst, and the
You're already done.
We already have it.
You already have
I
it.
tried not to overlap too much with like the
I want the
Myers-Briggs
7
stuff,
of them. I want the 7 of them identified on the t-shirt. So it'll be Hackster,
Okay, cool.
OkCupid, and then which of the
We'll come up
7
with
are.
logos, it'll be great.
Oh my goodness.
Yep.
Oh, that's
Perfect.
amazing. Oh, I can't wait for that article.
Thank you,
It just
Nico,
got
for
really
that
weird,
one.
guys.
Yeah. Well, it did get a little bit
That
weird.
took a hard
but,
turn.
This
you
one isn't
know,
weird, I promise.
let's come back for our last
Yeah.
3 minutes. I'm
Okay.
looking at the clock and it's 2:57.
Hmm.
So we got 3 minutes on the clock.
Do
Any
your worst.
well, any no, I won't. But any final thoughts? I'd be interested, you know, in a quick summary of, you know, what we've talked through over the course of the past hour. Anything you want to wrap up with, we'll go around. I mean, for me, I'm going first. I just voted myself
Oh,
first.
good. Yeah.
You know, I think for me, yeah, we didn't get to all the bullet points that I really wanted to cover. So one of you is going to have to get in a plug for Impact Summit.
Oh, yeah.
But you know, I think the biggest takeaway, really, Sean, thank you for bringing it up, was, you know, building trust and understanding the difference between marketing and the developer community and what you're seeking to achieve with it. I think I really learned a lot there. You know, Jessica, you said the very first thing you ask is, what are you trying to get out of it? Why? And I hadn't really given that thought. So that's my big takeaway.
Let's go in reverse order. Jessica.
Go next. Go ahead.
Is this
Jessica.
a shameless plug or
You get
what
both.
am
You
I-
get
Okay.
a parting thought and a shameless plug.
So my parting thought is my background is not in engineering. My background is in education theory, building curriculum and education theory. So when I joined the Hackster team, it was really important for me to find partnerships and opportunities where people can learn from each other and learn from the resources that exist. So it's my responsibility in my role at the company is to constantly seek that out and, you know, uncover all the resources that I can for the greater community to be a part of something bigger than just themselves. And so no matter why you're within the Hackster community, if you're there as a user, as someone sharing content, as a company that's just starting and wants exposure, or a big tech giant that you know, has something to say, there's a space for you within Hackster, and we'll try our best in our little tiny team to find the best way to connect you with the rest of the world. So that's my takeaway. My shameless plug will be for Impact Summit.
Yep.
Join us October 11th and 12th for our first ever Hackster Impact Summit, talking with community members, users, companies, everyone we talked to. Sustainability was top of mind for them. And so we felt it our duty to create a 2-day event where we're bringing together all of those leaders to host panels, lead a couple workshops, have demos. We have slots for spotlights where community themselves can come on and talk about projects that they're building, some announcements, 2 days, all virtual. Come join us. It's free to join. This year is themed around air and water. So check out the landing page. We'll share the link. And I hope to see you guys there.
Awesome. Thank you, Jessica.
Yes.
Sean, do you want to do
I don't
summary, or did we summarize
that's-
your entire?
all I'm gonna say is thank you for letting me jump in on your panel, like just completely impromptu to ask a question and like join for like half of it. So I appreciate it.
I
My
loved
summary is that Hackster is the OkCupid of the dev world.
That should be our tagline. Oh my
That's
God.
the summary. Wow. Wow.
No, I
wow.
love everything you all are doing. It's a great community, great site. So
Thanks, Sean. We love you too.
All right. Thank you, Sean. Ginger, you want to give us your parting thoughts? And do you have a shameless plug as well? Or did Jessica steal your shameless plug?
Well, we, you know, yeah, that's the, I think the Impact Summit, you know, we're all here for, to shameless plug that. But yeah, it's another one, shameless plug. This year, you know, Hackster just passed 2 million users, you know, on our site.
Congrats.
So
Holy
that's,
cow.
yeah, that's amazing. That's amazing number, you know, so amazing community. And, you know, we're really proud and honored. And that's why I think, you know, part of the motivation initiative behind this Impact Summit is that we are vendor neutral, you know, we work with everyone, and we feel like we have that fabric, you know, like capability in terms of, you know, bringing people together, you know, to talk about impact and to educate and keep like inspire, you know, like future innovators and people from around the world, you know, whether you just started with, you know, technology or like an expert, but, you know, like where we can all exert our effort in terms of, you know, think more about impact.
Yeah. I have a skill set. I have resources. I want to make an impact. How do I help? Those are the things we want to talk about at Impact Summit.
And we really have a pretty amazing lineup. It will,
Yeah,
you know, like
the names aren't up there just yet,
cool.
but they'll be coming in the next
Yeah,
couple days.
yeah. We ourselves, we are even, you know, like really excited about it. Yeah, so yeah.
Super cool.
So I guess I'll come back to the matchmaking thing. One thing that I don't actually think about saying that often, but really is an integral part of it, came up in this talk chat, where it's really about a feedback loop of exchange. There's a lot to be said about what companies get out of it and, you know, what they're trying to achieve, but also, you know, this thing about how your goal as a company working with users in this way should be to understand more about how they're using it. How you decided that people are going to use it is not always, you know, what people are actually going to find the most value in, or what you're building isn't always going to be what they really want from you. And so open source helps with that, but also, you know, that's sort of where the hack and hackster comes from, right? It's like a hack is something that is sort of an ingenious fix, or using something that isn't being used the way it was designed for. And what you get to do as a company is talk directly to those people and hear directly from them about how they're using your stuff in ways that you hadn't even imagined. And I think that's just like a huge part of it. And, you know, just like in relationships, it's all about exchange, and you got to listen to people. It's the same with like doing your company and doing DevRel. You got to listen to the people who are using your products, and not just like dump stuff out there and expect a certain ROI or whatever. It takes time and it takes listening, and then you'll both be so much happier for it. And so my shameless plug is, oh, come on, where'd you go? There we go. Hackster Cafe. So
Hey.
this is the weird, you know, backdoor view that I see, but
we see it.
bit.ly/Hackster Cafe. We have this weekly show where I get to talk to awesome people. Oh, let me put an HTTP on there. Every Tuesday at 10 a.m. Pacific, approximately. Get to talk to really cool people who are in the hardware space. And the last one was Sarah Maston. We talked about what she's going to be doing at the upcoming summit, Impact Summit. There's all kinds of amazing people on here and all kinds of amazing people coming up. We got Chris Gamble and Mike Sheets next Tuesday. And we got Kyle Wiens from iFixit recently. And it's just a joy of mine that I love getting to, again, I love getting to put my own technology out there, but I also love to be able to interview other people about what they're building and why and how, and like what the problems they're running into are, and the business side of it as well. Lots of people who have founded their own companies, and I'm asking them like, how do you do that? You know, how do you do what you do? I think it's really fascinating, and there's a lot to learn, and it's just a highlight of my week every week. So come join us there.
All right. Well, thank you, Alex. Thank you, Ginger. Thank you, Jessica. Thank you, Sean, for a special guest appearance.
I'm butting in to ask some questions.
David, you know, you mentioned that like you never, you just wanted to get us together to like talk about this stuff. We never really do this. We're always busy with the business stuff, and they're like, what are we doing next? And like, how do we do the thing? But like, we don't just sit down and chat about this stuff, and it's really been awesome.
It's been awesome. It's been, you know what? I guess I have another takeaway now, and I guess, hey, now I get to close it out. All right. Yes. But you know, you just nailed it. As I sit here and I reflect on what you just said, is we don't take enough time to do this, because honestly, we could have sat here for a day. You know, we had, Jessica, you had written originally a few weeks ago, those bullet points of things that we could discuss and things that we could talk about for this session. Mm-hmm. I only made it to the first bullet point. We only covered the first one. There's still 5 more. I mean, we could have, there's just so much to, you know, unpack and discuss and talk through. And, you know, I'm not going to keep you here for the next 5 hours. But the point is you're right. You're right, Alex. It's been great to just spend some time and do this. And maybe, you know, one of my takeaways is we need to do it more often. But so I just appreciate picking your brains. So with that said, I'm going to go ahead and close us out. Thank you, everyone. Thank you, Alex. Thank you, Ginger. Thank you, Jessica. Thank you, Sean. And thank you to all the other speakers who joined us throughout the day. I learned a ton. I had a blast. And that wraps up Imagine 2022. It, you know, started bright and early on Wednesday at the Computer History Museum, and it's ending Friday afternoon back in Phoenix, 1,000 miles away.
You got a trucker hat.
Yeah, she got a
so
trucker
good.
hat out of it. I don't even think I got
I wish
one.
I had one right now. This window is killing me.
Yeah. Well,
I have Alex right here. Oh, look at
You
that.
got Archimedes on there too.
yeah.
Yes,
Archie's
of
here.
course.
So, all right, everyone. I'm going to hit the end button. Thank you so much. Have a great weekend. And
Thanks,
if you have
David.
any questions, you know where to find us.
Thanks, guys.
Thank you.
Bye,
everybody.
everybody.
Bye.
Bye.